Hello again, guys. Good morning. I hope everyone is doing amazing. Today, we're gonna go crazy. No, not crazy. We're gonna go very well, and we're gonna do what? We're gonna study, of course, lead code, right? Um, yeah. So, um, yesterday, I created a skill that will boost us, like that will give us more CP. All right. Um, that's gonna be amazing, guys. Um, let me also bring this up, and also uh, actually let's do that, and also let me set up our, I don't know, right? Host, create a room. All right, let me also share the room code with you. You can also join us here. um, let's see. All right, now we're gonna do deep copy. All right, let me first copy this part. I will take a screenshot of this. um, we're gonna use this skill, and this skill will guide us, all right, to solve these problems under 15 minutes. And if stuff goes south, we will it will handle this carefully, and our cap is 30 minutes. And also let me start our this dictation application. That's gonna be awesome, guys. Good morning, Sergeant. We're gonna study lead code today, and this is the very first question that we're gonna solve today. So, could you please start our activate and start our skill for this problem? Come on, let's go. It's gonna be legendary, guys. It's gonna be legendary. It's gonna be legendary. It's gonna be legendary, fabulous, right? And yeah, inspectable, resolution, untangle. Yeah. So, all right, we officially started. We have officially started our lead code problem. Good morning. Clock's running. Let's not see the suggestion. All right. Good morning. Clock's running from memory. One breath. The pattern, the approach sketch. What do you traverse with, and what does your map store? All right. Um, the thing I remember from this question, like we need to do. We need to do um like a deep copy, and like I guess we can use what, the recursion. Like this is what I remember. And to copy, I mean to deep copy, like each node will have its neighbors, right? And those neighbors will have their neighbors, right? So so each node has some sort of list of neighbors, right? And our goal should be, I mean, traverse all the neighbors and copy them basically. So we need a for loop, right? We need a for loop, and our function, like a func, right? Our function will should get a list, like a neighbor list for the current node, and we should process, like in this for loop, we should process, right? We should process um all of the neighbors, right? and we should basically copy, right? But the thing is, we should do this copy mechanism like a DFS or something, right? I mean, like DFS means like a post order, right? Post order. Like this is what I remember, but it is all blurry. I mean, because the as far as I remember, when I first solved this question, I mean, I didn't manage to do deep copy, but instead only copy the immediate neighbors, right? Not all the um, I mean, like a subtree, right? Not subtree, but only child. Yeah, this is what I remember actually. Let's see, guys. Let's see how AI will, direct us. Like, we don't want it to give us the result right away, but we want it to guide us, right? We want it to guide us. Let's see. Let's have some water. DFS is right. Wonderful. DFS is right. What we are missing is the map. It's the whole trick. This is a graph, not a tree. It has cycles. So plain recursion loops forever and clones the same node twice. The plan. What's the plan, sir? What's the plan, sir? Wonderful. Let me even make it full screen. Yeah. So we, like it says, we need a map. Yeah. So hash map node. All right. So we need a map, but what's the structure? I mean, what type of map? Right. The map. The key is node, and the value is another node. Original and its clone. I wouldn't guess it. It's both visited set and registry. If not already in a map, return the existing clone. This is what breaks the cycle. Otherwise, create the clone, put it in the map before the neighbor loop. Then, like, I didn't make this skill like that. I mean, it's only been 3 minutes and it's already given us so much stuff. So break, Sergeant Cloud, break. I guess you have given us more than we need. Like it's been only 3 minutes and you already gave the structure of map and the clone idea. Anyway, just first follow what it says. All right. All right. Otherwise, create the clone, put it in the map. I don't understand that part. That map before the loop ordering is why your first step. Like map before the loop ordering reminded me of um, memoization, right? In recursion, in DP dynamic programming questions, we were applying memoization, right? So if there is something there inside the current stack frame, if there is something, right? Instead of doing all the calculations, we are getting the result. We are getting that value from our map. This resembles to that, but like I wouldn't guess we need to use a hash map for that. But the reason must be, yeah, the reason must be if we already clone, like we already have a clone, we should get it. But I wouldn't guess that. So, and the second point is you are saying that, yeah, like the first one and the second one is related to each other. Yeah, now you want us to write function in Java. So we need like a all right, we're gonna have the for loop again, and while looping through neighbors, if we have that neighbor, right, if we have the copy of that neighbor, but we are inside the for loop, so do I need to check the existence of neighbor inside the for loop, or so we have a for loop, we basically iterating through neighbors list, right, and it is coming from our argument, and our goal is to create the copy, right, create the copy. So but we need a start point, so we need let's say start node, right, and after this for loop, when it's done, we will return that start node again, I suppose, right, because this is our start point. So you said we need a hash map, so outside our recursive code, recursive function, we should declare and initialize our map, right? We can call it a map, right? Actually, we can call it clone map. So inside our for loop, before making our recursive call, we can first check if we have that node, like should we check, should we check the existence of the key or existence of clone? I mean, I didn't understand it. Actually, I suppose we should use the node itself, and for that node, if we have a clone, what should we do? Actually, I didn't get how we can clone. I mean, the core function, core process will be basically copying. Copying means creating a new node with the same value. Yes, guys, we should, like, the core operation is like initializing a new node with the same value. All right, so we should do this operation when there is no copy. All right, when there is a copy of that node, we should use it. So basically what I mean is that, like, we have, for example, these neighbors, right, and like it has their neighbors as well, right? So we are here, we like inside for loop, we are processing these children, and we should create new copy. So basically we should say new node, right, new node value. Basic that value will be, will be come from, let's say this is A and this is B, right? A dot value. So we are literally creating a new node with the same value. So this is a clone, right? This is a clone, but we should connect its neighbors, A's neighbors, to this new thing. Let's say this is X, right? We should fill its children, right? Is children. For example, it has is children here, right? So, but how can we do that? So that's the question. Um, yeah. So let me share you version one that I have in my mind, the code. Now I'm thinking of like the core process is basically like an even like a initializing new node with the same value, but like this is a new node, like we can call it x, right? And now like we should also like connect the original child nodes neighbors, right, to this node. So we have a for loop, we are iterating through neighbors, and we will basically create new copies, right? We will do some new node and that value, right? So but the thing I'm struggling here actually, um like how am I supposed to call or bring his children, right? Like I need to think kind of recursively, um not kinda exactly recursively, but when I should delegate, I mean, how should I use our sub problem? For example, we are calling our func, right? And what do we expect it to return? Should it return the um, the head, right? Most probably yes. Like if we pass a node, then it will return um, basically its copied version, right? So if we put n, for example, the one of our neighbors, right? Um, it will return a copied version of that. Uh, so it will return node, right? And what should we do? It's return thing. Um, we should maybe add what it returns to. Hmm. Actually, I guess instead of doing this, creating new node, creating copy basically, um, we can do this outside of the for loop, and like we literally create initializing a new node, and now our goal is to fill its neighbors, right, with the original nodes, neighbors. So um let's paste it. Welcome in, ladies and gentlemen. We are solving clone graph problem. um we are solving clone graph problem. um let's make it version 2. And here I shared with you the version 2. I guess like as we call this function, we should first create like initialize a new node, and now our goal is to fill its neighbors. And while iterating through all the neighbors, um like we should fill that new node's neighbors, right? I mean, this is what I remember. Oh yeah, by the way, on the problem C in the code forces contest, my solution was using union find data structure. That's nice. I will cover that too. I will cover that too. Union find. I copied your solution, so I will check it out, lazy skimmer. Um, like um, we created we created new node, and now we need to fill its neighbors, but we should also copy it. All right, so maybe for all the neighbors we should call our recursive function, right? Because our recursive function will return its copied. I mean, we're gonna call um our function, like a recursive function, and it will return same node basically, right? And but it's copied version, right? And we will get that copied version and add it to our at hmm our current nodes neighbors basically, right? Neighbors that maybe like that. Yeah, it should work like that. Like this is version 3. But I don't see where we can use hash map. Most probably before initializing new node with the current node, um, maybe we should first check if actually instead of start node, let me call it node, and if there is one, how do we check the existence of a key? I mean, if there is a if there is clone of that, we will return that node, I suppose, because this is what you just said. Return um return map. This is version 3, and I wonder your comments. Do you know it or you will learn it? Like I watched a video on YouTube about it, and maybe I solved one question using that, but it is not. I didn't internalize it. Lazy skimmer. Union find. It's a subset of graph problems, right? For some of the graph problems, we are using union find. Coding bara watch track 7 stream track. I appreciate, man. I appreciate. Like these things kept me work hard. I appreciate coding bara. Okay, when you internally practice it, I think you should be able to see the idea behind that solution. Yep, it's about connected components in graph. Yeah. Like there are amazing questions. Like you basically turn a question into graph and you solve that graph. Like graphs are quite helpful. Definitely. So basically, like in clone graph, I'm making our recursive call return the copied, like a fully processed, done uh, node, basically. Like if you give your neighbor, it will return its copied version. Its copied version. So we don't need to worry about anything. That's the beauty of recursion. Um, what are we gonna do with this copied node? We should of course add this into the current, the newly initialized neighbors. Yes, this also seems very nice. But AI also mentioned about um, like using a hash map, and if there is copied version of the current node, instead of creating a new one, return that node. But I couldn't manage to, check the existing of a node or not, that node. And also, for example, this should be in else statement, right? Actually, yeah, we have early return. All right, let's see what AI will say. Oh, time is up. Time is up. And it says we should, continue with the next node. Like today, our goal is to cover, all right. Before continuing with the next problem, I wonder your analysis on my thought process. What did you save? What did you write? Tell me, and then we will continue with the next one. Guys, am I seeing wrongly, or 7-day weekly limit is resetted? Why is that? Like, did cloud reset its limit again? We can build a new game for our, we can build another game, like, or my or maybe my weekly monthly schedule is resetted today. Which question? We will solve now. Which question? Let's see. Quicksort. We're gonna review quicksort. It is not from NeetCode. It's the questions that I have solved earlier. I wanna review them. Here's the read on your clone graph. Run three things you did well, 2 failures, patterns worth naming. What worked? Your recall of your own history was accurate. You remembered how you failed last time. Yeah. You self-repaired structurally across versions. Nice. You moved clone correction out of loop yourself. You added the check at the top. The recursion returns a clone that I add, pattern yourself. Each version fixed one real thing without me pushing. You asked the right contract question. What do we expect func to return? And answered correctly out loud. The copied version of that node. Yes. Alright. I don't want to read the failure patterns. Alright. One name take away to carry. Alright. Next problem. Next problem is quicksort. Let's see. We reviewed the merge sort yesterday, and let's see what we remember. Actually, I keep forgetting this partitioning step. I guess there are 3 different partitioning, right? Could you please give me a small hint, like a little hint, right? So that I can, start my engine basically. Yeah. For partitioning, do we, select a pivot point? But there are different ways to select pivot point, right? Is it quicksort or? Because in one of the sorting algorithms, we were selecting a pivot point. Small hint, engine starter size. Yes, there are variants. Yes. Lomuto, Oare, and 3-way. Drill Lomuto, the standard one, is picture. Like, I don't want to see him. Pivot. Last element, one pointer is a wall. Everything left of the wall is already less than pivot. A second pointer scans the array left to right. Question break. When the scanner finds an element smaller than the pivot, what two things happen? Alright. Last element. We are selecting the last element. Alright, the rightmost, right? And so our goal is to position, yes, our goal is to make that pivot point such that, so that all the things left of that will be smaller than it, and all the things on its right will be larger than itself. And we will keep doing this until we are sorting everything basically. So let's say we have an array, we select our pivot, right? And we have numbers there, and we have another pointer, right? We have another pointer, and it scans, and its goal is to find something larger than that. I think it's larger than it must be larger. When it finds something large, like when it finds something larger than that, larger than our pivot, right? Oh my gosh, larger than pivot, right? It should swap. But it says when the scanner finds an element smaller than pivot. Actually, the thing I remember is that, like, we have our second pointer starts from left, like a leftmost, right? And we compare the value at there and the value at pivot, right? We compare them, and if the left pointer's value is larger than our pivot, right, we should swap them. So that larger is now, it's on the right side of the pivot, but we have lost our pivot. I guess we don't change the position of our pivot until the last operation. So I'm remembering something wrongly, and you are saying that when the scanner finds an element smaller than pivot, but I'm remembering it should try finding a larger than that, so that it's swap. But swapping is also wrong, I suppose, because I remember that at last step we swap pivot basically. So if we think that when scanner finds something smaller than that, like I remember some swapping operation, but I guess we need another pointer for that, not only one pointer, right? Give me some hint. So the thing I remember is that at the end of this operation we will have our pivot, and all the smaller things on its left, all the items from its left will be smaller than itself, and on the right of itself they will be basically larger than that. Interesting. It's quite interesting that, like, I have studied this, I have understood it, but like, it's been maybe more than 1 month that I have studied this, and I kind of like forgot it's maybe like a 70, maybe 80% of the algorithm. It's quite strange, guys. Revealing the mechanism, rusty trajectory. We are rusty, guys. Two things you remembered correctly. The pivot doesn't move until the final swap. Yes, I remember that. And the post condition. Smaller left of it, larger right of it. What we are blending in ORS scheme. Larger from left means the smaller from right. Drop it. Lomoto is one directional. The plan. 2 pointers, both moving left to right. Pivot is high, park at the end, untouched. Untouched until the last element. The wall, index of the last element known, less than pivot. Index of the last element that is less than pivot. Starts at low -1, empty region. Yeah, like I also remember, like we had something basically outside, like a here, but then I thought like maybe the scanner and pivot, like maybe it was, I mean scanner and pivot, but yeah, like we have something that starts even beyond before our array indices. The scanner runs from low to high -1. Yeah, so the scanner, and also like does this mean our scanner also starts from here? Interesting. Scanner finds, oh my gosh, scanner finds something smaller than our pivot, grow the wall. Like why do we use the term wall? I++, then swap these elements. So we are, so all right, we have two indices basically, like two pointers basically, and we also, on top of that, we have our pivot. All right, elements greater than pivot need nothing. The scanner just walks past them. Interesting. Our goal, let's say, like move this pointer like that, for example here, right, and make all the left smaller, but it says when we find something smaller, greater than that, we don't move it. So let's say if this is greater than pivot, like we should, make it move, move to the right, but it's quite interesting, man. It's quite interesting. Loop ends, pivot's final seed is I+1. Swap, all right. The mental picture, swap doesn't, like this is what I remember actually. Swap doesn't send big things, right? It pulls small things left. All right. It pulls small things, like, behind the wall. Like, what is this wall, man? Big things get stranded automatically. So now reconstruct. We have partition array, low and high, then 3-line quick sort around it. Go. All right, we have low and high. Now I'm thinking like we have low and high, but do these things start from, let's say, -1 index basically, or low is starting from -1's index, let's say, and high it starts from index 0. I didn't catch that part. And like, how do we compare values? Do we compare pivot's value with high, or pivot's value with low, or are we comparing highest value with the lowest value? But in the beginning, low doesn't point at any value because its index basically it's behind the behind the array basically. Like, I have these questions. I'm thirsty. Hole mole. Welcome, Saran. Welcome in. Currently, we are reviewing quicksort. Welcome in, man. Let me even drink a bit more. Oh, hi, lovely. Welcome. Welcome in Legal Stress Temiz. Welcome. How are you? Welcome. We are doing some algorithms and it doesn't go very well. Like I am quite rusty. Currently, we are reviewing Quicksort. By the way, I'm still seeing the voice today. Really? Like yesterday, Uh, I checked it and I couldn't find an issue. But I will check it again. Sorry. Thank you for for the heads up. I will during the break. I will check it out. Good. I'm about to go to bed, but I saw that you were live, so I had to come say, "Oh my gosh, that's lovely. Thank you. Appreciate it. Appreciate it." And wishing you good sleep. Yeah. Thank you. Thank you for stopping by. So the confusion is that there are four names. I hope you have a wonderful. Thank you. Thank you. Thank you. Um, I hope I will cover lots of lead code problems today. I appreciate it. Thank you. Good sleeps. Good night and good sleeps to you. The confusion is that there are four names and you are merging them into two. Yes, so slight bounds. We have low slice bounds. So their name is slight bounds, guys. It's if yes, it is. Hansoe, bro, what background were you from? I graduated from computer science. My field is computer science. Welcome, by the way, Hansoe. Um, their name is slight bounds, guys. Function arguments. They never move. They never move. So we are. I mean, they should move, guys. Right? The workers. All right. We have I and J. Oh, they are values, but we have I and J. They are workers. All right. Yes. Behind the array, the whole region starts empty. Like still, I don't get it. The whole term. That's fine because we only write to I after I plus plus. The only comparison in the whole loop is like a comparing. All right. So I also ask that. I mean, what are we comparing basically, right? Are we comparing like a pivot with high value or low value? But actually, they are variable and they don't move. We assign values to them, and our workers is basically I and J, and most probably J will start from here, right? J will start from here, and I will start from here, I suppose, somehow. Or maybe both of them will start from, you know, 0. Let's see. We should understand that. Nothing else is ever compared. Fill only the 3 blanks. They are the whole algorithm. All right. Let's see, guys. Like we have these values in our arguments, but we also have I and J, and we don't have nested for loops, and that's the whole point. If we had nested for loops, then it would be n square time complexity. So we have high, right? All right. Let's first focus on that. We are calling this function. We are partitioning. Partitioning means we are getting a pivot point, right? This is the first half, and this is the second half. So it kind of resembles to merge sort as well, right? It handles the left part, and this handles the right part of the pivot point, I suppose. Like I don't want to continue with the next question, but first I should understand this. All right, like in merge sort we were basically calling our function for the left half and calling our function for the right half, and then we have merging phase. All right, here we have kind of similar question, I mean similar situation basically, but here I don't understand what like a first quick sort call returns or handles, right? And the second one, and also like I guess partial method returns a pivot point, I suppose, right? No, I guess this is the core process, right? And it is not recursive, I suppose. Yeah, it's a process, it's an iterative process, and we are calling it. And also it is like a pre-order, right? The structure of this quick sort is like a pre-order because we are doing our process before calling our recursive functions. But I still don't understand low and high and how do we set them basically, because in merge sort we were like in each step, I mean in merge sort is like a post order because we are calling our functions. We basically sort, yeah, sort the left half and then the right half and then merge. So this is post order, but here I guess we first making something, and I don't know what that is. I suppose positioning the pivot at the correct position, that the process, yeah, process should be positioning uh, pivot point at the correct place, and then we are calling our recursive function. So you should clear this up first of all, and then we can focus on the partitioning part. Let's see. Like I dedicated 15 minutes for each problem, but our cap is 30 minutes, so like during interviews they ask the time complexity of those sorting algorithms, and they sometimes asking you, I mean they can ask the just implement merge sort. They can also say this. um it's good to know, and it's a practice, it's like we can take it as a lead code problem basically. um yeah, like I forgot the how, like the role of partitioning basically, and also like to basically memorize this. Like merge sort is basically post order, right? um and quick sort is pre-order. So like in a quick sort we first do the process, and then call for, again it must be left half, right? and then the right half. But here we have variables like a low and high, and we should understand how we set them up. um yeah, so this is Pire order. Oh my gosh, Pire. All right, let's see. Locked Rusty. Re-review on 19th. All right, what day? All right, 3 days later. It opens with you writing partition code. Since today the clock typed it, not you. Pace note. Oh, it's been 22 minutes. The pattern in both overruns in long explanatory terms before the code. Try this. Answer the opener in 3 short sentences max, then go straight to typing. Like, I don't want to continue with the next problem. I want to understand this partitioning step. Show me how low and high moves. Actually, guys, good thing we have an animation. All right, instead of yeah, instead of waiting um Cloud to explain stuff in basically words, let's see the animation. All right, I have created this on Blender. So yeah, we are selecting our pivot point, right? All right, we have J and I. All right, so J starts from 0 and I starts from -1, and we don't have that kind of um, index. But I mean, let's see. And actually, we don't have nested for loops. We have a single for loop. All right, so basically, we don't have this for loop. All right, let's just forget about it. And we have a single for loop, and let's see how we manage I. Yes, let's see the animation, guys. Animation is the best way. So J, all right, it moved. Why it moved? So what's the condition for that? I guess we are comparing values with, I guess this is our high value, right? um and let's see what AI said about the comparing slice bounds. All right, so let me let me take a screenshot of that part. I really like the term slice bounds. Like, there are slice bounds, and I and J are our workers. um let's save it. Oh my gosh, why it didn't take my screenshot? Come on, you can do it. Nice. um So let's first read the part AI said. Yes, the only comparison is in the whole loop is J. All right, J is. All right, so J, we are comparing and we are checking if it. All right, so when we find something that's smaller than our pivot, all right, our goal is to find something smaller. I mean, less than our pivot. All right, let's see. Since 4 is greater than 3 and 7 is greater than 3, so we skip those items in our list, right? And when we find something smaller than our pivot, all right, we are making these comparisons using pivot. That's granted, right? All right, when we find smaller than that, we increased I value somehow, and we will swap them, I suppose. Oh my gosh. All right, why did we swap them? I mean, interesting. And we continue, moving our J and hoping for finding smaller than our pivot. We have found something smaller than our pivot, and now we're gonna increase the I and swap. So what's the logic? Come on, man. Like, why we are increasing I? Increase and then swap. All right, but how? Like, we should understand logic. So again, another bigger stuff. It will stay there, and J value. All right, and now we swap. Oh my gosh, we swap what? What did we swap? Pivot with what? Again I. So we are using. I mean, we increase I and then swap I and J. All right. So we can say that. Um, we can say that we increase I. Right. We increase I. Swap I and J. Right. When do we do that? When we find something smaller. When we find, right, something something less than. something less than our beautiful, amazing, fabulous pivot. All right, let's now take a screenshot. No, take a screenshot of it and save it in our notes. So, so what did we earn? What did we get by doing that? I mean, I guess our partitioning has completed its job, right? So now what we want. Like, oh, guys, check this out. All the things on its left is now smaller than that, and everything that is greater than that is now there on its right, basically. Um, like who did who designed that algorithm, man? Like, I mean, who could who could think that? Who could say imagine selecting a number, right? Like a rightmost, like any number. Like we can basically pick any number, but in this approach, we are selecting the rightmost, right? And we also have 2 pointers, all right? And one of them starts from -1, one starts from 0, and we are comparing our pivot, right? Actually, guys, I what I was remembering is, I mean, like there is only one loop here. I thought J was going there, and at some point they will reset, right, and start again, and they will reset and start again. But we don't have that. We are iterating only once. We are iterating this loop, these items only once, and by the end of it, right, we will position this pivot at its correct position, basically. So, I mean, we are comparing, right? We are comparing basically every number. Yes, basically every number. All right, let's see. We compared 4 with 3, right? Nice. We compared 7, nice. And we compared these two. So basically, J as a worker make us able to compare every element with the pivot. So to remember, to memorize this easily, right? More maybe easier. We can say that we are gonna select. We are gonna select like a number. We're gonna compare all the numbers on its left, right? And when we find something smaller than that, I guess now I kind of understand it. So our goal is to move, right, smaller things to the left as much as possible, right? To move to the left, we are using this I because it already started later. It already started late, right? So it's on the left side. So all right. So when we find something we want, which is smaller than our pivot, we move, right? We swap. Nice. All right. All right. All right. All right. All right. All right. Now I kind of understand it better. Like this is this is exactly the feeling that I have felt um, when I when I was studying this algorithm before. But all right. All right. Now add to echo and let me draw. All right. Uh, I mean, they are our workers. All right. And as a record, so this question is quite Oh, man, I got 3 hours of sleep last night. I couldn't sleep again because of heat. Like here in Turkey, like we don't have that hot, but I remember last year I had the same feeling as you, Solaris. Welcoming, by the way. And I remember I was pouring water on my bed and on myself, even though the window was open, and even though I was, I mean, I had like 3 of them. Even though I had these, and even though they are directed at me, it was still quite hard to sleep. But somehow nowadays we have rain and the weather is not too hot. But last year, this time, we had the same situation, and most probably in a few weeks, we I will have what you I will get what you are in right now. It's a very bad feeling to have because sleep is quite important, man. I like I wish you like Solaris. I wish you like. And currently, I'm reviewing Quick Sort at the moment, and I wish you luck. All right. It's quite hard, man. It's quite hard to try to sleep with heat. Terrible feeling. Terrible feeling. Yeah, I know. If I'm lucky, I may be able to take a nap sometime during the day. Yes, man. Yes. Or or just sleep better next night. I wish you luck, man. I wish you luck. Terrible feeling. But my friends that who have air conditioning, they sleep very well. Um, I'm thinking of getting one actually. I got back to expert on code versus. Oh my gosh! Congrats, man! You are now an expert. Wonderful, man. Wonderful. That's a great. It must be a great feeling, man. Being an expert. Wonderful, man. Wonderful. Let's see. Let's see. Let's copy that part. Let's see our Solaris, man. He is now an expert. Oh my gosh. He has like a 1600 expert. Look at this word, man. One word, 6 characters. I will be happy when I reach candidate master. Oh, you, you set a goal. Wonderful, man. Wonderful. We support you, Solaris. We support you. You'll get there soon. Like, we support you. We are with you in your journey. Expert, I have been in 6 contests, if you see, haven't been able to make the breakthrough. I mean, like, you are a dedicated person, man. You'll get there. I believe in you, man. You'll get there. Like, I'm solving this amount of problem, even on Twitch, watching algorithm related streams, and you follow, participate. Like, you'll get there. And those people who have those level, right, they must be like a 4 years of experience, like a 5 years. So it takes time, man. It takes time. um it takes time. And I wonder, like, there is a like a div 2 and div 1. So do you aim, I mean, are you aiming for like solving like a div 2 question? Because I remember you said that div 2 is like a kind of harder, right? And div 1 is even harder than that. So, like, do you plan to solve the questions in a div 2 maybe, right? What is your goal? Because I suppose div 2 is um like a expert, right? I think I'm going to attempt it. It's yes. Oh, all right, all right, all right. Wonderful, man. Just wonderful. Like, in your brain, the neurons, right, made so many connections, right? I want those. Thank you, old lazy lobster. Thank you. Um, thank you for the motivation. Welcome in. By the way, it's div 2 if you are 1800, 1900, let's or less, and div 1 otherwise, I think. Are you interested in solving the other problems of div 3? I still don't know how you would do the last one. One. All right. We are we are waiting for you. Um. So, I mean, I will solve the 3 questions for earlier contest. I feel like Twitch have tripled my ad durations. Like, I used to get 30 seconds max. I mean, interesting. What is this TV? What do you mean? What do you mean? Like, that's a good rating, man. Experts. Wonderful, man. Wonderful. 1,000 problems. Okay, welcome back. So there is welcome back, welcome back. What I Yeah, like I plan to complete the other. I mean, I plan to solve other Div 3 problems, and my goal is like a solving first three problems. And before that, I just want to review the questions that I have studied earlier. There are around 50 questions, and I will review them. And yesterday I reviewed, for example, merge sort, and now I'm reviewing the quick sort. Um, yeah, like on various of topics or from lead code. Basically, I have some questions, and I want to review them first, and then I will continue with the code versus questions. I really enjoyed solving first two questions. Still don't really know how to approach the problem. Problem G. Problem G. Like ABC is good enough for me. Solaris. ABC is good enough for me. Oh yes, I only know merge sort really. Like during interviews they ask basically, and like actually knowing their time complexity is enough, right? But sometimes I even once heard that one company asked implement merge sort, right? Yeah. Um I will look at this, Solars. I will look at this. But first, please allow me to do this, but I will definitely check this out, alright? First, I let me complete this one, review node, um, and then we will check this out for sure, alright? For I think for that question G, it will be some kind of DP, but it's tricky because it's hard to satisfy both conditions. Alright, alright. I will check this out. I will check this out. Data structures and DP, yeah. Alright. So for this problem, alright. For this problem, what I remembered was, I mean, something. I imagined I and J like a running, like a like after J is hitting to, let's say, length -2 index, right? I thought it starts from the beginning, and it's kind of same for I. Like of course they basically go forward. They basically go forward, but um, like this is what I remember. But now I see that like we have a single for loop, and that's the whole point of these sorting algorithms. Getting rid of the nested for loops, like getting rid of n square. So we have a for loop. Like this is a partition method. It is iterative, and what we do is basically setting pivot point, right? Like selecting any number. You could select any number, but like we are selecting rightmost number item, right? And we basically use J, right? This is our worker. We compare each element, right? And when we like, this is another thing that I remembered kind of blurry. So I thought our goal was to find find the bigger number and also swap that number with the pivot, but pivot is will stay there until the end of the partition method, right? Our swap is you know are being handled using our I worker and J worker. All right, we are using these to make swaps, right? um, and like you can also imagine that like basically you are like your goal is basically compare each item, right? Each item with the pivot, right? That's the whole point of this partition method. Like, it is kind of easy. It is kind of easy. You have pivot, you have J, you basically compare each item, right? Each item, and when you find something smaller than your pivot, right? And you swap, and then you find something smaller than your pivot, you first of all increase I, and you swap I and j value, basically I and j's value. All right, why do you know, why are you doing that? It is because, like, you literally want to move the smaller element to the left. All right, you want to move it to the left, because at the end of this parsing method, what you'll get is like a making like a positioning pivot somewhere, and the things on its left will be smaller than that, smaller than itself, right? And on its right you will get greater values. So that's the whole point. And the thing I'm trying to emphasize is, like, imagine a worker. Like, I really love the term worker. You have a worker, right? And basically you are comparing each values with the rightmost value. When you find something smaller than pivot, like, you tend to move, push for, like, push backward, like push that the item to the left, all right? Because uh, the last operation, the last step you're gonna do is like a moving pivot to, somewhere, um, the I minus I plus one. But you're gonna move your pivot, and you want all the numbers to its left to be smaller than that. That's the whole point. And that is what I underline, basically. All right, guys, let's hope for the best. And I guess we can save this one. All right, let's check the messages. How long does the legendary creature stay in the aquarium once I redeem it? um, as long as it survives, Solaris. Hello, welcome, Dampidon. Welcome in, man. Welcome in. Like, fish will be in our aquarium. Will be in our aquarium as long as they survive, basically. All right. This is nature. So you can hunt others, and others can hunt you. Like, if your fish is small, right, the bigger fish can hunt your fish. But you can stay in peaceful as well if you want your fish to stay in our aquarium as long as you want. Basically, you can run peaceful command, right? You can run peaceful command and make your fish stay here forever. Does fish size reduces with time? Yes. Yes. Yes. A bit. Yeah. So you need to feed it. Yeah. You can also run peaceful command to stay safe. All right. So let me show you the animation. Let me show you the animation I created on Blender, guys. And Solaris, you said you only know merge sort. So let me let me explain the quick sort. I mean, as far as I know, right? Quick sort, basically, there are three different ways to select a um, pivot point, all right? And the one that I like most, and the one that, yeah, that is kind of easy for me, is selecting pivot point, rightmost. You select the rightmost item as a as your pivot point, and you have your 2 pointers, all right? I and j. J starts from index 0, and I starts from -1, all right? And your goal, like, let me first show you the animation, and you'll already understand, all right? We have our j, we have our j value, right? We have our I value, and basically we compare the value at j and pivot, right? And if it is bigger than our pivot, we don't do anything, all right? We just skip. So it's all right. 7 is also greater than 3. We skip that too. And when we find something smaller, I mean less than our pivot, then we will increase I by 1, and we will swap those two. All right, and then we will continue basically another bigger number. We are skipping it, and now we have found a smaller number, right? Smaller than our pivot. So again, we will first increase I, right? Increase I, and then swap those two items. All right. All right. RJ will continue. 6 is greater than 3, so it will skip 2. When we hit end, we will basically increase I again, and we will swap these like two items. All right. And now, um, now what we have done is basically making every item on its left of this pivot, right, is smaller, and on its right we have greater numbers. So we kinda sorted things, right? And how can I see list of fish commands? You can edit into channels. um I guess we have fish help. No. How about help? Let me add a proper comment, Dumpydon, for fish comments. All right. Um, Actually, on this page, we should have um. Oh, it won't open. All right. Let me open this through here, and in comments you'll see um where is our fish? All right. Play with your fish, free in chat. All right. We have these comments. Dumpydon. You can check our comments here. Um. Oh, I see. So after one iteration, the prefix is smaller than our pivot. Yes, prefix will be smaller than our pivot. Yes, after one iteration, exactly. After single for loop iteration, exactly. Everything left of it will be smaller, like a less, and the right side of this pivot will be greater. Like we end up with um, all the elements less than pivot to the left and the rest to the right. Exactly, Solaris. Exactly it is. Let me show you the animation again. Exactly. Do we recursively? Yes. You are amazing. Yes, exactly. Let me show you how. Yes, exactly. So um, in merge sort, we basically call for left half, right? And then we basically call for right half, right? And then we basically merge those two parts, because we first, let's say, sort the left half and sort the right half, and then now we basically using again two pointers, we compare and we basically initialize a new array. And in quick sort, like, this is basically like a post order, right? This is like a post order. And exactly, you said, Solaris, in quick sort we are gonna do pre-order. So basically we will partition, like we will basically call we will basically call this animation, right? We will call, I mean, we're gonna do the things in this animation, right? We're basically select pivot and make these operations, and we will call our recursive function twice, right? um I guess again this will be for the left part, and this will be for the right part. I'm thinking now selecting the indices, like um like a because we had something like a low and high. I guess left half will be like a index 0 to high, I suppose, right? And for the right half indices, hmm, I guess I should check this. I should check this, but this is a structure of quicksort basically. But selecting these indices, I didn't remember. This is for quick sort, and this is for merge sort. Yeah, so like selecting these indices is also quite important. This is the structure. Um, is it n log n? Isn't that n squared if you always select the max as a pivot? Actually, we don't select max as a pivot. We are selecting the rightmost as a pivot. Yeah, yeah. We are selecting rightmost because there are different strategies. Like there are different strategies, right, to select the pivot point. And I guess we are using Lomuto, Lomuto's approach of selecting pivot point. We are not selecting the max item. We are selecting the rightmost item. So if it is already sorted, then that's a good question. Um, so if it's already sorted, then isn't that n square? Most probably yes, but I don't know it. You asked a good question. If it is sorted, if it is sorted, we are selecting the max item, and basically we are comparing. We are swapping basically. Yeah. No. Mm, if the array is sorted, if the array is sorted, and if we are selecting the rightmost number, right, and this is our j, this is our I, right, and we compare, and this is smaller, so we will increase I, and we will. I don't understand why are we swapping. I didn't understand that part. What would happen when the array is sorted? I mean, 1 is less than 7, and we should increase I and swap these two. Interesting. Say we are swapping the same number. Alright. And we will move j, and 2 is again smaller, and we will increase I, right? And swap these. Interesting. And this is again smaller. We will increase I and swap the same. I mean, we are swapping the same thing. Uh, so we are doing this. We are swapping the same number with the same number. Um, all right. I guess yes. I guess yes, but this is strange. So when the array is sorted, we are, I suppose, doing lots of swaps, right? And also the determining the indices of these like a left half and right half is also important. How do we do that? Yeah, so this is how we do. We have a low. Hmm. And also this partial method returns something, an integer. I guess it returns, right? I guess this method, like we sort, I mean, in this animation, in this function, we basically have this structure of this array, right? And I guess we are returning the index of this pivot. I don't know. Solar is D1 and D plus is today. Will it be super hard? I don't know. Harder than today. So what does this method return? Um, the position, the index of our pivot. Let's see. I suppose yes, like a low and Yes, this should return an index p minus 1. And the right half. All right, so all right, let me take a screenshot. For example, here, like we will return index 2, right? And our goal is like a partition, right? And func left, right? Func left are so left half will be like a low, and for high value we are like this is p, right? And for high value we are passing p minus 1. This is left half, and for right half, like we have high, high. No, start point should be p plus 1, right? Please be plus p plus plus 1, please. But I guess it is not. Let's we also understand why. P plus 1 comma high. Is this it? Yes, all right, all right. Luckily, luckily it is p plus 1. Are you doing div 1 and div 2? Um, like, can I solve it there first? One question maybe? Maybe not this time, Solaris, because I really wanna complete these questions that I have. I have 48 questions to review. Maybe. Hmm. Maybe next time, Solaris. Maybe not next time, because like I have like a container with most water, like a validate BST, house robber, hand of status, like the questions that I have solved earlier, like a LRU cache, and queens, rotting oranges, valid sudoku, lowest common ancestor, longest common substring. Like I have solved these, but I keep forgetting, and I want to make them fresh in my mind, basically. Loop detection, heap sort, case sum subarray, binary tree diameter. Like these are amazing questions, right? Lemonade change is graph midpoint. Yeah. Like this is, for example, I love this question. For example, flatten binary tree to linked list. Like I love this question. I have studied this question early. But if you don't submit anything, you don't lose alone. I'm not even sure about doing it, but it will depend whether I'm not too tired. Yeah. Do you drink coffee? So there is coffee. Yeah, coffee. Do you drink coffee? Do you grind 16 hours? Dampidon. Yes, yes. I need to grind 16 hours. All right, each day, because like I keep forgetting it, man. Like for example, studied this quick sort, right? Like look at these nodes. I have studied these, but I just keep forgetting it, man. So I should review them. All right. And my first goal is to review them, and then I will continue with neat code 100. So my second goal is solving a neat code 100, 150 basically. All right. um yeah, yeah. And after completing them, I will feel good. uh no coffee, no alcohol. I drink water and eat rice. All right. I also don't drink coffee that excessively. I also like I have my water. I have my water. Um, so you Asian, don't ask. Like I mean, drinking healthy stuff is good, man. Like like we shouldn't switch our focus, right? I mean, having a clear mind is quite essential for us. I drink coffee in the morning and no alcohol water. Nice, nice, nice, man. When I was working, when I got to the office, I was having my coffee. But now I'm home, and I don't basically drink. I don't drink basically. coffee that much. Yeah, so all right, let's continue with reviewing our what which question we were quick. All right, we have reviewed quick sort. It was amazing feeling. Let's continue with container with most water. We like I remember this. I remember this. Let's open. No, no. All right. Now our next question is this. I reviewed. Basically, we have reviewed quicksort. It was amazing algorithm. We have again two pointers, and also in merge sort we have two pointers actually. Like after like a sorting left half and right half, we have again two pointers, and we basically check the their first characters from left half and right half, right? And in quicksort we also have again two pointers, but they are behaving a little bit different than the merge sorts two pointers. And also I really enjoyed, like I really loved the idea of like a one iteration, like we have partial method, and in a single iteration it moves the pivot in its correct position, and it's amazing. And also like I really love the idea of like a j, like a worker. It literally compares its value with the pivot, and after single iteration it's done, right? It's wonderful. So yeah, so let's continue with most water question. And by the way, guys, like, is there a delay between, I mean, between my voice and my visual? Because yesterday and today also, our friends in our chat, I mean, one of some of them said that there is some sort of delay. Do you? I mean, are you watching? Clear? Is everything good? No delay. Wonderful. All right. Like I don't get, but some people say there is a delay, but I don't get it. All right. Now the thing I remember with this problem is that again, like I we again have two pointers. All right. Like I love these two pointers. Like I believe, I feel like we can solve everything using two pointers. Again, in this pointer we have two pointers. We don't need to sort the bars because we can't. Basically, we have we have like a um like a left pointer and right pointer, right? And um basically the idea is when we're gonna move these inward, like we're gonna move these pointers inward. And the thing is, as we move them, since our goal is to basically hold like a store like a high amount of water, right? uh, is between the bars, like left bar and right bar. uh, when we move them inward, we are basically making, like we are decreasing the amount of water that we can hold, basically, right? This is really bad, right? But um, if we find, let's say we move left pointer, all right, and if um, we find another bar which is higher than that, right? Then there may be a chance for us to store bigger water, bigger amount of water. And also, like another thing I love about this problem is it's not about left pointer and right pointer. Like we should think um, like a abstract, right? It's not about left and right. It is about the smaller bar. All right. Why? Why? Like we literally need to cover each cases, right? There will be four cases, guys. Four different cases, and we are analyzing all of them, and only single one of them will may give us. So in this problem we need to cover all four different cases, right? For example, like of course after deciding that we can use the two pointers. Now um which one should we, like the next question now is became which pointer to move inward, left or right? So which attributes they have, like can be like a smaller or higher than the its neighbor basically. So which one should we pick, move inward? If we move, like if we, like let's say we have uh you know let's say our left pointer, right, and right pointer, and let's say right pointer is higher, like longer, right, and if we move it, right, inward, like there are two cases, right? We can encounter higher than our right, this is one case, or we can encounter even smaller. All right, if we encounter smaller, then there is no way we can find a higher amount of water, right? But if we find higher, then again this will not give us any better result. Why, you ask? Glad you ask. It is because we are limited by the minimum, I mean, yes, smallest bar, right, shortest bar. Because even if we find a longer, like a higher bar, it doesn't change the high basically. All right, so this means we don't get any good result um by moving the higher bar. All right, so let's now cover the case where we move the smaller one. All right, let's paste it. And I remember, guys, Solaris in during one of our question in Code Forces, when he was explaining things, I remember he said something like, "It won't give us any good." Like, I remember, I'm hearing, right. I'm hearing this term again and again. This won't give us any better result. This won't give us any good result. All right, any good basically. So that's the idea. Like that's the greedy idea. And be I should get familiar with that because this concept is widely used. So now let's cover the case where we move the the like a shorter side, right? So let's say the shorter side is left pointer. So when we move our left pointer, there are again two different cases, right? We can encounter with a smaller, right? With smaller, like a shorter, or higher, right? Let's cover both of these. So when we encounter with the shorter than our left pointer, it's a it's a very very bad situation, right? Because we decrease the distance, right? We decrease the distance by moving our pointer, and also we have found like a shorter one, so that we are now limited by its height, right? And the amount of water we can hold is now in a terrible horrible situation. All right, that's the one case. And now we will cover the last case. All right, that's gonna be amazing. The last case is when we find, like when we move, and we encounter with a higher one. Then what's gonna happen? Let's see. So when we find something higher than our current bar, now although we decrease the distance, right, now we have like a smaller distance, because the way we calculate the amount of water is basically like a distance times smaller height, right? Although we now have a uh, less amount of distance, but we have encountered higher. So when we try to calculate the total amount of water now, since the height is quite high, now it's possible for us to store like a very enormous amount of water. That's huge, man. That's huge. So that's the one case. So we should now build our solution on top of that, right? um that's the thing I remember. Now I guess the remaining part is about implementation. Like we literally covered all the cases, guys. I mean, this this that's amazing, guys. I mean, I should get familiar with that. But I wonder, like, I mean, maybe most of the time in this type of algorithm questions, like we don't have 500 or 1,000 or 1,000,000 different cases that we need to care about. Like we have like a maybe like a 2, 4, 6, right? So we should cover. I mean, I assume this is a greedy problem, right? We should cover all of these and we should come up with an idea. And this is what I remember. All right, we can continue with the next question, but let's see what AI will say. Um, Maybe we can try implementing it as well. Maybe I can do two passes, right? In first pass, remember the like a logic and the some of the implementation details, and then in the second pass, we can focus on this part because I really want to complete all of these. Gate pass. That was a cleanest recall of the day. All four cases, and the key insight stated exactly right. The shorter bar is the bottleneck. Nice, nice, nice. That's the term I need to use. Bottleneck. So moving to taller, never this is the term I love, guys. This is the term I love. Like, look at this BD. Like because I see this in many questions, guys. Like when you read it, you don't say, oh, like this is a quite important thing, but that is a very important thing, man. Quite essential for us. The like coming up with this idea, basically, right? Moving to taller one can never improve anything. All right. Only moving to shorter one keeps hope alive. Oh my gosh, look at the term, guys. Only moving to shorter one keeps hope alive. Because we decrease this distance, now things are getting worse and worse, but the hope is encountering with the higher, like a enough amount of height. All right. Um. Yeah. All right. Um. And yes, to your question, this is greedy and your case analysis. Yes. Oh, I also love this term, case analysis. Yes, yes, yes. Because sometimes we don't need to do case analysis. For example, like a DP questions, like we have like a recursion tree. We are thinking differently there. But in this type of, in especially in this type of, not all in for all the greedy problems, but like this type of greedy problems, we need to do that. We literally need to do case analysis because without it, you cannot come up with a solution, basically. All right. So case analysis is sometimes the correct approach that we need to do. Case analysis is the proof. Each step you discard every pair involving the shorter bar because we just showed none of them can beat. You already measured. That's a dominance argument. Yeah, yeah, yeah. Dominance argument. All right, all right. Um, like take a note and add that I skipped the implementation because I wanna continue with the next question. Validate binary search tree. All right, our next question is this. Let's see what we remember from this question. And also check our friends on Twitch and let's lurk them. uh, let's lurk in their um, streams. But I guess, oh, we don't have. We have. but I don't know them very well, so we are lurking in only one of them. All right, all right. Let's continue. The next question is validate binary search tree. All right. Let's also check YouTube if we have any. All right. The next question is validate binary search tree. Logged fresh with an asterisk. Logic recall was the day best, but the implementation is unverified. So the re-review starts code first, zero discussion. All right. Yeah. What time is it? All right. Three short sentence then code. The pattern, the classic trap, everyone falls into this problem, and what your recursion passes down. Let's not see the hint. Validate binary search tree. So first we need to remember what it is basically. Validate binary search tree. I guess for for it we have a parent that is greater than their children, right? I guess that. So for I guess we should first remember what the binary search tree is. I suppose we have a parent who is greater than his children, right? And this made me remember. This made me realize that like it resembled to like a max heap, right? Because in heap we had this structure as well. Like I mean, right? Especially in max heap. Do I remember? Do I remember correctly? Or we have like a left child is smaller than our parent and right child is greater than our parent, right? I guess it was like that. um and our goal is validate, so we should traverse all the nodes, right? And since you said uh, what your recursion passes down, like you said, you literally said that, so it made me think that we should have an argument to pass. And also like I remember that if we pass like a low and high values, um, because each node represents a stack frame, and in those stack frames, um, like we should know what is the highest value we can get and what is the lowest value we can have, basically, right? I suppose. Let's see. But now I think that like what do we get from having I mean yeah, low and high. What do we get? You had know by knowing those intervals basically. So for example, we are parent and we're gonna call I mean func left, right? And func right, right? So um so this is how we traverse like a func left and func right. But while we are traversing, we should pass a rule, right? As we go, for example, to the left, maybe we should pass. Actually, to validate, we should focus on the meaning of validating. To validate, um, like those nodes have some values, right? And we should compare the value that it has and value that it can have, right? So can have part maybe could be designed using like a low and high. I still don't know. I still don't remember why we need these two, because maybe we just need only one, and maybe we will say that the value should be smaller than that, right? For example, when we go to the left, we expect our um, numbers, our values in this subtree, right? In this subtree to be actually, yes. So actually, like we expect that node's value, like a child's value, to be smaller than our parents' value, and also that's the important thing. We also expect subtree, all the nodes in this left subtree, to have a value that is smaller than our value, right? So, and also another thing is that like during this traversal, we can go like a left, right? But of course, like we can go like a left and then right. So it means that in the subtree we will make those right calls and left calls. So I guess this is the answer for why we need like a low and height, because if we only care about our immediate left child and right child, yes, we don't need to hold these two numbers. We can only hold, let's say, for example, when we are calling for like a func right, we may say that like you it needs to have um, value higher than our value, right? But we don't have only a single node. We have a tree, like we have sub tree, right? Um, so basically, and in that subtree, like it means that in the subtree we will make like a left call and right call, right? So because when we are making a left call, then our rule is becoming like it turns into like into a state like a um smaller than, it should be smaller than that. When we call for a right, we are saying that it should be greater than that, right? So since we're gonna do these many times, right, and we don't know if we have a tree like a only like a right, on the right, we may have, but we may have like a different type of um, trees as well. So we need to design our algorithm for all cases. Yeah, this is what I remember. It is transcribing. All right, let's press enter and let's. That's a lot of words, man. Let's see. Let's see. I really love this skill, and I hope it will make us, move fast. Because after forgetting to drive those ideas from zero, it takes a lot of cognitive energy, guys, believe me. But if they are fresh in our mind, then we won't, consume that amount of cognitive energy. It has been 7 minutes. All right. Get past. You talk your way to it. Past low and high. Bounce down. Going left. Tightens high to my value. Going right. Tightens low. And you drive the Y yourself. The trap is checking only parent child. Yes. Actually, when I first saw this, I was checking only um, parent and child. When the rule is about um, the entire subterranean. By the way, Dumbledore, you can also use you can feed your fish like a 5 times. We have a channel point type where literally it is, I guess, 250 channel points, and you feed your fish 5 times. Um, yeah, you are you are getting larger and larger, Dumbledore. I spent them all. Oh, I see, I see. All right, all right. You are getting larger and larger. And make sure you are in peaceful mode. Make sure you are in peaceful mode because we have some other fishes that all right. All right. Nice, nice. Because there are some other big fish and they can hunt you. Let's see how you're gonna eat your petal. Come on. Come on. I hope you will eat your petal soon. Come on, Koi. Its stomach is full of gas. Yeah. No, no, no. It should eat, but let's see. Let's see. Maybe I may need to update the AI. I made that fish eat. Yeah. We may have a bag actually. I mean, um, like on the cold side, you like your fish is getting larger and eat, but no, no, there is no limit. I mean, there is of course like a size limit, but there is no limit to amount of. I guess you ate it, I suppose. There is no limit, only there is size limit. You can get very large, but after some point, you just don't grow, but small in smaller steps. You can eat 11 creatures. All right, you have 28 bulk. All right, 28. Code it now. One go, and it's tiny. 3 notes, integer low and high. Two things to nail while typing. The base case for null. The comparison. Think about whether duplicates are legal. Let's copy this part, guys, and try implementing it, because while we are implementing we will see some stuff. All right, low will be integer, like this is easy. And as we call, like we're gonna call this function, right? Func for left and func for right, and we should also pass low and high values. So for going left, we should set the higher. So we can pass the same low, but we should set the high value as the current node's value, guys. All right, and when we are go into right subtree, we should set the base case, like a lower bound. Yes, lower bound. We should set the lower bound as the node's value, right? It is lower and high value. Do we need to set the high value? I mean, high value, it can be anything. Interesting. I mean, for going left, like let's say our value is 10, and on our left subtree, we can only have stuff like smaller, less than 10, and on the right side, we should have stuff greater than 10, right? Greater, and this is low. But what about its high value? High value can be yes. All right. We will call this function, right? Welcome. Hello, Antonio Morales. Welcome in. We will call this function, right, like this, guys. Like we will pass our root, and as a low value, we will pass. You guess it right. We will pass integer min value. You guess it right. And in integer, and for the high value we will pass integer dot max value. All right, that's how we're gonna call it. Ready for 12 hours stream? Yes, yes, we are ready. It's gonna be amazing. Root, min value, max value, we have low, we have high, and we can share past the same high value here. This is our implementation, I suppose, but we have about the base case. Like, of course, we should have a base case as well. So what should stop us? What should stop us, guys? And why the sound is too high. Let me also turn this a little bit down. Alright, I guess it is now better. How many chapters did you complete total? I am now currently at 15. At 15, and our goal is to complete all of them. Antonio Morales. Our goal is to complete all of them today. Like, I mean, review basically. Like, these are the questions that I have already solved. So, yeah. So, wish me luck. We are at mark 15. What should stop us? I mean, if the node is, if the node is null, right? If the node is null, what should we return? That's another thing. Maybe true, right? And also, I realized that we have a return value, return type. So our questions will, our function calls will return like some values, right? Boolean, right? And we should decide. All right, so we are making these calls, right? 34 left to review. All right. 34. We will do it, man. We will do it. Come, one, you can come. All right. I hope we will do it. We will do it. So, come on, you can do it. So we are making these calls, and they will return answer, guys. Like, answer of what? Like, this is our left subtree, right? And this is our right subtree. And it will return that. Keep reviewing. I'm not this. All right, I'll turn it. Saron 0.0. What do you mean, man? Do you want me to drink my water? What do you say? What should we do? They will return. They will say that subtree is valid. All right, and this will return, yes, I am valid too. Let's drink water together. Is my eye. Let's drink water together, man. Come on. Thank you, man. Thank you. It's valid, and it's valid. Now what should we do? If they are both valid, then I can return true as well, right? I can return true as well. So return A and B, I suppose, right? But I'm not sure about that base case. Like, I don't like base cases, all right? This is my solution, and I don't like the base cases, but I hope we are doing good. Because why I don't like the base cases? Because do we need to have like a node? Actually, on linked lists we have node equals to null, and also node.next equals to null, all right? Yeah, but here I guess we only have checking with null, right? And also I realized that on linked list problems we are making this checking in a single if condition, but actually those checkings are for two different cases. Yes. um, because one of them is for handling the empty array, I suppose, right? Empty input, and the second one is literally for understanding if we hit the if we are at the last node. Keep reviewing. I'm gonna play with my fishes. All right. Feed your fish, man. We have a tank. You can also change the color, Saron. You can change the color of my lamp and the color of our aquarium using our color command. Which color do you like most? We have these um, we have these colors available for you. All right. I'll take orange. All right. You can set it. You run color command and then the name of the color, and let's see how it will look. All right. Thank you for the color, Siren. Now our aquarium is shining orange, and my room is orange as well. All right. One sharp question. You answer with one line of code, then I close this out. Your structure is right. Base case is right. Empty subtree. Vacuously valid. The linked list. The linked list double check exists only because those loops dereference. Dot next, the different reason, not a missing case here. But look at your function. Where does any tree ever get rejected? Trace it. Every branch returns true. You built the bounds plumbing perfect and never installed the check. Low and high are passed everywhere and read nowhere. Oh, all right. We didn't add the process basically, right? I mean, we should actually I add the process. I mean, if they are valid, hmm. All right. They are valid, but the current node should be valid as well. Current node, yes. If current node is let's say lower than our lower, or it is higher than our high, then guys we are early returning, early exiting, return false. Have about that. Come on. um and thank you, like you guided me amazing, and I realized that um like for post order I am good at like delegating the responsibility or expecting answer from sub problem, but also like we need to put the process as well, because how can those sub problems can return a true and false actually. That's the process, as I call it. And positioning it is quite important actually, and I put it above our function calls in this case. But there are some other let's say DP problems or recursive problems. um yeah, like I feel like I should solve more problems basically, because positioning it, for example, deciding which parameters, which argument parameters we should pass, um and this is important basically, right? Let's see our statistic, and uh, and then we can have a break. I want to do some exercise basically. Every muscle I move I hear a sound, guys, like tuck tuck kut sounds coming, indicating I haven't moved for a while. We should I should do some exercise. Let's see what our beautiful, amazing, wonderful, fabulous, astonishing cloud will say. Look, Rusty. Oh my gosh, I thought this isn't Rusty. Pace check. Averages are running 20 minutes against 15 cap, all of it in long spoken turns. The recall quality is genuinely good. You have self-derived the core idea 3 or 4 times, so the fix isn't thinking less, it's capping the narration 3 sentences then type. Next problem. Alright. Actually, welcome, hungry people. Yes, yes. Um, so before continuing with our next problem, can you give us statistics like how many minutes I spent for each problem? Uh, Maybe even better, can you create an HTML file showing like how many minutes we have spent for each problem, the easy to remember, like easy to remember parts, and the parts that I didn't remember, the capping, like everything, right? So that we can analyze. Welcome in, hungry people. Like we are reviewing these notes, right? And yes, wonderful. Our next problem will be house rubber, a problem that I love. Like how I really like the reason why I like you know the house rubber problem is that because it's the question that taught me how to delegate sub problem in DP, in dynamic programming questions. A session dashboard, loading the design skills. Have you tried prompting Cloud to use the Socratic? Yes, yes. To guide your thinking to the answer. Yes, yes. I'm using a skill, and this skill basically does the same job. And I have already like two different Socratic method skills. Like I call it tutor mode. Exactly. This skill, um, based on the elapsed time, it changed like direct thinking basically based on the elapsed time. And as time goes by, it gives more hint basically. I've been doing it reverse. I have had to guide Claude to answer sometimes. Interesting. And also, do you know hungry people? Like yesterday, I had huge amount of weekly usage, but now it looks like it reset. It has reset. Uh, I mean, is it because of the time or date, or did cloud reset all the usages again? Not in lead code, but projects. Oh, I see. Guide Claude to answer sometimes. Come on, man, it shouldn't take this long. All I wanted was an HTML file. Come on. Let's see which friends do we have. All right. Come on, man. Give it to us. Give it to us. And let's see our friends on YouTube. Um, we are reviewing it got problems that I have solved earlier. Alright. My weekly use also reset, so I think they may have done early reset for some reason. Amazing, man. Amazing. It means I can build. Because I have already used the 50% of my weekly limit. So we can build, guys. Wonderful. I'm quite happy about it. I'm quite happy about it. Oh, I guess we have low amount of low amount of um, battery on my lamp, but let me charge it. Page not found. Oh, it created it, but why I can see it created it on um, on my account basically. I wish they do what ChatGPT does every once in a while, that they will give you two free limit resets to use whenever you want. Really? Really? That is amazing, man. I didn't know that. I mean, in each month, or like a, you say every once in a while, but what is the duration? What is the duration for that? What is the duration for that? I mean, um, not always, sometimes. All right, all right. Cloud also started doing that, and this is the second time I encounter basically. Um, and that's a very good feeling because there are some other projects that I want to build, and my daily, my monthly, no, day, weekly, my weekly limit was already like a 50%, and on this Sunday I want to have very long stream basically. So I was thinking that maybe we may have like a 1 day off. I think they do it with major upgrades or something. I'm not sure, but I have had at least two per month lately, and they have no expiration. You can use whenever. Wonderful, man. Yeah, yeah. I really love that idea. All right, guys. So this is our review session dashboard. We have reviewed 4 problems of a planned 50. Total time 72 minutes. Um, all right. Fresh rusty gap. So we have one fresh, two rusty, and one gap. Clone graph is what? Is not good, I suppose. Quick sort. All right. Container with most water. Yeah, like I remember this easily. For validate binary, all right, 23. So recalled clean. Deep copy DFS, loop over neighbors, all right. Blanked and revealed hash map registry. Put before the loop. Return to original. Contains key. All right. We recalled these clean, and the blank part is this. Quick sort. Oh my gosh, guys, this is just amazing. This is just amazing. The session pattern. Recall is genuinely strong. The minutes go to narration, not confusion. Two recurring code level muscles to train. The function contract. What flows up as a return? Yeah, yeah. What flows down as parameters? Prescription. Answer every opener in 3 sentences maximum. Then type. Container is the proof it works. I like the design of that. Yeah, yeah, like design is also amazing, right? Look at this. Everything looks very neat, very nice. There is no, excessive parts. All right, we have covered 4 problems, and we're gonna continue with house rubber after the break, guys. And let me also, power this lamp. So it's been, I guess, 2 hours, right? How many minutes? Where is my? All right, it's been almost 2.5 hours. So we may have maybe 20 minutes of break so that my lamp also gets charged. Break 20. Even better, make it 25. Maybe I may have my second my second breakfast. We'll be here, and we will continue with the I'll solve a problem when we come back. Take care, guys, and see you after the break. We are back, guys. Don't worry, guys. We are back. That's gonna be legendary, guys. I ate some dessert and I feel better now. Welcome in, Coding Para. Welcome in, man. How you doing? How you doing, man? Coding Para fed 10 times. Oh my gosh. What did you feed, you know? All right, we are all right. And also, guys, I realized that my eyes are getting kind of red because of the ice train, I suppose. And let me use my eye drop, right? This is eye drops. Yeah. Um, since we are looking at the screen for a long time, um, our eyes are getting tired, guys. Um, yeah, so we should use them, you know. Yeah. All right. It's now better. It's now better. Where is our music, guys? Oh my god. Where is our I guess you are here. Maybe I can increase a little bit. No, maybe even better, I can decrease a little bit. Yeah, it's kind of good. All right. Let's check the YouTube. Hello, YouTube. How are you doing? Yeah, so let's check now. Let's continue now. Um, the question we're gonna solve now is, let me also start my timer. And also, guys, let me first search for something, right? um, let me type be right back. All right. I was yapping. Welcome, man. Welcome in. All right. I'm looking. I'm searching for something. Right. Give me 1 sec, and then we will continue with this one. Look at my fish. Can you run? Can you run? Follow me. Let me see your fish. Oh, you are starving. Like you can add a new fish into our aquarium if you like. I mean, it's getting larger and larger, but um, wouldn't it be better for you to pick a normal fish that you know swims? Let me check something, guys. All right, I guess we can continue with house rubber, but before that, I just want to search something on the internet. Oh, hungry people! Look at this blue whale, man. It is enormous. It is enormous, man. Where is my fish, by the way? Let's make it hand. Look at my lovely fish, guys. Yes, it ate. It hunted down. My fish also getting larger and larger. Wait, can the starfish hunt? Actually, it can hunt other seabed creatures, not the fish. Give me a fish, man. I have 0 points. You should watch and get some channel points, Coding Barra. Come on. And after I guess like using your 300 channel points, you can have a fish into our aquarium. Use your channel points wisely. They keep hunting me. No, actually, they won't be able to hunt you anymore because when you insert a fish, it's by default in peaceful mode so that they cannot hunt you down. We have other fish type like a other fish, basically anonymous fish, tank fishes. They can hunt them basically. Uh, yeah, look at this beast. Let me add some prey. All right, we add. Let me add some more, and even better, let me add some more, and let me hunt them a little bit. Uh, nice. I think starfish can hunt the mud. No man, no no. Let's hunt again. Yeah, that's nice. That's nice. I'm getting I'm getting larger and larger, guys. Look at this beast, man. I'm always in the lurk. While in your lurk, do you get um channel points, or use your channel points wisely, coding bar? Like you are using for feeding your basically starfish. Um let me give me let give me some sec, guys. I first need to check something. But you have to click on box. Can we have a poll? Hmm, I see. I see. Without clicking that button, then you don't get your channel points, right? Um, can we have a poll? Yes, we can. Um, how do I do that? Uh, test one and test two. Oh, question. Test question now. Response one and two. Channel points per vote. But you need to consume your channel points. Alright. I guess I started a poll. Then what will happen? Then what will we do? If you choose correct option as viewer, you will get points. But uh, all right, I will vote too. But what is the correct? a solution. I mean, correct option. Did I, determine it? All right, I voted. What now? I guess we have 2 minutes, and after 2 minutes, it is you will choose which is correct. All right, I have chosen two, option two, and I guess in a minute you'll get some point. Let's see. Let's see what will happen. I'm not used to using those polls, but let's see. Very nice. All right, there are different types of poll on Twitch. This is basic one, but there is a channel point poll and bits poll and sub only poll too. Did you get any channel points now, Coding Para? Oh, we have lots of poll prediction. One setup menu to create and manage a prediction. Will I be able to solve 5 questions? Possible outcomes? Yes. No. How about prediction? Maybe when you are solving this equation and you have asked viewer a question, and if they choose right answer, they will get channel points. Oh, I should definitely use it, Coding Bara. I should definitely use it. So, I guess I started, a prediction. Let's predict. Uh, what should I do? Oh my gosh, what happened now? I guess I need to learn these, Coding Bara. Then we can make it even better. I mean, we can make our streams more enjoyable. Let me first handle this something. I need to do something. Um, You will choose the result. Please choose yes, or I will lose my channel points. Dummy don't. I mean, how should I? How should I choose outcome? All right, outcome should be one. All right. Yes. How many channel points did you get? How many did you get? While you are typing that, I picked 20 and I got 20 because nobody has participated. I see. Also it means it depends on how many people we have here as well. Um, I'll be back in a minute, all right? Let's go. All right, we are back, and let's continue with house robber. All right, our next question is house robber. All right, next problem is house robber. 3 sentences, then code the pattern, the recurrence, and what fi means in words. The thing I remember from um, basically from this question, um, basically we can rob the last house, right? Or we don't rob basically, right? If we rob the last house, then the next position we can continue, right? Since we cannot rob its neighbor, um, like if the last problem is if it is of fi, and then if you rob the last house, then the next sub problem will be fi minus 2. So this is one case. And actually, like today we also covered container with most water question, right? So um so basically there we had also some cases. And also in um knapsack problem, we also have cases, right? Like a um for example, like this is quite important, all right? Please state this in our notes. For example, in trees, sometimes our recursive function returns the answer, right? Returns the answer, and sometimes we use it. I mean, we use recursive function to have to build the real answer. And for example, here we have different cases. Like I'm creating connections, so this is quite valuable, all right? So here we have different cases, right? Like we don't build like a single recursive. Actually, we are building a single recursive relation. But what I mean is that like maybe it is because this is this is a DP problem and it has reoccurring sub problems. But actually, no, it is not about that. I mean, we have literally different cases. I mean, and our recursive relation solves both of them, but the thing we maximize is something else. So yes, so our recursive function does not return the answer right away. Like we're not trying to build such a thing. That's a quite important thing to realize. It says 3 sentences, but we are so So here in this problem, we have two cases. The first one is rob the house, and by robbing the house, what do we get? What is the function of it? I mean, yeah, actually it is not fi. When we rob the last house, we get its value. Let's say it is nums I. So if we rob, we get its value, and the next subproblem we need to solve is now becoming fi minus 2. And the next question is that like why do we need that subproblem? I mean, actually in your question you also stated that the meaning of the f. So maybe I should start with defining the meaning of this f function. F function, the definition of that, like, and also this resembles to ending at I, which is a max subarray and max product array, right? So there we had the same style as well, and we also have the same style in prefix sum as well. So here fi would mean, most probably, I guess, um, maximum amount of money it can get until index I. Yes, so we define that. So to answer that, we have, yeah, for example, to answer that, what do we do? I mean, for to answer fi, what do we do? To calculate the maximum amount of money that we can rob, f, at index I, until at index I, including. And by the way, instead of until, what else I can use? So maximum amount of money that we can rob until at index I. How do we define that? I mean, do I need to create a relationship um of like a sub using sub problems, right? And we have two cases and we need to use them, I suppose. But like, how do we define fi using sub problems? I mean, of course, the first case is like a getting the value right away at the last index, right? At the last index, at index I, plus, and delegating. Now we are delegating our problem to our sub problems, right? So fi minus 2. But I mean, I'm trying to see why. I mean, we rob, and now what we are looking for, like after robbing we get the value, and then now what should I think? Like, I'm trying to understand the creation of this recurrence relationship. All right, since I remember this question from earlier, I could write it, but if I had seen this for the first time, then things might go south, right? So this is one case actually. So like, is this a definition of fi? And the other case is like, we don't rob the last house, right? But then our sub problem becomes fi minus 1. And like, this is quite strange. Like, I like, when I see it, I can understand. What if you ask me to create it from zero, then I would fail. So could you please, like, what do you say? Do we? Yeah, we have a little bit song, right? Come on, press enter. And also increase the sound a little bit, I suppose. All right. Let's see what AI will say. I mean, like, after seeing that, yes, I can say that, yeah. So we can rub, right, get the value and delegate the sub problem. But actually, we have the same situation in reverse linked list problem as well. So, for example, um, like, we delegate our sub problem, and like, this is our head, right? And we basically, you know, when we call func, like func node dot next, we expect this method to return what we want, basically, right? What we want to reverse. So it returns the reversed version, right? Reversed version. It returns the reversed version. Amazing. And even better, we have also this one, right? All right. So we now think about what to do after, when this returns, right? Um, we literally do that, right? I guess we have the same style over here. Um, Recurrence and meaning both recalled, right? Your question is the derivation why. So here it is. Compact the recipe, partition all plans by the last house's fate. Every valid robbery plan for houses from 0 to I either robs house I or doesn't. Two buckets, covering everything, overlapping nothing. Best overall, max best of each bucket. Either robs house I or doesn't. We either rob that house or we don't. Bucket A. Every plan here earns nums I, and its remainder is a completely free choice over, yeah, completely free choice over 0 to I minus 2. So the bucket's best is nums I plus this. Yeah. So that's why, like, I know, but that's why appears not we jump there, but the rest of the plan lives there. Bucket B. So B basically have two choices: rob that house or skip that house. These plans are exactly the plans over. So these cases aren't branches you walk. They are buckets you sort all solutions into. So same move as your glue test. List the candidates of Fi. Take the max. And your noted insight is real. Here's its sharp form. It depends on whether if is constrained or free. It depends on whether f is constrained or free. Cadence fi is constrained, best ending at I, no single f is the answer. The answer is max over all I. Hausreber's fi is free, best over the first I plus 1 houses. Say over, not until. If n minus 1 is the answer, I will save this to the notes at rub. Now type it. Um, your function type with a memo or a bottom-up array, your pick. Before going into that, I also find this quite similar to a reverse Nick's problem. Um, we basically call func with node.next, and we expect it to basically do, I mean, complete its job basically, I mean, achieve what we want basically, and then we think we think about what should we do, right? um yeah, and we apply that to basically every node. Here we have kind of same thing, and actually you have explained it very well, but I didn't understand, to be honest. I mean, first thing is, you said those and that the case aren't branches you walk, but I mean we have two different cases. What do you mean by branch? And you are saying that they are buckets. The second thing is, um, it depends on whether f is constrained or free. So in cadence, how f is constrained, how, in what way it is constrained. I mean, it means best ending at I, but you know, yeah. And for this problem, we can also skip implementation and add this into our node, skip implementation. In knapsack question, I guess we have the same stuff, same situation again. Like a, we either include the item, or exclude the item, and we also have the same situation in, I guess, subsets, like in backtracking. I guess no, I guess it's not in was there, but like I remember some questions like that built upon this idea, like a take it or leave it, right? But now I'm trying to understand the case situation, the buckets, right? Yeah. So actually, so basically we have a function, right? and that function will have two cases, right? One case will be like a uh, delegating our problem to this one, right? And actually robbing the current nums I, right? This is robbing. This is one case, right? Integer x. The other case will be integer y, and here the answer, the thing we want is basically I minus 1, right? So we will return the maximum of these variables basically, and that's it. So um we may need to add a base case, right? But I'm trying to understand, I mean, how do we decide that we have two different cases actually, right? And what is the relationship between those cases and the recurrence relation? And the thing I'm trying to understand is what is the relationship between our recurrence relationship and our cases, our buckets. We have two buckets. Because sometimes, because I remember while I was solving knapsack problem, I was basically, trying to create a recurrence relationship that solves those two buckets, right? But we should put them, we should evaluate them differently. Having buckets is something, and creating a recurrence relationship is something else. Closed out, locked fresh, recurrence, and f meaning recalled clean, and at the gate implementation skipped by your call. So like container, its review as code first, 15-minute even. Not saved, appended buckets, not branches. All right. So before we continue with the next question, could you please answer that? And maybe you can give maybe five other examples to show the buckets and the recurrence relationship. But even sometimes examples, the examples don't mean anything. So for our case, like, can you give me some hints? Can you teach me, right? Like how, because since I know this question, it is easy. But when we see a different question, I should be able to determine, this will be our bucket. This will be our recurrence relationship. I don't feel confident about determining these guys. So that's why I'm pushing. And then we will continue with hands off the traits. First, I should tree map. Oh my gosh, I forgot what tree map is. Do you know, guys, what tree map is? Because I don't remember. Great question, and the answer is a single reframe. The recurrence isn't something you build after the buckets. The recurrence is the buckets prized. They are not two artifacts. Pricing the buckets is the act that produces the recurrence. Oh, we have then then do you mean that we have two recurrence relationships? Right? Not single one. Interesting, guys. Let's see answer for this question. No, oh, no, one recurrence. I mean, one recurrence with one term per bucket inside it. Hmm. All right. Two buckets each contribute a candidate, and the combiner wraps them into a single equation. Bucket A term, bucket B. For example, in coins change, no, not coins change. climbing stage problem, we had kind of similar stuff, right? We had like a fi minus 1 and fi minus 2, and we were summing them up. Here, we don't sum them up. We compare, take the max, and also for a sub problem, which is fi minus 2, we add a value. Like I'm trying to, generalize or, internalize the concepts, right? And here, we like the sub problem has a value on top of that, right? I mean, we are adding a value to that, and that determines the bucket. That means the bucket. So, for example, in climbing stage problem, then do you mean that our buckets were like a two sub problems, right? Without any additional stuff, like a two steps prior and one step prior, right? Then do you mean that in almost every dynamic programming questions, do you mean that we're gonna have two buckets, right? Actually, for example, some basic recursion problems, I remember like we were doing stuff like a 1 plus func I minus 2, right? And there, I guess we have single bucket, and that sub problem, inside that bucket we have a sub problem and an addition, right? But here in dynamic programming questions, most probably we will have like a two number of buckets, right? Let's see which buckets we have, guys. Let's see. And I redeem myself. Can I redeem myself rosemary oil sniff? Yes. Oh, 500. That's a very expensive thing. 500. Maybe I can reduce to 300, man. Let's see. Four generalizations in there, three right, one to sharpen. Climbing stairs buckets, yes. Here's why no value gets added. Buckets, buckets, buckets. Last move was one step, and or last move was two step. In house rubber, the bucket's fixed part contributes money, so it shows up as plus nums I. In accounting, there are different problems, right? In accounting problem, the fixed part contributes to the identity of each way, not to how many there are. Every way in bucket A pairs one to one with a way of reaching step I minus one. Appending the same. Then take one step to each doesn't multiply or add anything. So the bucket's price is just um, f I minus one pair. General rule: what the fixed part contributes depends on what f measures. Money added counting nothing. All right. The added value determines the bucket. Backwards. Small but important. The bucket question, the last decision's fate, determines the bucket. The added value is merely that bucket's price tag. Two buckets can have the same price tag and they are still different buckets. Always two buckets. No. Two is just the most common because take it or leave it is binary. Coin change, one bucket per coin. Edit distance, three, yeah. For example, in edit distance, the important part was not about, you know, seeing your options, but it's about how you implement those insert, delete, and replace. We are gonna do pointer arithmetic in this problem. The count of buckets, number of possible answers to your bucket code. All right. Your one plus style single bucket observation is sharp. One bucket means the last step has no choice. One bucket means the last step has no choice. I really like this idea. Every solution ends the same way. Length of a linked list, every count ends plus this node. So the separate is plain recursion. There's actually a clean definition of the boundary. Decomposition equals one bucket. Decision problems, multiple buckets, and a combiner. Decomposition one bucket, decision problem multiple buckets, and a combiner. In our document, can you also add that Kinesin loved the idea, loved the term of multiple buckets and a combiner, especially the combiner term. And for decomposition means one bucket. I really loved these two terms, right? And also, um, what did I like? Um, I guess I like another term actually. But what was that? That the last term, the last term. Where is that last term? Yes. And also, can you please clarify on this line? Like one bucket means the last step has no choice. In climbing stairs, yes. At the last, I mean, at the last step, we don't do anything. But like, do we have a special thing? Because you use this term term in other places as well. But in dynamic programming questions, most of the time, I assume uh, we don't need to think about the last step, right? We won't need to. Anyway, guys, like we need to continue with the next question after it answers it, all right? I still didn't get anything from this, not anything, but I didn't get any, too valuable thing. But like we have buckets, but like we define our problem using sub problems, all right? And inside the bucket, we can add new terms, basically, right? Um, yeah. In bucket B, for example, we don't have any extra term. All right. What is our hand of traits? The next question is. I think I can increase the sound a little bit, I suppose, right? Come on, Claude, answer this and let us continue. Yeah. Created persistent memory entry so every future session teaches DP in this vocabulary by default. All right. Yeah, this is actually what I wanted. Decomposition. Oh my god. Especially combiner. All right. Actually, I don't remember. I kind of remember about this question. Three sentences, then code the pattern, the key data structure, and why you must start each group from a specific card. Three sentences, then code. Why you must start each group with a specific card. All right. So for this question, actually, I don't remember much. Could you please remind us? I guess here we should create some groups, right? And we will count the frequency of them. And also, when I say group, I remember group anagram, and there we had like a computive absent method, um, and there we were grouping word strings by based on their key basically, right? And that key is basically, their letters and frequencies. We were sorting the characters of each word to generate a key. For the same key, we store them in the same group basically. And here I suppose we had another variable, let's say k, and let's say this is 3, and our goal is to group the integer. I guess we have integer array, right? Our goal is to create, I guess our goal is to create groups that contains consecutive numbers, right? For example, in the first group, let's say it's gonna be like a 1, 2, 3, and in the next group, it can be like a 2, 3, 4, and in the next one it can be again 1, 2, 3, and maybe in the next one it can be like a 5, 6, 7, like a consecutive. Our the question was this, right? Uh, let's make sure of that, and then I will think about the solution. Oh, even on the camera, even I look, disoriented. Uh, like the weather is kind of hot right now, and everything is good, man. Everything is good. Don't complain. Don't complain. But I may need to bring my other fan, all right? Because single of them started not being enough. 2 minutes. Oh, the problem confirmed. Let's first remove this suggestion. Recall, problem confirmed. One correction. Groups are hands of exactly size k of consecutive cards. So the question is Boolean. Can the whole array be partitioned? So are familiar. We are we are familiar with this term from, you guessed it right, quicksort algorithm. Can the whole array be partitioned into such groups? Every card used exactly once. Yeah, all right. So we have an integer array, we have k. We remember it correctly, guys. We remember the question correctly. Nothing left over, no card. All right. How could we sort? So, um, maybe we can pick, like, if we sort our input array and get the minimum, and then find the next minimum, and find the next minimum, and when we reach the k, then we can start the next group. But for that next group, we don't know where to start. That start point should be the next smallest one. Like after consuming these, from among the numbers we have left, right? We should be able to pick the smallest again. Your frequency instinct is right. A count map is half answer. One probing question. Like, I like the term probing. I don't know the meaning of probing, but when I miss something, AI says this is probing thing. So one probing question to unlock the rest. Then it's gate time. If a group must be 3 consecutive cards, and somewhere in your hand the smallest remaining card is 2, which group does the 2 have to belong to? Could it ever be the middle? Or rather, sorry. I guess the point where you are trying to get is about, I mean, we can sort our input array, right? Or even better, we don't need to sort, right? We may hold the frequency, right? Uh, frequency, but yeah, like we need to know the our smallest one. After getting the smallest one, then that's easy because if you know the current smaller, right? Smallest current, if we know the current smallest number, then we can basically um search for the frequency of its consecutive, right? If the smallest number is 3, then we can start, I mean, we can look for 4, right? um and we can reduce its frequency basically. So, and we should do this for 3 times, right? um and after completing a group, then in the next iteration we should start another group. And now the question is, how should we know the next group start point, right? And actually it should be the next smallest one after consuming all the frequencies of the numbers inside the first group. um so, like, in my notes I've seen something like a tree map. And, like, for example, for the group anagram, I know that I need to know, like, I have learned that I need to know computive absent method. But without it, I still could came up with the solution, right? I mean, it would be more complicated, but still. So, in this question, if I don't use the tree map data structure, would I be still able to solve the question? Um, this is my question and this is my idea. What do you say? Oh my gosh, the weather, the the temperature is getting hot right now. I may need to bring another fan. Let's press enter over here. Last summer I was using 3 of them. Nowadays the weather is not too hot here in Istanbul. But last year in this term, it was quite hot. Escalate, yes, yes. Based on the elapsed time, this skill escalate. Escalate what? Escalate the, hint level. Gate pass. Oh my gosh. You rebuilt the grid yourself. You rebuilt the grid yourself, yeah. So the smallest remaining card is forced. Yes. Yes, the term I should use is remaining. The smallest remaining card is forced. It can only start a group because being middle or end would require. Actually, guys, when I first solving this question, I asked this question, but now I don't even ask this question because I know, um, like, since we have solved group anagram and since I know how to hold the frequency table, since I know the meaning of consecutive, because when I first started these questions, like after reading consecutive word, that wasn't ringing a bell, right? So, but now I know what to do because after knowing the start point, what I need to do is just basically checking n plus one, I plus one value, right? And existing of it and decreasing the frequency basically. So since I have solved similar questions and also since I have solved this question earlier, but of course still it is quite important because even though, like, a question might be a question that I have solved earlier, but it doesn't mean that I will be able to solve it again. Or even better, it doesn't mean I will be able to explain it during the interview, alright? So don't underestimate the value of solved questions, all right? It's quite important, guys. It's quite important. And your question has the same answer as group anagrams. Group. And your question has the same answer as group anagrams. Yes, the tree map is a convenience, not a requirement. Oh, that's good. You need 2 abilities, counts and smallest remaining. Tree map bundles both. First key plus values. The unbundled version usually cleaner. Sort the array once, alright? Like if I can sort the array, then actually even if I sort the array, I can use those numbers, but in the next group, I should check them again. maybe I can use a index. Yeah, that, I mean, for example, we sorted our inputs, right? And we know their frequencies, right? So after creating first one, two, three, now in the next group, like we need some sort of pointer so that, I mean, we created our first group. Then what? What should tell us that, I mean, you have, you know, this is your smallest again. In the next group, what will tell us that this is the smallest that we can use? Tree map solves this both, but the unlocked version usually cleaner. Sort the array. That's your smallest ability. Frozen upfront. Plus a plain hash map for counts. Alright. Walk the sorted array. A card whose count is already 0 was consumed as someone's neighbor. Otherwise, it's the smallest remaining. Actually, I didn't understand that. Actually, I didn't understand that part. Like, if we don't use tree map here, like for example, we have 1, 2, 3, 4 as an input, and their frequencies are 5, 6, 7, and 8. All right. Um. So basically, after creating our first group, right, what should tell us that in our next group, we still have 1 as our smallest. All right, because we are sorting. Actually, do we sort the hash? Actually, we cannot sort the hash map. Yes, that's another important findings. But even if after we sort, oh, if we sort our input array, what we have is something like 1, 1, 1, 1, right? 5 ones, and then 6 twos, right? All right, this is our input. Like, how do we iterate over those? I mean, after sorting, we have like a 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, right? So 5 number of ones, 6 number of twos, 7 number of threes, and 8 number of fours. Let's say we started from the beginning, and by looking at our hash map, we will check its consecutive ones. And yeah, first, yeah, we should check its consecutive, like its neighbor's frequency. If it has, actually, should we check the frequency of the current one? Yes, I suppose we should check the frequency of the current one. For example, the iterator of our for loop is I, right? Hello, hello, hello. Welcome, Anna Froggy Princess. Welcome, welcome in. How are you doing? We are solving hand of straits problem. We are reviewing lead code, and I wish you a wonderful day. How are you doing? How are you doing? As someone's neighbor, Sikibit, otherwise it's the smallest remaining starter group there. Alright, so um doing cool, co-working study too. That's nice, that's nice. You can also add a fish in our aquarium using our fish command if you like. Fish command. You can add your fish into our aquarium, and you can hunt others. You can feed. Bro, coding is so crazy. I need to go back to coding. Yeah, yeah, like coding. Coding is crazy, man. And we have a koi. Your fish is now koi. Um, yeah, what a lovely creature, huh? What a lovely creature. You can also pick a color if you like, right? You can set my lamp's color and our aquarium's color as you like. Um, yeah. So in this channel, we study lead code. We are learning Python, C++, robotics. We are developing games. Um, yeah. Currently, the primary focus is on um, basically lead code. By the way, what is the name of this iterator inside our for loop? I guess it is called iterator, right? So like we are processing, and if it has the I mean if its neighbor, but which neighbor? I guess in our hash map, right? We should look for the key of, let's say, nums I plus one, right? Yeah. So if we have a value with this key, it will, if the frequency, if the value of that key is greater than zero, then we can continue, I suppose, right? We can go forward in our for loop. And in the next iteration, again, we should check its neighbor, but actually we are not generating the group, like we are not generating the first group. If we are using this for loop and if we are iterating through the items in our input array, um, then we're not creating those groups, I suppose. But we should decrease it also. So if in our hash map, if with that key, if we have a value, we should basically decrease it, right? Decrease its frequency. So, and we are, I guess, continuing. So now we are at index 2, right? Again, we will check its consecutive, but actually we are not creating. Oh, maybe inside this for loop, right? Maybe we can have another while loop, right? Because that while loop should run k times and decrease the frequency of of of these numbers. And for that, um, it should look at basically like a nums I plus 1 each time, and it should decrease it, and also it should increase the I, right? So all right, we will increase our I inside this while loop and decrease the value at the new I, basically. But we may need to use another variable than I, because I is the iterator of for loop. So that's the thing I have in my mind. Any tips to start from the very basic again? Um, about coding um, like a Java, Python. Like building projects is a great way, and making AI to teach you is another. Because I have created a skill now, it basically teaching me. It helps me. Uh, the topics that I'm studying is, I mean, they are not easy, but at least I find what I want faster. So I can suggest, like building projects, you can speed up your learning process for programming languages. Um, yeah, building projects and asking lots of questions to AI. This is what I do actually. Everyone has a different learning methodologies, but mine is like a. But the common thing is like a building projects is really helping, and also building projects that can have real users. That's the advice that I got from a senior developer, and I really love that idea. Creating projects that have real users, that will be very helpful, because making something serious is hard, right? The unbounded version usually sort the array once. That's your smallest ability. Frozen up front. A plain hash map for counts. Walk to sorted array, a card whose count is already 0. Mhm. Otherwise, it's the smallest remaining. Start a group there. So actually, I realized that using tree map it's much easier. But if we don't use tree map, then it becomes harder, you know. Let's drink some water. Logged Rusty, re-review the 19, alright, 3 days later. It opens with one question. Which word does each, alright, so actually before continuing with the next one, could you please tell me how I can do without using tree map? I mean, after we sorted our input array, like because by using tree map, things become quite easy, right? Because it really answers the next smallest one. That's the amazing information, right? This is quite helpful information. This is a quite helpful information. But without using tree map, then how would we do? Could you please shortly explain it? Because I will, we will continue with the next one. And our next problem will be, guys. Oh, yeah. This is another beautiful, amazing, wonderful question. Short version. The trick is splitting three maps, one superval power into two chip parts. Tree map answers a live question. Who is the smallest alive right now? Without it, you split that question into, arrays that sort the other half frozen up from. What does this mean? Frozen up from. The sorted array is an itinerary that visits every card smallest first. Hmm, I actually didn't understand. Then the wall glues them. At each array position, ask the map. Is this card still alive? Why probably? The invariant. Once the walk moves past a values block of copies in the sorted array, that value's count is exactly 0. Every copy you visited was either already dead, a neighbor consumed killed it earlier, skip, or alive, it led a group, which decrements it once. Copies visited decrements accounted. So everything behind you is fully dead. And whether you are standing on with, oh my gosh, I don't understand this part. Rule of thumb worth keeping. Sorted structure. Order plus membership fused. The same two facts unbundled. Like I didn't understand these parts basically, right? How we can solve this problem without tree map. So next time we can start with the implementation of this question with tree map, and then I need you to teach me how we can do without using tree map. And the next question is LRU cache. The thing, the thing I remember from this question is that we need to basically create dummy nodes like for our start and end, basically like a head and tail. But we were using them. Yeah, we were using, like we had like a two directional linked list so that we can reach the previous and the next as we want. We were storing these linked list nodes in our hash map, and we were making requests to that hash map, and our goal was our goal was when we like when if we are adding something that we already have, we should basically update its its value and move it to the header, like removing it from where it is and putting it into like a head or tail. I'm not sure. Let's say tail. Yeah. So actually, let's have a quick break. Let's have a quick break. I'll be back soon. Let's have a quick break and I'll be back in a minute. All right, guys. What is our All right, let's have a 10 minutes, 15 minutes break. Break 15. Oh, it's already running. Let's run work then. All right. And let's have 15 minutes break. I guess we are back, guys. Let me lower this down. Let me pour Colonia, guys. As you know, Colonia is just amazing thing. What are you working, man? I'm working on LRU cache problem coding bara. Welcome in, man. Welcome in. The LRU cache problem. Lead code. Pol Poliana. Do you mean Solaris? Oh my gosh. Colonia. Yes. Yes, this is Colonia. It's Cologne. Yes. Yes. It's fresh. Um let me Oh, it's been 2 hours. Alright, interesting. Let's start the counter again. How did it how it is 2 hours? It's the perfume. Actually, it is not the perfume. It has some sort of alcohol, I suppose, and somewhat. What was the name of that? Let me. What was that yellow thing? I forgot its name. Uh, what was its name in Turkish? Yeah. Let me find in. It is lemon. Lemon. Lemon. It is lemon cologne. Colonia. Cologne. Or yeah. But it's not a perfume. Um, LRU clock is scrapped and will restart fresh when you are back. Meanwhile, I will refresh the dashboard with. Oh my gosh! Look at this decision, man. When you are back, just ready. Just say ready, and LRU cache starts on a fresh clock. All right. We are ready, guys. We are ready. Let's go. So yeah, like I will share what I remember from this question. 3 sentences. Each time it asks 3 sentences, but we give it more than three. We give, yeah. So the thing I remember in this LRU cache is that we were using um, we were using like a double linked list and a hash map. In our hash map, we were storing those nodes, and each node has the reference to the next node and to the previous node. And also I remember that, like, also you should remind us, all right, because like in this question also, like when we add a new node, we should update its value, right? I mean, since it's a cache, when we read, we also update it, right? Meaning it's yes, recent used, recent used. All right. um so what does I remember, let me see. And also we had this like a dummy nodes, like we had like a head node and tail node, and we were having some sort of dummy nodes, like even before the head and after the tail. And also I may mistake, I mean, I may confuse the meaning of head and tail, right? Because in linked lists, the thing we have as head is like the first node, like on the left side, right? And nodes goes to right. At least this is what I have, how I draw. Could you also remind us this? Um, and in the solution, I remember we had maybe like a 3 or 4 different methods, like a utility methods. But it's an implementation detail, so um, So we have hash map. We store the nodes. Each node will show us the next node and previous. So, and also there will be some moves. By move, I mean like removing a node. How can you remove a node? Because you need to rearrange the connections, right? And now I will tell AI about it. And also about um, for example, we have some moves. First, one of them is basically removing a node. For to remove a node, basically we should make the that node's previous next as the current node's next, and next prev as the current prev. So this is how we remove. And also we should, when we read, since it should be marked as recent updated, right? Recent used. So when we read, first we should get that node, and we should move it to, I guess, tail or head. I don't know. Like I may confuse the meaning of head and tail, but when we are making a read operation, first of all, we basically we need to remove that node from where it is and put it to the basically head or tail, right? Recent position. But if it is already recent, maybe we can add a case for that, right? For this. Like I remember remove, I remember adding to head, but I don't remember the meaning of head and tail, and I don't remember how we use like a dummy node. And also, I guess I'm not sure if it is in our yesterday's note or not, but I guess we have applied that dummy node thing in our problem in one of our problems. Could you remind us that? Yeah, this is what I remember. And also, like there should be another move other than like a removing and updating. But since I don't remember the question fully, this is what I could fetch. I guess, guys, I may need to, add some fresh water, like a cold water, like cold with ice. We have two fans. All right. Coding butter redeem drink water 100. Oh my gosh, man! Thank you, man. Thank you. Appreciate it, man. Appreciate it. The temperature in my room is like I feel like it is like 30 Celsius degree, or even more than that, maybe like a 35 or something. Thank you, man. Thank you for the redeem. Um, Gate passed. Structure recalled. Map plus double linked list. Supplies out. So you described the exact right. Move on read. Sentinels, helper methods. 3 fast answers to your 3 asks. Then you type. Head and tail meaning. You don't remember it because it isn't a fact. It's a convention you declare. Nothing in the problem decides which end is recent. Nice. You pick and stay consistent. Declare the usual. Head side. Most recently used. Tail side. Least you recently used. Hot things get added right after head. Eviction happens right before tail. Yeah. Uh, yeah. Dummy Sentinel nodes. You met this exact idea yesterday. Yes, I remember it correctly. Remove end from end. Yeah. And also, even better. Yes, yes, yes. I really love these connections, all right? Because this dummy idea, for example, today we also have studied quick sort, right? And there we had two workers, I and J. And as you remember, I was starting from -1 basically, right? So I resemble it to basically our dummy node. Could you please add this like a connection into our nodes when we complete this problem, because it is quite valuable, like seeing patterns in different topics basically, right? So head tail meaning. Yeah, so yes, we decided. You met this exact idea yesterday. Remove ant from ant, where the refrain was every removal is a predecessor operation. Same medicine here, doubled. A dummy head and dummy tail that never hold data mean every real node always has a live prevent next. Alright, alright, alright. This is why we are doing this, man. This is why we are doing, because we really want to have um like we really want, for example, this is our node, all right, this is our another node, another node, and another node. So we basically want, for example, we create our dummy nodes, right? This is dummy head and dummy tail, I suppose, right? And so, like, for example, they have like a next now, like a next pointer, next pointer, next pointer. Is there a latency between microphone and camera? I think yes. Um, actually, actually, this is the second time I hear this. There are some says there is no sync issue, but there are others say there is. I don't understand. Interesting, interesting. Because yesterday there are a few people who said this. I will check this out. Thank you for the heads up. All right, so let's now draw the prev. So this is our prev. So for example, for this one, this is prev, this is prev, and this has also now has a prev, right? And this is head. So why did we add these two green things? So maybe I can mark this as LRU cache marker, LRU cache. All right. Because guys, after having these, after having this dummy node, now every node in our linked list basically has prev, because without it we would have this node, right, this A, and like it has its next, right, but it doesn't have prev. So to eliminate this issue, we add this dummy node, so every node in our list now has prev and next. And also we can understand actually another reason. Yes, actually, yeah, like I really need to create a very fast way to record it. Maybe I can create a desktop application, all right? Because for example, I will talk about quite important thing now, and it would be great if we save it actually. All right, I will definitely create that desktop application. So the important thing here, guys, is um, the second thing we get, the second advantage we get from this is that we basically know where head is and where tail is. For example, this is tail, right? But how exactly do you plan to understand, I mean, how do you plan to distinguish this node from this node, right? This is how, I mean, the following is how. So because for this B node, you know that next, actually next is not null. Next, again, we have, maybe we can assign a value, let's say 5, right? And if we can understand that this is tail node by checking b dot next dot value. If it is 5, then you are tailed, right? And for us to understand this node is head, right? We no, not this node. um this is our head, right? This is actually, yeah, this is the node. Like, um for us to add a new node, for example, this is recent used, right? Recent used. So we should add the incoming node right here, right? Right here, like between this, like a dummy node and this. So actually, the first thing I said might be wrong, because we don't need to distinguish this is head or this is tail, but we should know where to insert. Yes, this is actually what I'm trying to get. We should know where to insert. And how can we know? Yeah, how do we know? I guess we can store these dummy nodes addresses, right? Dummy node, dummy head, and dummy tail, right? Yeah, we can store their addresses. And for example, to add a node in our tail, we can literally say that, forget about this part. We can literally say that add tails next, right? No, tails prev. Make tails prev as your new incoming node. I can draw the new incoming node as this one, right? And we can make this a newly added node next as tail. So basically, tail. So basically, we don't change, we don't update, because I thought for a second that we are updating head and tail, but we don't update tail, and head. So we are using them as a static addresses, and basically when we want to add something, we add there, and when we want to remove something, we will remove from there, basically, right? That's a brilliant idea. All right, so we can now skip it. Actually, let me add this. So now I draw, like it's like after my last sentence, I spent a few minutes to draw and understand the structure of head and tail node, dummy node, and I realized that like, because I for a second I thought that we are updating their locations. I mean, when we add a new node or discard the node, basically the head and tail gets updated. So like, I mean, they are like a pointers, but the value in those pointers will change. But actually it doesn't isolate, as far as I understand. They don't change. What we do when we are inserting an element, we are basically using their addresses, right? For example, this is tail, right? When we want to insert a new node between the last node and between tail, we basically assign the tails prev as the new node and the new nodes next as the tail, right? Yeah, and also these last nodes next should be our node, right? Because we insert an element there, and that last node prev is still same. Yes, all right. Yeah, we basically update this. So could you please clarify on that, and we can skip evaluate my findings, and we can skip to the next one. But I really love the idea of having a dummy node to use them as address, as a lighthouse, right? As an address, we are using them. They will show us where to insert, where to remove, right? Because when our size will overflow, that will overflow basically. For example, we will remove from the last, so but we should define the last. So define is last, is maybe like defined by our head, right? But I still don't understand head and tail convention, but you are telling me that we can pick either name, either convention, but we should stick to it, right? Teach me some basic data questions, please. I will give 100 points. If you subscribe our channel, like we can create some let's say private lessons, right? We can do that. We can do that. I can prepare some notes. Yeah, we can do stuff like that. But the best way coding Bora is understanding neat code 150. The questions there are amazing. Understanding them takes some time. Like the thing I can suggest is, like, after learning a topic or a question, please review it frequently. Like each week, spend some time reviewing, because I haven't done and I kept forgetting it. Now I review them basically. Like we can discuss it. Problem is, don't have a job. Like, yeah, I totally understand, man. I totally understand, man. I will create some notes coding Bara, and I will share them on my website soon, and we can discuss about them. All right, we will actually, even today I can start doing that. I will actually, on my YouTube as well, I will prepare some YouTube shorts, let's say in 1 minute, in 2 minutes, um, like a compact and summarized version of them with animations, with colors. That's gonna be amazing. They are gonna be amazing. I will prepare those stuff, but first I should create a desktop application so that I can basically take a screenshot, record my screen, record like a short YouTube short size videos, because currently it is kind of hard because I have one OBS instance and I should start the next one and pick the correct profile and start it, stop it, and maybe pause it. Those stuff is kind of hard, but if I create a desktop application, then that would be seamless, I hope. So now currently I'm in preparing for interviews. I'm preparing for interviews. How to get a job? Like, LinkedIn is kinda helping. LinkedIn is a good place to hunt for jobs, actually. Done all three. LRU cache 18 minutes. Structure recalled well. Eviction. The node stores its key move variable. Review on. Alright. New node created. Boundary sentinels. Your lighthouse pattern. With 5 instances, LRU dummies, remove and prehead, quick sorts, oh my gosh, prefix sums leading 0, accumulator inits, oh my gosh, guys. The sentinels never move, clarification. The head and tail is declared convention rule, and a recognition rule for spotting it on new problems. The 2 fresh for rusty, 1 gap, next problem, alright. Let's continue with. Oh my gosh, I love this question. I love this question. The next question is this, but let me rest for a few minutes. I will larp till they give me job. What do you mean? Rest up, and quiz is cute. Clock starts fresh when you say ready. Alright. While we are, studying this, let me also. You don't know LARP? No. I don't know. I don't know. Let's see. What does LARPing mean? A form of interactive, collaborative storytelling where the participants physically act out their characters' actions in a fictional setting. Faking it or pretending to someone you are not. Hmm. Interesting. Why is everyone LARPing? To be something they are not. Oh, like in 2026, like I'm trying to not give suggestions, right, and recommendations. So I don't I don't have a comment on this, all right? Let's see, let's see. It's a meme, all right. So now I want to have a light desktop application. You can use Rust, a desktop application to following case. I am currently streaming on Twitch, by the way, right? And I stream frequently, and I stream for long hours. But during the streams, there are some times that I want to record my screen and to upload it to YouTube for that specific part. For example, I want to create lots of YouTube shorts, lots of many of them. So, but for that, like I have another OBS instance, right, with dedicated WebSocket. So this application, um, like basically we can set, right, we can set some WebSockets, and when I start this application, I want to see large square buttons, right? For example, for it can be for my the primary OBS or the other OBS, right? Or we also have um, some commands. You can check our commands. Like we have some OBS and OBS shorts commands. My goal is making like a recording for, and also in the secondary OBS, like we have some profiles, all right? For example, like a full screen profile and like a YouTube Shorts profile. So I want to use this for specifying which OBS I want to record, and after that which profile. So it should be seamless, all right? I don't want to click anywhere. So I want to dedicate one button, and after clicking on them, basically should start the recording. Basically, all right. Um, yeah, like a recording start recording with the correct profile. For example, like we can create some like a button for, let's say, record a YouTube short and record the full screen video, basically, right? We can have dedicated buttons, and actually most of the time, most probably we don't use our primary WebSocket, primary OBS, but instead like this is this secondary. Maybe most probably we're going to use it because most of the time I'm live on Twitch, right? So sometimes OBS can get crash, and I don't want to risk it. So basically I will use the secondary OBS to record YouTube shorts and like a important points. For example, I like we have discussed about the lead code question, and like I've seen some connections about the like a boundary sentinels. For example, um, I want to create a YouTube short about it, right? So could you please create a desktop application for that, and make sure you use a nice, very nice a desktop application as well. So in this application, um, I should be able to select the OBS, like if OBS, which OBS, right? And then I want these buttons. Yes, actually, I have enabled 90 seconds protection. I suppose. I guess you are talking about that thing that prevents bots to come to your chat and typing, right? Yeah, yeah. I have enabled it. Enabled it. And also, you may ask me clarifying questions as well. Yeah, yeah. Because without it coding bara, they come and they add some, messages. No, not that. If you're, oh, yeah, yeah. I see. I have enabled it, and on top of that, on my OBS, I'm using relays. So in case my electricity got, um, got cut off. No. Um, in case my electricity is gone, right, or my internet, if there is a problem with my internet connection, even that happens, still I will be on stream, but it will show you some relay saying that internet connection got lost, reconnecting. So even though I turn my laptop off, the stream will continue. Where I live, there are too much electricity. All right, all right. You should use relays. Use OBS relays on your VPS. I guess you have VPS, right? Do you have VPS? Which Rust GUI stack should the app use? Same stack. Zero web starts instantly. Lightest option, but UI looks more. No, no. When you click record you record YouTube short and record OBS, and isn't running, or is it wrong proof? What should happen? App launches the recorded OBS with the right profile, or switches in place, waits until ready, then starts recording. One click, record even from cold. Nice. App switches profile, starts recording only when the OBS record is already running. Alright. What window style do you want? Small, always on top panel. Compact floating back with the right balance. Stays above other windows, so it's one glance click away midstream. Where should project live? Efficiency. Alright. But you have understood this correctly, right? I have main OBS like a by default WebSocket port, and the other instance I want to use the other one. So, and also currently I am live onto it, so don't make it any change on my default OBS basically. No, it's physical, which I convert into server. All right, all right. Oh, all right. Then you won't be able to use it. You need a VPS server in another country. Or in the same country, but in a central place. I have one in Germany. So when my electricity or internet got issue, the stream is coming from there. As I said, I don't have a job there. I can't buy such thing. I will try to get job in 2-3 months. I live with my parents. Man, it sucks. Yeah, I totally get that. I also live with my parents. Luckily, they support me, and I am trying to do my best to learn faster and better. Yeah, but we'll get there. We'll get there eventually. Is it Hudson? No, actually, it is from Hostinger. But I will switch to some, domestic VPSs because it is expensive. And I've seen some, cheaper options for VPS, and like I want to create some games, and for those games I will use some domestic VPS options. Domestic. Let's see our friends from Twitch and who is live. Do we have Hitway is kicking hard? Let's see. Let me check our friends. How old are you? I am 29. I'm 29. How about you? We will continue with these and queens, man. Around 20. You are too young, so how do you manage? How do you plan to get a job? Like, did you graduate from college? I mean, college takes 4 years, so I suppose, right? You are very right, young. And is create. No support. I will learn. What do you mean? What do you mean? What do you mean? Maybe I can share you what I mean. We can love together. All right. Yeah. Share it. Let's start that counter, that timer. Come on. We will do it. Oh my gosh. Out of 50, we've done 7. Because we have spent more time, you know. We have spent more time than we planned. But we will do it. We will do it. 3 sentences. Like the thing I remember, actually, guys, how would it look like if I am on foot? Would it look terrible? Let me put this here, right? How about this, guys? Because sitting is like sitting for a long hours. Like, oh my god, it's light over here. I'm like an Iron Man. All right. So, oh my gosh, it's taking. How about I'm on foot, you know? The thing I remember from this question is that like we have like rows and columns, and in each row we will make a choice, right? We will make a choice, and we have 4 columns to choose. So we will basically create a decision tree, right? We will create a decision tree, right? And each node will represent the current choice on the current row and column, right? In the current cell. And we, after making a choice, so each of these nodes will mean a choice, right? So after After making a choice, we will go one level deeper, right? One level deeper. So and after going down one level deeper, we like we should change some of our basically state values. By state I mean the arguments we have in our function. All right. What defines our state, right? um, because as we go one level deeper, something change. What is that something? That something could be like we should have array, right? Array of what? Array of, because we maybe array or set, because we should basically know where we placed our queen. All right, this is quite important, where we placed our queen, because if we are in the same row, right? For example, we went one level deeper and we are now at level row 1, right? If there is a queen in the same row, we should basically prune like this. This is called pruning, right? We should basically skip making a choice on that address. All right. Yeah, so for that we need to distinguish, we need to understand if we have a queen in that row or not. So I should find a way to understand if there is something in that column and row as well, which actually there was a question where we had something similar to our, I guess it was Sudoku problem, right? Try this. I will try this. I will try this coding for. Let me first finish this. All right. I'm sharing this. Don't give me any hint, but I just want to show the thought process in the current time. After this message, I will recur. I will send you another message. All right. So after going one level deeper, now in our state, like in our argument, we should share this set. All right. In that set, we should know we should know we should know the current state of, like, an accumulated state of our previous choices, basically, right? We should know where the other queens are. But now I'm thinking of, I mean, which data structure I should use to detect, to store those decisions, basically, right? Because in each level we have 4 different choices actually, but we should prune them, basically. And as we go one level deeper in our set, we will have more of queens, right? And for example, we can add a guard, right? If we have like in our set, if we have a queen in that address, but how am I supposed to use our row and column values to decide if basically there is a queen in the same set. All right, so maybe we should have, like, if our board is 4 by 4, maybe we should create like a maybe 4 different sets, and four different sets for rows, and for columns 8 different sets in total. And we also should know, we should also handle the diagonals. But since we have solved a question where instead of creating different, like a huge number of sets, we were using keys, right? Maybe we can try creating those keys to locate which set we are in, and maybe as a key, maybe we can use row and column variables. For example, when column is 0, it may represent, it can represent the set 0, column 0 sets, column 0 sets. But I guess here, column 0 sets, like, do we need to create those sets, or still we can use a key? Like, this is the part I want to remember. So anyway, let's assume we have a data structure that we hold our queens, and we can understand if there is a queen in that column or row or diagonal. If there is no such a thing, we, like, in a for loop, we should basically explore. Like, I really love the term explore. Come on. In this for loop, we should basically try exploring placing a queen at the um, at the current address, at the current row and column, basically. So I guess we need a nested for loops to basically place queens, and also we should explore so we basically iterate on our board row by row, right? So in each row we have, let's say, 4 different places to basically explore. After placing in a row, we should go one level deeper. But if we have like a nested for loops, how can I go one level deeper? Actually, we can't. So that's why we will have a single for loop, and that for loop will iterate through our columns. That's the amazing realization, right? Because I thought we had nested for loops, but actually we don't. So we will have like a single for loop, and inside of it we will have a for loop, and using that for loop we will explore each cell in the current row, and also we need to do some pruning. Maybe inside this for loop, maybe we can add a if statement, right? If if that place is not suitable for us, right? If suitable, if not suitable, we should skip that cell. All right. Um, yeah. So inside this function, this is where we're gonna store our raw values. Um, to define our state, we need rows because yes, in each row we have four things to discover. When we go one level deeper, we again run this for loop to discover each of these. So for loop will start from 0 again, and it will check if we can put a, a queen. And then also, does the question ask if it is valid? I mean, that question doesn't ask if it is valid um, board, right? It is asking how many um, different possible combinations we can create with the current table, right? Um, so, and also then it means we should have a place to count when we place the last queen. This is what I remember. I also love the term registered. It is building nice. Recall was rich. The single loop plus recursion realization was structural hard, and you got it yourself. For corrections reveals to finish the picture, then straight the code. You don't need to. You don't need row sets at all. The recursion level is the row. So func row places exactly one queen in that row. So two queens can never share a row by construction. That's the bucket-free guarantee. The shape of the recursion enforces the constraint. You only guard columns and diagonals. We don't need to guard the rows. Alright, this is what it means actually. It is trying to show us basically. We don't need to guard basically rows because by using our function, the way our function behaves is already covering this case. The keys you half remembered. This is the star move. Um, every square on a diagonal shares the same row. Yeah. Like I couldn't remember this part basically, right? Every diagonal shares the same row minus column. Every square on a bottom diagonal shares the same. I'm back. Welcome, coding baron. Row plus column. Yes, this is actually what I was trying to remember. Did I miss something? No. Like I'm still studying on this problem, and I will check your link out soon. All right. So 3 sets total, cos diagonal. All right. So row minus column. Anna Froggy Princess redeemed drink water. Oh my gosh, thank you, man. Appreciate it, man. Appreciate it. Thank you. So basically we need to come up with this row minus column and row plus column basically, right? So diagonals. So but we have this in valid Sudoku as well. In valid Sudoku, we had something like a row divided by 3 plus row column divided by 3 plus the current value, and we were using it for key. All right. Here, on the other hand, we are using row and columns for defining the identity of our diagonals. All right. I certainly believe that in code forces there are lots of questions about this. So to define diagonal, let's see how we can do this, and let's see how we are doing this basically. So this is row 0, row 1, row 2, row 3, right? So for example, for this diagonal, right, and also they also have a special name for them, right? For this, for example, for this diagonal, right, basically we cannot like place a queen if there is a queen in this diagonal. How do you define this diagonal? So this diagonal can, like, we should look at the similarity, right? The pattern we have here is basically row is 0, column is 0, right? And look at this cell, right? It is row 1 and column 1. All right, this one is row 2 and column 2, and here we say like a row 3 and a column 3, right? So what can we say about it? So maybe we can say that if the if the row and column values is same, no, actually we can not define this diagonal now. For us to define this diagonal, we should maybe also look at this. So how about this diagonal? In this diagonal, we have like a row 0, column 1, here row 1, column 2, here row 2, column 3. But in the previous diagonal, it was like they were same, row 0, column 0, basically row 0, column 0, no, row 1, column 1, row 2, column 2, row 3, column 3. I don't know how we can come up with, but if we come up with this idea, but if we sum them up, like this gives 0 and this gives 2 and this gives 4, this gives 6. How about the second diagonal? When we sum 1, 3, 5. Actually, guys, the thing is not sum but subtract, all right? Because when we subtract, then we will get distinct values for this type of diagonal. How? Let me show you how. For example, if you subtract row and column, this will give 0, and when we subtract them, again 0, and when we subtract them, again 0, when we subtract these row and columns, again 0, then we say that, oh, that's amazing, I subtract and all of them they are giving basically 0, right? Then I can call it this specific diagonal with this angle, with this type. We can basically distinguish it with 0. How about the second diagonal? So let's actually, is it row minus column or column minus row? Let's do column minus row, all right? This will, let me use another color. This will give 1 and this will give another one, and this will give one. So we can say that this diagonal with this type, all of the cells here are giving 1. So maybe this diagonal can be represented by 1. Alright, how about these two? Let's see. Row is 0, column is 2, row is 1, column is 3. So as you guessed it right, the difference is 2 here, and the difference is again 2. Alright, so and here the difference will be like a 3. Alright, so we like a 0, 1, 2, and 3. But how about this diagonal? Row 1, column 1. Yeah, at some point we will hit negatives, because this give us -1, and most probably this will give us -2, and this will give us -3, right? So from -3 to +3, we have these diagonals. -3, -2, -1, 0, 1, 2, 3. All right. We have like a distinct numbers for each diagonal. So we literally created a formula basically using rows and columns, right? If we like a you know, if you do this, just reverse this. All right, if we apply row minus column, we will get from +3 to -3, and we're gonna get those diagonals, and we can use these numbers basically like 3, 2, 1, 0, 1, 2, 3. Do we have 7 diagonal really? 1, 2, 3. Yes, 1, 2, 3, 4, 1, 2, 3. Yes, we have 7. So we can use this formula to, you know, distinguish these diagonals. How about the other diagonal? Oh my gosh, if I if I try to draw, most probably it will have the same logic basically. I don't wanna basically, you know, type it down, but we will they most probably, what was the formula? Row plus column. So if we apply row plus column, then we will most probably we will get like a distinct numbers for those diagonals. But which numbers? Let's see. I mean, they share overlapping numbers, so maybe we need two sets, right? And not set actually, maybe hash map, right? No, maybe set. Yeah, we can use set. We can say that set at let's say row minus column, right? No. Yeah. So for example, for this is for diagonals, and if we add one queen, then we since we won't able to add any other queen, we can say that if there is a value at this address, then don't add basically, right? This is for diagonal. How about the column? So for columns, let's say this is set diagonal and this is set column, and for column I guess it is easy. We have like a 0, 1, 2, 3 columns, right? 0, 1, 2, 3 columns, and we can literally add the column. Maybe this set is like holding like a boolean, and we set it to true. So and to check if there is a queen there in this address or not, we can basically check if Yeah, because when we are adding an element for the second time, this set will throw an error, right? And we can set it like this. Yeah, we can use it like this. So this is for column, this is for diagonal. This is what I remember, and I wanna see it now. Now type it. Base case statement the piece you. Oh, you never said undo. I didn't think. Yeah, so the undo step will be exactly for here. I mean here, where. Oh my gosh. Actually we have it right. We have this here. So like after adding this q, I mean this. Oh my gosh. The q. Oh, how do you come on? Um, after like exploring these right different levels, now we should go back and we should basically remove. Oh my gosh, what is that? Are we still solving? Yes, we are still solving. um Basically we should remove it, right? Yes, coding bara, we are still solving. Oh, we have lost. Anyway, we need to move it to right, so basically we should remove it, remove the previous choice here and put it here. All right. um So again, in our notes, add that we have skipped the implementation, and in the meantime, I was, drawing our table and trying to understand the row minus column formula. Basically, I figured for row minus column formula, we are literally having distinct numbers if we subtract them. So we can say that if there is, if we can create a set, and if for example in if in this diagonal set, if there is a number, if there is, it is true, for example, if um, set dot get, for example, 2 is true, then we say that there is a queen in that diagonal. So we can literally use their numbers. All right. um yeah, so I figured the meaning of that, and we can wrap up. I didn't mention about the undo because I had it in my mind, because it was kind of easy for me to see. In each row, after making, like after a method returns, like after our function returns inside the for loop, we should remove it, because we are using shared resource, which is I guess temporary array, right? Because we are using it to fill and unfill basically, right? Again and again. And when we add the last queue, then actually then we should, no, we should increase the counter, right? We should increase the counter, because I was thinking that yesterday we had similar situation, and I was storing this temporary array in a result, like a list of integer array. And there I figured that since I was storing the reference of the temporary array, then in a result we would get like a zero, because we are basically fooling and undoing basically, in this temporary array. So it doesn't matter if we are putting this, but in this question we don't need to return the basically n queens state, right? Combination basically. And instead we should return a number. So after the last successful addition on the last row, basically we can add a base case and we can increase the counter. So this is all I remember. Update our node, add that we have skipped the implementation. In the next time I will do the basic implementation. Yeah, coding bara, I was we were still, you know solving this, and now I can check what you have just shared. Let's see. Every coder in 20. I have no technical ability. Are you being paid for the confidence that I have in my taste? My ability to express what I yeah, yeah, definitely. It's funny, yes, like this is how I feel exactly coding para. I love this my ability to express what I feel. Definitely, man. I think it's happening in 2026. Leak glimpse of the future. AI does the code, we just talk ideas, yes. It can be true for real, yes. But why all the commands is like a short? It looks like a they are bought or something like that. Let's see what we have on our Twitter, man. HTTP server, rate limiting visualizer, file upload system. Like we should build them. We should build them. Let me even save them. Don't waste 2 years learning code. The man who built Cloud Code tells you what to learn instead. Uh, like let's save it for. Actually, we should also try this looping. Maybe guys, I can use it in my one of my project. I don't prompt Cloud anymore. Oh, that's like we should understand this loop, guys.
Something like that.
Every day.
Every day. Yeah.
Good God.
I
100% written by Quad
I don't hear it.
code. I have not edited it.
Yeah, why? Because this is black hole. Oh my gosh. Alright. Like we will check this out, man. What is this loop and what yeah. The man who built Cloud tells you want to learn instead. What to learn instead of coding writing code is writing code is the old job. Building loops is the new one. Watch it, then build your own loop with the guide below. Loops matter more than code. Yeah, like we should be able to orchestrate our basically AIs better. Like loops in my list. Just to see with my own eyes. Before any framework, he built nice. Skip TensorFlow at first, write yourself at the lowest level, then pick up the framework once you know what's under the hood. Loop engineering. We should cover these guys. Modern software developer is coming along nicely, and the AI coding world has changed a lot since last September. Yes, this is the where cloud started basically doing very well. Even before that, it was doing well, but after this point, it started catching its mistakes early, fixing them, and also fixing the prompter. Like um, I was oh my gosh, I was giving a prompt basically, right? Um, I was giving a prompt, and in that prompt, I may want to, I may want something basically wrong, and it started fixing the prompt as well. So fixing its ambiguities. It was great. So we should also build LLM architecture, man. How to become LLM engineer? Let's see. Let's Actually, like it. Best YouTube channels to crack tech interviews in 2026. Mock interviews. Um, no, man. What does it say? Software engineers after building the AI that's replacing software developers. Yeah, man. Like we are coding so fast then that how to pivot to hardware as a software engineer. Stop thinking in abstractions, start thinking in electrons. Write code, now make it move a motor, send data, now read noise from real sensor. Your clean functions meet messy reality. Signals drift, latency matters, physics doesn't forgive. Yeah. So you adapt, learn circuits, control to power, learn interfaces, learn constraints. You don't leave software, you ground it in the real world. Very nice, very nice. Be honest, guys. Is it which one will you get hired? Hybrid, guys. The solution is always hybrid. The solution is always hybrid. Competitive programming in Python. That's nice. What is this? NVIDIA open sourced a 600 million model that transcribes body language in real time. That's faster than you can blink across Mandarin, Arabic, Hindi, Portuguese, Tagalog, whatever from a single checkpoint. Japanese politician says Muslims should not be buried in Japan. Yes, we know that. We could never build pyramids even with today's tools. Look at this, man. It carries the, you know, this metallic structure. Like in today's world, guys, almost, oh my gosh, what is that? Almost everything seems doable. Atterbuck CEO Dario Amodei could be obsolete in 1 year. AI could wipe out all white collar jobs. AI could create 20% unemployment rate. Within the next 5 years, there will be no software engineers, no lawyers, no consultants, financial professionals. It's already been 1 year since he made this statement. If you have to describe him only one word, what would it be? Um, yeah, man. Like, I mean, AI is typing code, and it is getting better and better. And I suppose, uh, yeah, we should behave carefully. We should know what to study, what to learn very carefully. People making all types of arguments quicker and easier and cheaper can hire more heads to get more done, but it also requires less people to build the necessities. On the other hand, personal relationships and connections are always going to be desired and needed. This is what we have, guys, in our streams. We have real human connection. We can build, we can achieve, we can basically set a goal together. This is what is valuable in this AI era, because writing code gets cheaper and cheaper. Is already capable of writing? Yes. The head count definitely reduce soon. Of course, man, of course. Yeah. Leading the workshop worth more than $1,000. All right. Let's save it for later. What is this? Anyway, let's continue, guys. Twitter is good. Lead code is better. Maybe I can turn this a little lower. All right. Everything seems fine. So where were we? Next problem. 2 fresh, 5 rusty, 1 gap. Let's hope. Let's hope. Oh my gosh, guys, we are at question 19. We are crushing it, guys. Rotting oranges. Oh my. So, um, the next question is this, and let me also update our marker. Like, I should definitely find a way to add these markers better. All right. Next question is this. So let's see what we remember. Yeah. Um. Yeah, I think. Yeah, maybe after the break. 3 sentences, then code the pattern. And why this problem forces that pattern over plain DFS? What goes into queue? Minutes 0, and how you count the minutes. So the thing I remember from this question, actually, when I try, I mean, when I think of basically graphs, actually, this is the first question that comes to my mind. All right. Why? Because at the same time, like let's say 1 minute passes, right? So let's say we have, let's say, 5 different rotten oranges, all right? And as time goes by, we basically affect, basically change their neighbors, but all the 5 rotten oranges, all right? So for that, we need a queue, right? We need a queue, and this is how BFS basically works. And but you asked a valuable question. You asked that why it is different than DFS. Why? Because DFS, like, I mean, this is like, this question is basically created for the BFS, right? Why? Because we have many things, and as time goes by, right, we will have more things to process basically. So, but we need to, like, the thing is, the crucial part is, we basically need to process those newcomers, right? In newcomers at the same time. So this is literally the case. This is literally the case why we need to have like a queue system. And the way queue works is basically like we start our queue by adding the, you know, all the rotten oranges we have, right? We basically fill it up, and in the for loop we basically pop it, right? Pop it and add its neighbors, right? Because our rotten oranges affects its neighbors. We basically pop, and we basically add its neighbors back into the queue, right? And we are gonna do this pop. We're gonna do this pop operation for every element we have in our queue. All right. This is what I remember, but apart from that, there are some implementation details, like how do we understand it is rotten orange, and how do we basically detect our neighbors, what do we do for basically edges, right? we have a music. Maybe I can increase. All right, this is now better. Yeah, wonderful. How do I look in the camera like that? 3 minutes. All right. Get past, multi-source, BFS, recalled, clean, seed the queue. Seed. Yes, this the term we need to use is basically seed. Yes, seed the queue. Right. The queue with every rotten orange at minute 0, spread in ways. Yes, yes. I really love this idea. Spread in ways. And your why not DFS answer is the right one. DFS would let one orange's road run 10 minutes deep. Yeah, that's a good explanation for distinguishing our DFS with BFS. BFS is the only shape that respects simultaneity. Oh my gosh, this is the first time I see this word, but this looks amazing. The wavefront is the clock. Oh, that's nice. Your implementation details are exactly the 3 moves of this problem, so reconstruct them in code. Self vocabulary is given by the grid. Yeah, so like 2 is rotten. All right, we know that. 1 is fresh, 0 is empty. Marking fresh orange. Yes, marking fresh orange rotten in the grid itself is your visited set. Yeah. So we have this visited set, right? Actually, we are using. Oh, thank you for the lurk, Anna Frogi Princess. Thank you for the lurk, man. Um, thank you for the lurk. So basically, like we have this visited set idea in many questions, guys. In many questions, like in DPs, in greedies, in almost every question. All right. Your implementation, yes. So all right. So marking a fresh orange rotten in the grid itself is your visited set. No extra structure. So neighbors. So here it says neighbors. The integer, like a two-dimensional array, right? Yeah. So this direction. So we are basically using this this direction in other questions as well, right? So like a 1 0 means 1 row below. 0 1 means 1 row up, like a down, up, and right and left, up and down, right and left. No, down and up, right and left, stuff like that. It doesn't matter, but we basically discover all of directions. The order does not matter. And the bounce guard, yes, this is actually what I meant with the edges. Basically, you have written this shape before. Yeah, all right. So the star move, all right, like the cloud started using this many times. Star move in our history. So the star move counting minutes without stamping every orange. How do you know? Actually, the other thing I remembered is that basically there will be some oranges, right? There will be some oranges that that won't be able to harm or rot any of its neighbors because there is none of them. I mean, there is no basically like a fresh tomato around this cell, right? The star move, counting minutes without stamping every orange. How do you know when 1 minute ends? Actually, we can know this by consuming all the elements in our queue. We have elements in our queue, right? And to basically route all the elements neighbors, we can basically hello brother, welcome in. We guessed yeah. We guessed yeah. Welcome in, bro. Um, what? All right. Come on. It didn't work, I suppose. Welcome. How are you doing, man? We are solving this question actually. Which question? Rotten tomatoes. Yeah, rotting oranges. Yeah, this problem, rotting oranges problem. Very good, very good. How are you? I'm doing man. I'm doing good. I'm doing good. Like I'm reviewing my notes on lead code. I want them to be fresh in my mind. So I dedicated today for the reviewing. How about you? What are you working on? What are you working on? And why didn't my Apex command work? I created this command, but um, come on, interesting. I will. Yes, now it worked. All right, interesting. Um, yeah. So like we have these directions, and we're gonna look, and it asks, how do you know when 1 minute ends? So we basically after basically routing every neighbor, right? And basically, yeah. So in the for loop, the basically endpoint, like the time, how many times that for loop will run is determined by the size of the current queue. So by the end of using all of the oranges, right, routing, I mean when it ends, we basically know 1 minute pass. I'm doing great. Currently trying Codex a bit and thinking of how to use it in my current workflow. By the way, where are you from? I'm from Turkey, man. I'm from Turkey. I live in Istanbul. Yeah. And also today, Matikus, nasılsın? İyiyim, sen nasılsın? Teşekkür ederim. Teşekkür ederim. Matikus, today I realized that my weekly limits resetted. So like Codex and like Cloud, the ChatGPT and Cloud Anthropic competes very very seriously, and I'm quite happy about it. And I will build some apps. Yeah, they reset Sona exactly like because it was like a 50. Like I had used my almost like a 55% of my weekly limits. I was thinking that what I'm gonna do on this Sunday, right? Because on Sunday I plan to have like a long stream. I was sad, and now today I like I've seen this and I feel happy about it. But most of the time you use Cloud, right, in your workflow. Like I have tried basically Codex very long ago, basically. I guess it is much better now. It functions much better now, right? I got tired, all right, sitting on my chair, and now I thought, why not I walk around? Um, so, and by the way, this is our tank. You can feed your fish. Oh my gosh, you can feed your fish. What I currently like about Codex is that it's implementing so impressively fast. Interesting. Way faster than Cloud, but yeah, I mainly use Cloud. Interesting. Like, have you ever tried loops? I haven't basically tried it yet, but I really like. I will try it in my next project actually, because loops are basically, I mean, it's gonna be, it makes our prompting easier. So we will set a goal basically, and it will manage to basically create which prompts, and it will handle it it will handle creating this project by itself. Loops like this one. I haven't tried it, and I wonder how it functions really. And it is good that now we have our like a weekly limits resetted. So I will definitely try it. Yeah. So you said how can I understand 1 minute pass? Actually, in our queue, as we basically consume, as our for loop ends, it will mean that 1 minute pass, because during that 1 minute we basic in our for loop we will try to route every neighbor, every neighbor of every rotten node in our queue, right? So when that queue is processed completely, then we will say that 1 minute passed. So this is kind of easy. Like if we understand the queue, if we understand the BFS, then it is much easier, yeah. And while routing others, since we are adding new rotten nodes, new rotten nodes into our back of our queue, in the next iteration, basically, we will process them in our for loop, right? And one end game question you recall skipped. When the queue empties, yes. How do you know whether to return? Yeah, so that's another question, actually, yeah. So actually, you asked a very nice question, like the end game question. After processing all the elements in our queue, I guess you're asking this, right? I think you're asking the following. So after processing all the rows in our queue, how are we gonna manage to basically just start it again, right? I guess in the BFS, actually we are inside a while loop, and that while loop will solve us, because that while loop is checking the size of our queue constantly. So we have a for loop inside the while loop. While loop condition is if there is an element inside the queue, run it and continue. So basically, until there is no element in our queue, this loop will continue. And in our for loop, we are basically processing each element in our queue. And before running this for loop, we basically check the size of our queue, right? This is basically the definition of BFS. There is nothing too, special about it. BFS, like concept, must be created for this. For solving this problem, basically. And also, is there something I'm missing? Because I want to continue to next problem. And you may add that we haven't completed the implementation. Maybe in our next pass we will do it. Okay, first I need to go to the playground with Junior and get some groceries. All right. Hope you're still, yeah, online later. I'll stay in lurk. Take care of my fish. Okay. See you, man. See you. Thank you. Thank you for stopping by, Matikus. Thank you. Take care. Take care. Um, Choose. Choose. Choose. Take care. Thank you for stopping by. Take care and choose. I guess I, missed the path, but yeah, you can understand. Thank you for the lurk. Um, yeah, so let's see. Our next question will be, guys, Mark 21. But it's all right. We know this question, and it shouldn't take that much of time. Locked Rusty. All of the questions we have solved today is like a marked Rusty, guys. Core was clean and fast, but plus -1 endgame had to be revealed, and the implementation is deferred to next pass. Opening with the fresh counter and off by 1. All right. The next question is this. It is not off by 1, but well, it's Sudoku, right? We have solved this. We have solved this earlier, and this shouldn't take long. All right, valid Sudoku. You name dropped. Let's get rid of the suggestion. You name dropped this wandering and queens keys instead of many sets. Yes. So the bar is high. 3 sentences, then code. What you are checking: the data structures and the star. How one key encodes. All right, all right. So in this question, when I try to solve this question first, I thought of creating many basically sets, right? Because let's say we have like a 9 rows, like a 9 columns and 9 rows. So for each of them, I thought maybe we should create a standalone dedicated set, but we don't need that because that would cost us some space. Since we are an engineer, we should optimize it, right? So what we do instead, we basically create a set, like a maybe like a set that contains strings, right? And we're gonna decode those rows and columns and the internal areas using some keys. So the smart thing about this is how are we gonna create those keys? It's all about generating a string, right? Our keys is I mean, they have like a string format, string type. So basically, for example, like a row, like we used row value as a string, like for example, row can be 0. We should use row, and that's it, I suppose. Like if like actually, yes, I'm thinking how we can create that key. Let me think. Like in this string, we should have the basically like a row value, right? We should have it. So what I mean here is basically, come on, um, like a set, like a string as key, right? And we will generate a key. That key will be, for example, hold row, right? Like a row value, and then what? We should have something more. So we basically have like a 9 by 9 board, and we should distinguish each row, right? Because in each row we should, yes. So in each row, the rule basically says in each row you can have the same number ones, right, in each row, and you can have same number in the column ones. So we should enforce. So I guess I remember we should enforce the rules of Sudoku basically. And for generating key, like this is the smart way, like this is the star move. So basically we should create that key using the row number and the value. All right, because I was thinking, why do we need the value? But actually the question enforces us that. So we're gonna have row value, we're gonna have the value, basically value at that index, right? And in that cell. So row value plus value in that is gonna generate the key for that number basic in that row. For example, if the row is 2 and if the value is 5, the 25 is gonna be the key for us to understand. In row 2, we have value 5. So in case, like while we are processing, if in the same row, for example, R, if we have another value with the same value 5, then we're gonna make a request. In our to our set. Maybe we can use like a get, right? Set.get. If it returns something, then we can return false, right? So for columns, it is same. For column key, like we can call it like a key 2 or a key column. we will use same approach, the index of column and the value of value we have in that cell. And when it comes to small areas, we have another smart move, and maybe we, as you call it, another star move. That another smart move, guys, is basically how can we distinguish those small areas. By small areas, I mean 3 by 3 subsections. Not snowboard, since our board is like a 9 by 9, right? We have like a 9 number of 3 by 3 subsections, right? And so we need to distinguish them. We need to generate key for them, so that when we are trying to add the same number in the same number in the same like a sub area, then it will basically throw error or something like that, right? Or false, return false. So the other thing that is star is that how can we distinguish those small areas, which is like a 3 by 3, right? We should generate a formula for them too. So basically, since I remember, it is kind of easy, but maybe when I solve a new question, well, actually it is like a basic arithmetic, right? So for example, for the first small area, like it is like for the rows 0, 1, and 2, and the columns 0, 1, 2, it feels like we should generate like a 0, right? So basically the formula is like a row divided by 3 plus column by divided by 3 plus, like we are appending, basically like it is string, plus the value nums I. So basically the structure we have is having a nested for loops, iterating through each cells and basically checking the validity of our board. And we're going to do this, and if we don't return any false value, then after this outer for loop we can return true. So inside the nested for loop, if we encounter anything bad, we can immediately like return false, and outside of this outer for loop, basically if we don't return false, we can return true. Like this is the way, this is the early escape, early return, right? Yeah, so I remember we have an if condition where basically set dot at the key row, or set dot at key column, or set dot at mini columns. If either of them returns false, we return false. And basically another thing we need to know about the set method is it returns false, I suppose, right? Or true, I don't know. What does it return when we try adding a number that it already has? What does it return? All right, so we can close this question after Cloud answers to us. I really got tired sitting on this chair. All right, like it's quite comfortable, but like after 6 hours it becomes harder and harder to sit, because your back starts hurting actually, and it's not good for health as well. So that's why I'm standing right now. Let's see. Let's see, guys. Let's see. Let's have some colonia. Go 6 lines, and this one closes inside the cap. Oh, it really wanted us to implement. Actually, I feel kind of tired, and I just want to complete the first pass for all the questions of these 50. So I wanna remember all the core logics, and maybe like implement some of the implementation details. you can add that we have skipped the implementation detail, because I kind of know like nested for loops, like using set. So wrap up, save our note, and I will share the next question's name. All right, guys, this is gonna be good. This is gonna be good. I guess you can hear me very well, right? So let's also check what our YouTube friends. That's amazing, guys. On YouTube, we have exactly 0 concurrent views and 0 chat rate, which is amazing, guys. And and also 2 views, and they watch 2 minutes. That's amazing, guys. This means we're gonna basically concur, not concur. Yeah, concurrent, like we're gonna do some good on YouTube as well, right? That's what I mean. So again, guys, this is another question that is marked as rusty, but let's hope for the best. That's not an issue for us. We will make it fresh, guys. Like among those 10 questions, two of them are fresh, 70 of them is rusty, and one is gap, meaning we should, I should study it more. While Sudoku, yes. So, oh my gosh, this, like, actually this is not too hard, like the lowest common ancestor. Like for this one, we may need to, the next question is this. For this one, I may need to basically draw, I may need to do some drawings, but I feel kind of tired, so let's see. How about this mirror? We have a mirror in our camera angle. So let's see. So about the lowest common ancestor, guys, what do I remember? So basically there are some nodes, all right. All right. There are 2 famous versions with different solutions. Which one is in your 50? In my 50, the quest, oh my gosh, we have is, I guess it is, yeah. All right. It is this one. Oh my gosh, my neck. All right, recall. Plain binary tree, no binary search tree ordering to lean on. All right. Example 3, rooted at 3, lowest common ancestor. A node may be its own ancestor. Core logic from memory. Actually, we may activate a new mark because at this moment I feel a bit tired, and remembering this question from memory is kind of hard because I'm on foot right now. Actually, I may draw on this part, right? So because I don't wanna draw on the computer, right? So maybe even better, guys, even better. I can move my table over here, right? And very nice. All right. So the thing I remember. Yeah. All right. The thing I remember in this question, how do we understand if we share in this question, maybe the core part is how do we exactly understand, right? How do we exactly understand if two nodes share, if two nodes basically, right, they share, I mean, we need an information bubbling up, like a coming from bottom, right, coming from our children. So this is what makes this like a post order, right? Because we need that information coming up from our children. So um, but what kind of information and how this information will pass to us, basically we're gonna basically call like a function, right? Function, we're gonna call function left, we're gonna call function right. Amazing. What do we expect them to return, basically, right? Let's say x and y. So I guess this the return type of this recursive function is like integer, right? um, or was it node? What was the question asking actually? Does it? Oh, actually, I guess it wants us to bring or fetch the node. Which node? Um, which node? The basic, the common ancestor, right? Yeah. So its value, I suppose, not itself, but the common ancestor's value. So then our recursive function should basically return nodes, right? Not the values, but nodes. So they can return, um, like I remember like a P and Q. Um, so the important thing is we need to be, like, we need an information, like that information should be like I have P, like yes, I have P in this subtree, right? Or Q, it doesn't matter. Let's say our child should tell us that I have Q in me, right? I have the other node in me. So in our function, we can say that if those children return, if both of them returned that returned something, right? Return what? Can it be 0? Can it be 1? Or anything other than other than null, right? Um, if both of the children returns any value rather than null, we should return I am LCS, right? Lowest common, not LCS, LCA. But the thing I remember from this question is that, like, we should keep the number of variables we have low as possible, because, like, I think this is the thing with lead code and the algorithms in general. We keep our number of variables as low as possible. Why? I don't know, but for example, the thing I'm trying to get is that, like, we shouldn't need to create another state for indicating yes, I am LCA, because this is what I remember from this question. The thing I'm trying to basically remember is like I'm familiar with the post order traversal, right? And like we expect an information coming from our children, right? But I'm thinking that what should they return? Like most probably they should return like I have P, right? I have Q, right? Like we need those informations. And for a node to be a LCA, actually this is one case, right? Yeah. So maybe like another case, maybe like a node, like a left node again. and maybe that has that information, right? Maybe this has this LCA information. So we should bubble this information up. But how should we define this information? Don't give me any hints, just save the progress with the elapsed time. Actually, this is all about defining state. How do we define the state, right? By state, I mean I remember there was a three question where we defined like a three states, like a 0, 1, 2, and each based on those, like based on the answers coming from our children with those states, we are processing and we are coming up with a like a derivation, right? Like an idea, like a new state. Floors, yours, whenever you are ready. So the thing I'm trying to remember is that, for example, there was a like a thing with most cameras. Like there was a three question where we had states like a 0, 1, 2, and each of them was representing like a node with like a neighbor, like a node that is not in the area of camera, or node is not has a camera, like in that, like with most cameras, like if you check it you will find it. This question reminded me of that question actually. Why? Because here, for example, how am I supposed to like state that I am LCA, or this is the LCA? Oh, actually we don't basically return a string, like a string label as LCA, right? We don't create like a new LCA and we don't return it, but instead we should embed, we should integrate that information, the existence of a node in the return value of a recursion, right? If a method returns something other than null, then it means it has P. But the question asks that lowest common ancestor, and we are expected to return that node. I don't understand it. Like, does this mean we can return P, we can return Q, and maybe we can return the LCA node, right? LCA node as well. But for example, there can be a case where from its left child it returns the LCA node, but on its right it returns null basically, right? And also, like, I realized that if we find like a LCA in a subtree, from our right subtree, it is guaranteed that we will get null basically, right? This is another observation. It's been 8 minutes. All right. What else we can say? Like I'm trying to also, let me add a marker, right? Which marker? What was the name of this question again? LCA marker as LCA. All right. So the thing I'm trying to remember is that how do we state, how do we create, how do we represent that we found as LCA. But the thing I remember is that based on the value, basically, if it doesn't have a value, like if it is null, then it doesn't have P or Q or the LCA node. But if it has P, we should delegate it, we should promote it, we should bubble it up, right? We should transfer. So if the current node has P inside it, right? Basically, we can return it, right? We can return it. But how about if it has q? Like, we should return q. But what if it has p and q inside of it? I mean, how can we represent that information, right? It has p or q. Maybe we can maybe check if it is p or if it is q, or if it is not null and some another value like a. I don't understand. So now, actually, I'm trying to basically understand how I can represent those states, because if, for example, our function basically traverse, right? When it finds a node with p, right? Should it return p right away without continuing traversing? But that it can find q inside its children, right? So when we find a p, like, we shouldn't return immediately, but we should continue discovering. So let's say we have a function, right? And let's say that function basically expects answer from its left child and right child, and based on that it will decide on what to return. So if either of them is holding a value, it should return x, right? Either of them. But if let's say left child and right child returns q, then what should we return? Actually, p and q is here, they are basically a value, like value, right? For example, 3 and 5. And we should return, for example, 2 if 2 is the common ancestor. For 2 to be common ancestor, it needs these signals. Yes, signals. But, like, for example, in a container with most water question, I need to, like, there were 4 different cases, and I need to think all of them. I need to basically think all of them, right? Do I need to do the same thing in this question as well? I mean, like, a different cases, but the feel I have is that I shouldn't need to do that, because this is a recursion, right? I don't need to do case analysis, right? I don't need to do case analysis. So but which cases I should care about? Like, should I need to draw those different type of trees, like different cases? Because the tree I'm looking at is like basically like a node, like a root node, and like it has like a left child and right child, right? And left child has its subtree and right child is its own subtree. And but the thing is, from left child the p signal comes, and from right child the q signal comes. And since it has both signals, and it returns the current node, for example. So this is one question. And another question is that maybe we can return like a p or q, or this third thing like a other than q, but other than p and q, but a value like a non-null value. So maybe we can build our logic on top of that. What do you say about it? What do you say about it? Yeah. So it's been some time. So I will let AI to decide what to do now, because we should basically skip. And I couldn't remember the state definition basically. Like, although I have studied this question, like I solved this question many times, it's quite strange, man. Also, like a neat code also said the same thing. I mean, you like we say that like we learned, we understand the question, and after some time when we try to solve it again, basically we can't. So like it should mean it means that we should review questions that we have solved frequently. After some time, they will stick. They will stick. But in early phase, even though once you, I mean, you feel, I mean, you understand it, right? Um, you may say, I don't get it now. After some time, so it means that in early phases, in early stage of lead code, we should, you know, dedicate more time for reviewing. Let's see. Let's see. Oh, we have here micro. Let's say hi to him. Which other friends we have? All right. All right. Let's continue. Let's continue. Log Rusty review is the 5-liner code plus explaining why stopping at a font node is safe. Stopping at a font node. What does it mean, man? Stopping at a font node is safe. Next. Actually, here I wanna ask this. Like, we reviewed basically, but still I don't know how to basically solve this question. So do you think that maybe you should show the answer to me, right? At least how do we define our states? Maybe we should do this. What do you say? Or because next time we remember, for example, in 3 days, next time we solve this question, I mean, then next time I try to solve this question, again, I will get stuck at the same position basically, right? What do you suggest? Should we continue to the next question? I mean, I'm talking about the current question, all right? How can we make it more effective? You may stop worrying about timing for this question for now, actually. We will continue with the next question, but what I mean is that for the next review session, how can we make it more effective? This is what I'm asking. This is what I'm telling, actually. Follower, we reached 130 follower goal, man. Oh, thank you for the follow, man. Popcorn Antics, welcome in. Thank you for the follow. we have reached the goal, man. Thank you. Let's press enter and let's see what it will say. Thank you for the follow, man. We are solving lead code algorithm problems, and it's going it's going great. All right, it's not going great, but eventually it will start going great. Honest answer, you just did the most effective thing possible. You told me the reveal didn't stick. The ledger has a lane for exactly this. And I mislabeled the row. Rusty means revealed and reconstructed. What you are describing, I was stuck at the same spot in 3 days. This definition of a gap, conceptual hole that a 15-minute review can't fill and shouldn't try to. Gap problems don't go back into review. They get a full lead code sprint session, 30 minutes. Yeah, all right. The ledger has a lane for exactly this. I mislabeled, yeah. 30 unhurried minutes to derive it, not to remember it. Reclassifying noun. And here's a seed that sprint should start from because this problem is surprise your buckets again. Ask ask any ask of any node where can P and Q possibly live relative to me. For buckets, exhaustive. Ask any code where can P and Q possibly live. Both in both in left subtree. Basically, guys, it seems that we need to basically do the case analysis. Yes, I guess the reason why I missed this question is, I mean, this time is that I haven't done case analysis, and the reason why I reviewed the container with most water question easily is that it's because I have done the case analysis in that question. So I guess these three questions also require us to basically do the case analysis phase. Both in my left subtree, yes. The LCA is down left. My answer is whatever left returns. Both in my right, split across my two sides. They meet at me. I am the I am the legend. I am the LCA. One of them is me. I feel like the reason why I couldn't come up with the solution here is that um, basically I haven't done any case analysis because, for example, in container with most water problem, since I know like there is only one case that may give us any better result, this sticked me. But although I have studied this problem earlier, right? Because this is my first rodeo, right? This is not my first time I'm solving this. I have spent at least 3 hours for this question. At least 3 hours for this question. So, but still, I couldn't manage to remember. So it means that I didn't internalize. But in that time, I thought I internalized it. But the thing is, the more fundamental thing about this question is like this three question requires us to do case analysis, right? Because there are some greedy problems that we need to do case analysis, but there are some others that we don't need to do case analysis, right? Maybe like a maybe one or two case analysis. But for example, container with most water question requires us to basically analyze 4 different cases. And also, this question also requires us to do case analysis. But especially in tree topic, I don't see many questions that requires us to case analysis, right? Um, because basically it is recursive most of the time. For example, like a linked list problems as well. Like they don't require us to do case analysis that frequent. But this question specifically it is really requiring us to it really requires us to do case analysis because by looking at those, I mean by basically by evaluating those different cases, then we may see what we need basically more clearer, right? What do you say about that? And also, can you please add this into our notes? And also, do we need to update our skill? What do you say about that? I mean, because you got this as rusty, but it was not rusty because I didn't basically I couldn't remember the essential parts, like the fundamental parts, right? For the questions that I remember fundamental parts, even though I may miss some implementation details, but um, maybe even I remember some of the implementation details, but I didn't type the code. But we can call them rusty, but for the questions that I don't basically remember, I cannot remember the fundamentals, so we should mark them as gap. So do we have something to update in our skill in this sense? Let's see if we have or if we don't. Let's press answer. I said skill and it understands SQL. I need more Colonia, man. Your diagnosis is sharp. It deserves all three things you asked for. First, the inside itself sharpened one notch. Why three problems usually don't need case analysis and why this one does. In most tree recursion, the return value has one meaning. Oh, yes, this is why. The reverse list had the subtree's height. So trust the call. Yes, exactly. Trust the call. Exactly. I really love this idea. So, oh my gosh. Let me. Actually, it is kind of full. So let me put it there. Right. Trust the call. Like this is basically the essential part of recursion. Trust the call is the whole game, no cases. But in LCA and binary tree cameras, the return value is multi-stage message. And also there is another question where another tree question where we basically like don't use the return value of our recursive function. Like we don't return basically, but we are using and we are storing it somewhere to basically create our answer. And that question is, guys, I mean, should be I don't know, but we can find. I can ask AI. Nothing, one answer, yes. So nothing, one or 0, 1, 2. The moment a return value needs more than one meaning, you cannot skip the case analysis. The case table is the solution. The code is just its compression. That's the recognition rule. Single meaning return. Single meaning return. Trust and go. Multi-meaning return. Enumerate the cases first or you'll drown. Your 3 hours went into memorizing the compressed artifacts, the 5-liner. Without ever opening the table, it compresses, which is why it evaporates. Yes. Internalization isn't ours. It's whether you own the question that regenerates the answer. Fresh fundamentals, moves clean, rusty, fundamentals recalled, implementation shaky skipped. Fundamentals needed revealed, no matter how commonly the reveal went on. One N is the pass on today's rows under the new rule. Quick sort is borderline. The Lomuto mechanism arguably fundamentals needed the revealed, and you never type the partition. Yeah. I would rebuild it from suppose the word. Alright, next question. Actually, now I want you to bring me the other 3 questions that resembles to this question, because there I remember a 3 question where the return value of our function is not the answer, right? But we were processing it and maybe storing its answer on somewhere. What was that question? Like this, I mean, our question, our current three questions reminded me of that three question, but what was the name of it? Let's read um, the explanation we have above. Why three problems usually don't need case analysis? This is a good observation. Yeah, so this one, yes. Both in my left subtree, my answer is whatever left returns. Both in my right mirror, split across my two sides, they meet at me, I'm the SEA. One of them is me, the other is somewhere below. I'm my own ancestor. Yeah, so because three lines are these four buckets collapsed, 3 and 4 both return node, 1 and 2 return 1 and 2 are the pass up line. You don't memorize the contract, you rederive it from where can they live. That's the question you can ask, you can always ask, even stack code. Yes, exactly. So we should be able to ask these actually, because answering them will lead us to basically coming up with the solution, right? Because I didn't decode this as like a case analysis question, because without doing this case analysis, there is no way for us to basically internalize this. And I have spent, considerable amount of time for this question, but I guess this is what I need. So, all right. This diameter of binet, yes, I suppose, yes. Almost certainly the one you are remembering, and it has two heavier siblings. Binary maximum path and the longest univalue path. All three share the exact shape you described. Returns one thing to the parent. Yeah, so the best straight arm going down. The answer is computed and stored on the side. Answer is max left arm and right arm plus the node. The band through the node. So why the split? Alright, so let me take a screenshot of these. I can also add some colors. Similar questions. Why the split exists? Here, the connection to your own framework. A parent can only extend a straight arm, never a bend path. A path that already turned at my child is closed. Going, what do you say, man? If diameter is on your 50, this connection just did half its review. Next question. Let's take a screenshot of this part as well. We can check this too. And now, since now I know that I should basically cover all of these cases, from our left child, we can have an answer, right? Like our left child can have both of these. Our right child can have both of these. Our basically we can have one on the node, and we can receive a signal from either left or right. This is another case. What was the fourth one? What was? Let me also. What was the fourth one? One of them is me. Yeah. Split across. All right. Split across. All right. Both of them can come from left. Both of them can come from right. We can get one from left, one from right, and we are the LCA. Or we can have Q or P, right? And answer the signal comes from either left or right child. All right, but how about now? So actually, we can dedicate a bit more time on this problem, and then we can solve that question. All right, because I remember one of my friends was solving that question, and I thought, like, does my function need to return a height or true or false? And I realized that we are using integer value to decide on that. So if at the end our function, like first call of our recursive function, basically, if it returns a value rather than 0 or -1, I don't know, it means that, oh, actually it was balanced. It was balanced. Can you please add this information in our documentations? Basic. The question I mean is, I meant is balanced binary tree, because there we are integrating the information of balance or not in the same integer, that is height. We are using the same number for two different purposes. Yeah, add this information, connection information. That question was actually, balanced binary, and we were using the height information. If a node returns something other than -1, then it means it is basically balanced. Exactly right. Just to balance binary, and your one sentence summary of its trick is precise. One integer, two jobs. Function returns the height, but the value -1 is repurposed as a poison sentinel, meaning something below is already unbalanced. It has to be -1, not 0. All right. The poison propagates instantly. If either child returns -1, you return -1 without even computing your own height. The failure serves to the root untouched. Your LCA, yeah. The final answer is comparison, not the value. Yeah, so the family portrait gains its fourth row, saving the whole table now. Next question. Actually, before we continue with the next question, I basically want to understand how we should decode this information, right? I mean, we have done case, and also in our documentation, can you also please indicate that we should give some time for how to understand a question requires us to do case analysis, because earlier in our chat you said that there is a state that will hint us basically to do case analysis, right? Because you said, like, without case analysis we cannot do this. So I want this information. And for our question, common ancestor problem, after we have done this case analysis, so now what should we do? how can we integrate, how can we decode those numbers basically, right? um, like what should we return, what does I mean, what should our recursive function, what should our recursive function return, like a p or q's or any value or null. um, we have different cases. I can understand that. I can understand that. But how should I design my solution basically? Like, should I create different if conditions saying that if, for example, like since we are applying like a post order traversal, should we add different if conditions saying that if we have like an answer coming from, I mean, like a left hand child, actually this if condition may only cover this actually, right? Because other states should be integrated in the return value of of our children. What I mean is that, for example, we said that a child can return the information of, I mean, after we have done the case analysis, we said that a child can return basically like I have p and q, right? So so and we said that, right child, for example, can return this, and also we said that we may have p, for example, right? And our children, one of our children can return q. So, like, should we create like a different if statements or something? But I still don't see, and I still don't see how we can integrate this information into our return statements. And also, for example, in balanced, we were using the same return value for different roles. And also, I remember that like, like there are some three questions where we basically don't use the return value right away. Could you please basically teach me, all right? I really want to basically fully grasp this. And also, like, to be able to solve this question, we need to do this case analysis, right? Like, even after doing the case analysis, I still don't see basically how should we integrate these informations into our return value. Let's see. Let's see, guys. I really want to understand this. This is worth the time. Let's fully build it from case table to code with the decode question answered head on. And yes, does this problem require case analysis checkpoint goes into documentation? Yeah. What can a subtree possibly contain? What can a subtree? All right. For any node subtree, exactly four possibilities regarding P and Q. Neither. What should ride up, bubble up? Nothing. Nothing here information. Nothing here signal. Just P or just Q. Found this one. All right. Both. All right. And they meet deeper down. What does this mean? Both. Yeah, so we have them in deeper area, but deeper levels. The answer is already crowned. Here it is. What? Oh, all right. Yeah, yeah. We literally have these cases. Step two, the encoding decision. Your actual question. We get one three note return value to carry all of that assign. Nothing means null. Found one that note itself. Answer crowned the SE. All right, we already I already said that like we can have P Q or the SE node as well as a third, basically like a new state. Now the objection you are circling, and it's the right objection. A tree node is just a tree node. How does the parent tell found one apart from, yes, this is exactly what I'm this is exactly actually let me take a screenshot. This is exactly what I'm asking. This is exactly what I am asking. Yes. This is exactly what I am asking. Done. Not this one. Yes. So yes. How does the parent tell found one apart from, yes, it doesn't. It doesn't. It never needs to. That's the theorem that makes this problem be beautiful. Once the LCA is crowned in one subtree, both P and Q live inside that subtree. So the other subtree is guaranteed to return. Oh my gosh. Yeah. Like actually I have thought about it for 5 seconds, right? Um, but I didn't follow that path basically. Which means the confusing combination crowned answer from the left, found one from the right cannot exist. If both sides return non-null, each side found exactly one lone target. If one side returns non-null, the parent correlation is pass it up. And that action is identical whether the non-null is a lone P or the crowned answer. Alright. We basically return non-null values and this will become our answer. Alright. I'm not even looking at the code, guys. Like the logic is the thing. But here's the interesting thing. Doing the case analysis is the key for this question, man. Even more than I assumed. Why? Because knowing or seeing that from our right, like the other subtree, we won't get and we will get none. And we are basically using our null return value quite effectively and efficiently. All right. Now I can, yeah. You may overload one return value with several meanings only when, for every place it's read. Crowned versus lone cannot co-occur across siblings. Oh my gosh. Documentation updated. One line take away to walk away with. Write the case table first. The code is just table with identical action rows. Yes. Yeah. So the thing with this question was like because I thought basically it was all recursion and I should focus on the um, the DFS part, but this is not about the DFS. Actually, DFS is part of it, not small part of it. Um, the more important part is like a drawing this um, table, right? So actually, I think the reason why I remember, the reason why I couldn't remember this question is because basically like while I was learning these three questions, since I didn't internalize the recursion idea very well, my first focus was understanding the basically how we traverse in this tree, on this tree. Um, but later, after I learned how post order and peer order works, now like I reviewing our questions, and now I realize that, for example, for this question, the like of course I am expected to know how DFS works, right? But this question is like a like knowing for this question, knowing how DFS works functions is like a maybe the first step. Like for the second, third, fourth, fifth, sixth, and like the others is mostly about doing the case and also knowing what to do. Basically what I mean is that for this problem, for example, it's all about case analysis. The code part is quite easy. The thing is, like, you should know the how DFS works, and you should know that you should apply basically case analysis. And after doing that case analysis, you should also realize that you can use that null return value to decide something, right? This is the important part. This actually in this sense, this question is, I mean, it resembles to um, basically greedy problems, because in greedy problems I remember like we are basically deriving this kind of ideas, right? um so um yeah, I guess this is why I couldn't remember this question today, because I basically um like coded this in my mind that this is all about DFS basically, and actually it is not. Like it is, the fraction of it is about basically DFS, but on top of that we should basically do this case analysis, right? Because the thing is, I was like the reason why I avoid doing case analysis is that for there are some questions that I shouldn't do case analysis. It's really like this, guys, because there are some other questions that we shouldn't do case analysis and focus on the basically decision tree, and those types is basically like a DP problems, right? And actually, for example, the place, like the one place I remember right now for not doing case analysis is basically like maybe like a coin change problem, like a dynamic programming question. Like in those questions, like you cannot basically do case analysis, right? The amount of case analysis you can do is basically limited, right? But instead you basically explore, and you should know what your function returns, and you should basically decide what we should do before calling dot function and after calling that function. This is all about that, and that's why I coded those all of most probably all of the three problems as this topic is not the thing that we do case analysis. And also another thing is that, for example, for greedy problems, I was literally like creating, like adding a lot of if statements, right? But actually for some greedy problems, it's all about you using like a min value, max value, and making an observation. So this is why I may have coded this as like a DFS basically. But actually, uh, since it is wrong, I couldn't remember this today. But I strongly believe, I genuinely, with my heart, all with my heart, I strongly believe that next time we study this problem, I will remember it, because I will know what to do. I will need to do case analysis, because after doing that case analysis and creating the table, I'll be able to remember what to do, and I will be able to derive that knowledge, that idea of okay, if they will return null. Actually, even today, fun fact, even today I remembered that thing about right child, for example, returns null if the left child has two of p and q. Basically, I I thought of it for 5 seconds and then skip because I thought this wouldn't help us at all. So that's the thing. So coding and understanding, I mean, by understanding the question, I mean, maybe like understanding what to do is quite essential, because in this question I thought the thing I need to do is basically like a DFS or something like that, like focusing on what value it returns, and basically um, processing it, because there is a question called flattened binary tree to a linked list, right? And in that question, the thing we do is basically like a trusting trust the call, yes. And I will tell Cloud this now. And for example, um in in flattened binary tree to a linked list, the thing we do basically there was like a trust call approach, right? Um, After our function returns, we say that it flattened that part, and now what should we do with its return type, right? It also resembles to reverse linked list problem. So we call like a not we call our function with dot next, and we basically imagine that it be basically returned it basically inverted, right, reverted all the nodes. But in this tree question, it's not about that, all right? So can we also save this? Hello, Dumpy Don. Welcome in, man. Welcome in. I'm basically yeah. Welcome in, man. Yeah. So like I was solving lowest common ancestor. Let me. I was solving this, and like I spent um I remember I spent like a 5 hours. I hate any problems. I remember I have spent 5 hours studying this question, and I remember at the end I said that, oh, now I see, I understand. But today, when I was reviewing this question, my favorite is graphs. Yeah, graphs is also quite helpful. You basically translate things into graph and you solve that graph. So today, while I was trying to remember review this question, like I couldn't remember basic, and I realized that I need to do case analysis. Yes, case analysis. um yeah, that's case analysis, and knowing how to decode the return value, how to integrate the information into return value, basically. So yeah. um I hate tree problems and linked list. No, I don't hate them, but um this is the best diagnosis you have made all day. It explains the gap better than anything. Recall doesn't retrieve problems, it retrieves index cards. And you filled LCA under the wrong card. Yes. When you first studied it, your bottleneck was traversal itself. So the card got labeled DFS problem, but DFS is this problem's prerequisite, exactly, not its identity. Maybe step of one of six, as you put it. Yes. Its identity is case analysis plus decode the null. 3 hours of study filled under the wrong label is why today returned nothing, exactly. You search DFS, and the DFS drawer genuinely had nothing special in it, exactly. This is how I feel. And your refilling taxonomy is worth keeping, exactly as you said it. Trust the call problems. Flatten, yes. Reverse list is coin change. Know case table. Know the contract, decide what to do. before after the call. Your flattened connection is exact. It flattened that part. Now what I do with it is pure. What is this, man? What is this sign? Pure trust. Case analysis problem. Um, case analysis problems. LCA cameras container um, happens with trees. Most of tree problems have specific way only to solve. Also, to visualize recursion tree in mind is hard, and almost everybody never tries to write the tree on paper. While graph is easy to visualize in mind only and multiple approaches. It's interesting. I see graph is a bit harder. I see graph as harder one. Um, because I didn't solve lots of graph problems, but it is in my to do, so I will solve it. No, no. I see a camera's content. Yes, yes. The table is the solution. Code. Oh my! I just love this. I will help you become it. That would be awesome, man. That would be awesome. And I can also help you with linked lists and trees. I really enjoy drawing the decision tree on these. Um, basically, I can share my insight. Basically, um, I hope it can help you. Whenever you practice, all right, all right. I appreciate it, man. I appreciate it. Like my first goal is to basically review these questions that I have solved earlier, and then doing neat code 150, and then I will feel happy, all right. And then I will feel happy, and then I will focus on the code forces div 3 first 2 or 3 questions. I will practice some of them, and then I will say that, all right, I know enough. Now I can, attack other problems. Thank you, man. Thank you. I appreciate it. I have a sorted list of grab problem and list of concepts. Amazing, amazing. I also plan to create a website for us, basically, right? Where we basically share our documents and our insights. I am thinking like a community website. I will build it. I will build it. All right. That's your old rule, tree recursion, no case analysis, was a reasonable overgeneralization from real experience. It just needs 5 trigger as its exception clause. The moment the return value means more than one thing, the table comes out. And the fun fact deserves its own skyline. Today you derived the code theorem yourself. If the left child holds both, the right returns null, held it for 5 seconds, and throw it away as useless. Yes. That observation was the entire lock mechanism. The lesson and observation about guarantee structure, what can and cannot co-occur, is never useless. Park it in the table and ask, alright. So, yeah, so I really love this part. I really loved what you stated here. Do we have this in our notes as well? I really loved this, drive basically. Like basic in degree problems, DFS, BFS, multi-sort BFS, 0-1 BFS, cycle in graphs, topological sort, shorted path algorithms, Dijkstra, Prim's Kruskal, DSU, union find, and few more. 7 problems on it. I have a list and everything in mind. Wonderful, man. Wonderful. That's it. That is exactly what I'm doing with these actually. I need them to be in my mind, fresh, ready to pop up basically. Let me. Good for you, man. Good for you. Um, let me basically say what you just oopsie, what you just save it. Yeah, yeah. Oh, this one. All right. I will also save it. Um, let me save the link. And also let me open that one. Let's see what that is. And also that. All right. This is a private list. If it is a private list, it may be because I didn't sign in. Let me copy. Oh, Dumpydon. Graph 150. Nice. Save. Very nice. Multi-source BFS. 01 BFS is cool and I find it very useful while many sources and others leave. This picture you're seeing. This is a Turkish pilot. Oh. F-16. Yeah, it must be wow, that's nice, that's nice. Solo Turk. I will share YouTube. Yeah, share it. It must be Solo Turk, right? Wow, that's nice. Oh, thank you for the follow. Teheye for RC, I spoke right. THY for RC. Welcome. Thank you for the follow. I really appreciate it. Welcome. Hello, welcome, man. Welcome. Thank you. Arc, all right. The arc, all right. 4 is arc. Thank you for explaining. If you like, you can add fish into our aquarium, right? Using fish command, and we can see your fish in our aquarium, basically, if you like. T arc, the arc, the I arc. You can run a fish command and we can see your fish in our aquarium, basically. I love fishing and I fish in IRL too. Used to for hobby. Use exclamation mark as well. Use this as well. We have angelfish. We have angelfish in our aquarium. Damn, angelfish. Yes. Angelfish. Yes. We have lots of fish in our aquarium. You can also follow me, and we can follow your. Like I'm discuss. I don't know this type, but it looks very cute. This is the last fish I added. Back from Jim, my friend. Welcome, man. Welcome in. Welcome back again. Welcome back. I also love fishing. Arc. Let me say arc. I also love fishing, and I love animals generally. I love birds. I love fish. They are lovely creatures. Yeah. You can also feed your fish arc, and you can hunt others as well. After reaching a certain point, you are able to hunt others if you are large enough. I pet cat at gym. Oh, nice. I haven't fished for a while. I was on internship. Oh, I see. And 3 sets of pet curling cat. What did you learn? This is why I saw Jack. And the 3 sets of pet curling cat. This is why I saw Jack. Alright. Like it's been a while I have visited gym. But going to gym is good. Yeah. Alright. I should also change the level of this. Alright, it must be better. What did we type? It lives on both places. Yes. All right. Next question. AI doesn't get tired, guys. It constantly want us to continue. Looking for internship, man. I'm 20. To be honest, I never applied anywhere. Same 22. Um, 7 days plan. And the next question is, guys. Oh my gosh, guys, this is another hard problem. DP2 table match diagonal plus one, match branch and mismatch branch. Oh my gosh, what do I remember? Oh, X. I think I remember. No, do I remember this question? I don't remember this question. I don't even remember the question itself. Let's see, let's see, let's see the question itself, man. If there is a no common subsequence, for example, ACE is a subsequence of subsequence. We need to look for subsequence. A common subsequence of two strings is yeah. We are gonna have two. All right. We will have two pointers, right? And basically, one of them will be on text one, and one of the other one is will be on text two. Then we will check if they are equal or not. Yeah, and we should explore moving each of them basically. I kind of remember it, and I should draw basically the decision tree. I kind of remember it. I kind of remember it. um so guys, it's been a while since we anywhere job market is good, guys. Make connections, and having connections is quite important, like being a good communicator, having good connections. Like that's why the college helps, because you have your friends, like you have your professors and something. So it really helps. um so let me have a break, guys. It's been a while since we have, actually it's been most probably 5 hours. I finished my bachelor's. Nice, nice, very nice, very nice arc. 9 hour. Yeah. Like from the last break, it's been 5 hours. So I will have my dinner, and we will like I will come back and we will continue, guys. Yeah, we will continue with this problem. Okie dokie, man. Perfecto. Muco perfecto. We will continue with this problem. Um, because I really wanna understand. And also you can enjoy our tank, guys. Um, Take care, my friend. You too, man. You too. We'll be back in most probably 40 minutes, guys. I will have my dinner and I wanna exercise, but you can enjoy our tank. You can hunt others. You can feed your fish. See you after the break. We are back, I suppose, guys. Let me run. We are back. Let me start my fans. Alright. I also charge this battery power bank. I had my dinner. I exercised a little bit. And now, guys, it's time for us to basically continue studying, alright? Let me handle one thing first. Let's see which friends we have. Alright. Let's continue, guys. Longest common subsequence. Alright. What are we gonna do with this question? So the thing I remember. Welcome back. Thank you. The thing I remember from this question is we're gonna have like a 2 pointers, alright? Let me first actually, like, we can take a screenshot of this part. We're gonna have 2 pointers, and our goal is to find the longest subsequent, right? And like we will have like a text 1 and text 2 and A, B, C, D, E. Alright, so we're gonna have our like a pointers, right? And they will compare them. Compare if they are equal. So we need actually, like, we have like some different cases, right? So for example, one case is like they may have equal. So when they are equal, what they may need to do? What do we need to do? And also, like, the thing I remember, guys, is about cases and about buckets is that about like in house number problem, we basically like we had like a different cases, right? First one, like the first case was like we could rob the last house, right? And the other case was we don't rob the last house. So for those, like, we have same recurrence relation. We have same recurrence relation, but and also we apply it for like 2 different cases, and we are taking the maximum of it. Yeah, but actually it's not only single recurrence relationship, I suppose. Let me ask this to Cloud as well. Before moving on, in house robber problem, basically I remember that we like you said that we don't have like a multiple recurrence relation, but we have only one recurrence relationship, and we are basically using it to create like 2 different buckets, right? Yeah, actually now I see now, because I was gonna say that we like the fi definition is not, I mean, may not be our recurrence relationship, but actually it is, because we literally defined fi using our sub problems, and like we have like 2 buckets, and in one of them we also use the value, and in other we only have the sub problem itself. Yeah, like I was questioning this, and I guess I answered myself. So can we add also this insight into our notes? Is everything all right? We are back. Um, yeah. So we will continue with yeah, lowest common subsequence. Let's see. Almost the small correction is itself worth saving because we brushed against an important separation. There are two layers, and keeping them apart is what lets you debug. The definition of F is a question in plain words. Best loot over the first I plus 1 houses. No subproblems in it, no formula, just a meaning. Best loot over the first. The recurrence is the answer to that question, expressed in a smaller f's. The one equation. Derived by bucketing and pricing. So you were right to hesitate. The definition is not the recurrence. Let me write something down. The definition is not the recurrence. The recurrence is what the definition earns after you price the buckets. The definition is not the recurrence. The recurrence is what the definition earns after you price the bucket. And your observation about the two terms is exact. Bucket A carries a fixed contribution, nums I. The price of robbing house I. But bucket B is bare, same equation. Asymmetric price, that asymmetry is normal, not a smell. Why the separation matters practically? If your code produces wrong answers, you check it against definition. Does F3 really equal the best over houses 0 to 3? If you defined F by its formula, there would be nothing independent. Actually, you mentioned, like, you explained very nice actually, but I didn't understand. What should we do? Here's the do version as a literal actions on paper. Write one English sentence, no math allowed. The most money I can steal from the first. Like, why it is I plus 1? Why is it I plus, oh my gosh, I plus 1? Is it because by definition first I plus 1 means items from index 0 to I. First, we should understand this, guys. Let me also reset my timer. Exactly right. Fi covers houses at indices 0 through I. Count them. We have I plus 1 houses. All right. All right. So we include. That's a quite important thing, guys. We basically include I. So because I thought we don't include the I. Actually, I want to share a realization of me. I mean, realization with you. Um, Usually when we see like a function like a fi, for example, let's assume like a climbing stairs, right? In climbing stairs, our function I is equal to function I minus 1 plus function I minus 2, right? Um, so like usually on the left side of equation, if we see fi, then on the right side we don't have I value. But here, I mean, here how we basically state our problem is literally including that I. That's a quite important thing to know. Hello, coding para. Welcome in, man. Welcome in. Good catch. And it slots straight into vocabulary you already built today. Don't mind me. I'm always in the dark. All right, all right. Thank you, man. I appreciate. Thank you, man. Thank you. A good catch. It slots straight. I don't understand this. I'm really trying hard to understand, man. Like, but we will study and you'll understand coding Paro, right? I will prepare you YouTube shorts. I'll prepare you some videos. I'll prepare you notes. I'll prepare you like animations. Just easy, man. We will do it, man. We will do it. But also you start studying, all right? Even though you don't understand, just keep going, all right? Um. Oh, subscribe. Oh, Matikus, welcome, man. Vigestia. Thank you, man. Thank you. I appreciate it. Matikus Games. Yeah, yes, sir. Um, let me let me give you um shout out. Thank you, man. I appreciate it. Thank you, man. This really motivates me, and one makes me study more. Thank you, man. I appreciate it. So I feel quite happy about it. um, so like I will, after I make myself reach to the certain level in this lead code, like I will call you Matikus. Like I really want to build something together with you, man. Definitely. Because I set a goal and I really want to get that level. Like, and I'm not far away from it basically. Um, there are only there are only 200 questions. No, no, no. Yeah, around 200. But like if I manage to make those, yeah, no stress. All right, I appreciate it, man. Like after I manage to make those 200 questions ready, fresh and fully understood, I love to exchange knowledge. Amazing, man, amazing. um I have some game ideas. I have some productive I mean not productive, anyway, like ideas. And um in this AI era, like knowing good people is what matters basically. I really value this. So it's really good to know you. um yeah, thank you everyone. Thank you, chat. It's really good to know you are there, right? um It's a lot straight into vocabulary you already built today. Um, the right side of the recurrence has exactly two kinds of ingredients. The smaller subproblems, the remainders of the buckets. Hmm. The current elements data is this the price tag of the bucket's fixed part. We will understand this. We live. I'm pushing for 100 kilograms. That's very nice, man. That's very nice. That's a huge amount of kilograms. Climbing stairs has ingredient one only because it's a counting problem. And you already know why from this morning. In counting, the fixed part contributes to each weigh's identity, not the total. So its price tag is nothing. House rubber is a value problem. So the rope bucket's fixed part shows up as real money on the right side. Same grammar, different questions, different price tags. Your observation stated as the general rule. If i's right side may contain smaller f's and the ith element's data, but never fi itself. Yeah, the data term nums I is an input constant, not a subproblem. So no circularity. The recursion still strictly descends. If you ever see a wrong solution where fi sneaks onto its own right side, this is cycle. This is cycle. State definition. Yes, yes, exactly. I like this term, state definition. It's quite important in dynamic programming questions. State definition. So the presence or absence of a I index data term on the right tells you at a glance, is this bucket paying for something or just counting itself? The remainders of the buckets, the current elements data, the price tag. Alright, kinda understood, kinda. I kinda understood this part, and so could you also please add these findings into our notes as well? We will continue with the next problem. Longest common subsequence. The next question is this. All right. Two ingredient rule. Smaller as the current elements data. All right. Let's continue with this one. Be right back. Yes, I will design stuff. Then I will show you because I don't like so many people. All right. Longest common subsequence, and this one is a gift for today's vocabulary. Interesting. It's a 2 sequence DP, 3 sentences. The definition of F in the English sentence. What does Fij mean? The bucket question and the recurrence it earns. I mean, the thing I remember in this question is like we will have basically like a 2 pointers, right? And we will check each character, right? Like pointer 1 and pointer 2. We will check each character, and if they are same, like there is only one case for us. We should increase basically, right? It should increase our total counter. And there are two different cases, two different paths for us when we compare characters and they are different. Then we have two choices. By the way, I'm doing this from memory, all right? I don't know why this is DP, like why it is not greedy. We should have a ground for that as well. Anyway, when we have like a two different characters, the first option is like a moving the pointer one, and the second option for us to explore is moving pointer two, right? Um, and and again, as we discussed in the last question, how should we basically define our state and our recurrence relationship? Um, and also, you asked the meaning of Fij. Like actually, I'm doing this without determining the meaning of this function completely. It's also kind of strange because I guess I focus on the recursion part because I've been struggling understanding recursion for a long time, and ever since I really my primary focus is only on understanding recursive part, and then I just leave the rest. But I guess it's quite important to to be able to define the function state fully because we literally build on top of it. But um, so, for example, in this question, like on train on Marmara in Istanbul, I was on train and I realized that we don't have like a three cases. This question also taught me like a determining our cases and our recursive relationship because, for example, when we encounter like the same characters, like we don't count this as a new like a thing or thing to explore. There is one obvious choice, and it's increasing our counter and moving up our pointers one forward, right? But the other two choices, they are really a thing to explore, right? They are really choices for us to explore. Um, so let me now try to, you know, explore those two options, and I also need to think about how should I connect these. Because like I still not I'm not still quite confident about the problem definition because like in climbing stairs we literally define our problem. Like you say, since it's a counting problem, things is a little bit things are a little bit different, but for in house order problem, like the way we basically like define our fi is you know quite interesting because fi is equal to like a max value of nums I plus fi minus 1 comma fi minus 2. um welcome in. What is the practical use case of this? The longest subsequence. The practical use case of this is when in our human DNA, like understanding and basically solving the human DNA, it's too costly and computers cannot compute them basically, right? But even though you have like a low level of computer system, if you apply dynamic programming to basically analyze the human DNA, since they are only like a four different proteins, right? When the number of parameters are low, like a 3 4, the dynamic this is where dynamic programming shines. Instead of trying to create a complex algorithms, dynamic programming solves those that kind of problems quite easily and quite fast, amazingly fast. But although dynamic programming solves this kind of can solve this kind of problems very fast, it also fails on the real world problems. All right, so this algorithm has a specific case where it shines and it solves very fast, but in other case it also fails. So there is also a discussion about it. You can also check, and this is uh, my comment on this. MD Kayyum Hussein, I suppose, right? Hussein 75. Welcome in, welcome in. Like this is a dynamic program question, and this is what I know about this. All right. Fij mean. All right. So because like I mean I guess I should be familiar with, you know, I mean more confident about it, right? Because you also like define fi, right? But also we have like a recurrence relationship, right? um so I think we have like a two different things. And in our case, like there are two options to explore, so maybe I should try to define them, right, or express them. So the sub problem we will get would be, I mean, maybe like a f p1 uh, plus 1, right, because we move our pointer, yeah, and we make pointer 2 stay same. And for the other choice where we move pointer 2 is basically p1 stays same and p2 is increased, right? So, and I think our goal should be getting the maximum of them, right? Like a maximum of first option A and the second option B. Like I think since I'm doing this kind of from memory, I think yeah, like take this and give me some hints. Because like seeing this type of questions for the first time is something else, guys. All right, because since I have already I solved this question earlier, I know how to look. All right, but for example, this is a sub problem, right? Sub problem that we delegate, and this is another sub problem, and they returns, and we are getting maximum of them. And do we add like a one somewhere? Actually, we don't. I mean, we shouldn't. And we don't need to, I suppose, right? The other thing is, this is when the numbers are different. When they are equal, when they are equal, what we do, we basically delegate our subproblem like this, right? Func pointer plus one, pointer one plus one, and pointer two plus one, all right? This is when they are equal. When they are not equal, we have now two options to explore. And basically, um, we are getting the maximum. An interview, yes, as coding for says, as for interviews as well. Yes, yes, definitely. In during interviews, these are asked. These are coming up. Thank you, coding, but that's another use case. Um, so this is when they are equal. When they are not equal, we basically um, explore those two options, um, right, and get the maximum of them. A and B. All right. This is what I remember, but the thing that I'm not quite sure is like what should we return? I mean, yeah, like this is return, and if this is return and we don't add anything one, anything like one, right, to it. I guess this is what I remember. We are discovering both of these options, right? Option one, option two, right? And this is a case where we don't basically explore. um all right, this is what I have, guys. This is what I have, but I want to understand it better. I mean, delegating to sub problem. Here it is my solution, and for DP problems and for maybe like a recursive functions, but especially for DP problems, I want to understand what we expect from our subproblems. I mean, we process the current state, current situation, and somehow we expect answer from our subproblems, right? And for example, in house robber as well, like I really can easily understand that if we rob the last house, like we what do we get? Like we get the value, and the sub problem that we need to solve now is becoming like this, right? But like if I see this problem for the first time, or if I see any DP problem, I may miss that. The second thing is basically not robbing, right? Not robbing the last house. So the problem, because the problem that we need to solve is now fi minus 1. And on top of that, we are like our function basically is like a getting them and getting maximum of them. So it is like it is kind of like, it is not fully, I didn't um grasp it fully, and it, it does what I don't feel good about it. All right, I want to understand. It irritates me. Yes, I guess it all begins with the two option, right? We can rob or we don't, and we can decide robbing that house or not robbing. So actually this A represents one option and B represents the other one. But if there are options, what do we have with like a nums I plus func I minus 2? Like, what is that? Is it the definition of our option, or our choice? Is it the definition? Yes, is it the definition of our choice? Quite interesting. Let's see how many minutes passed. So today's goal was basically completing all of these 50. But maybe, guys, maybe maybe tomorrow we can do it, right? Because like we are already halfway through. That's very nice. But the thing is, we should do another pass too, right? Because for most of them, we basically skip the implementation, since I feel more confident about their in their implementation. Basically, it is easier to understand implementation. But for example, here, I mean, on house rubber, like this is our this is one of our option. This is the other, right? First thing we need to do is like realize that we have two options, two things to explore, two things. Nice, nice, nice. All right, two things to explore. Maybe I can choose this one. Two things to explore. All right. Um, when we explore the first thing, this is what we get. I mean, of course, this is what we get, but like this thing changes stuff, all right? Because it includes the sub problem itself. So this problem also has like a two options, right? Option A and option B. We have best if reading plus your Marmaray theorem. Greedy in the Greedy in the match case. Yes, greedy in the match case. DP in the mismatch. Yes. The boundary inside one problem. Two fresh, nine rusty. Actually, let me give the honest tally. Two fresh, eight rusty, two gap across 12 problems. All right. Um. All right. Cadence. Another. another. Another complicated problem, guys. Another. Let's see. I really need to limit the time. All right. Limit the amount of time I spend for each problem. And actually, today we have done, guys. Like I haven't completed this many of problems for a long time. Let's click press. All right. Maximum subarray cadence. All right. This is your glue test home, and today's constraint F. Yeah. So the bar is high. Three sentences. The sentence for Fi. Careful. Is the constraint kind? The candidates genuinely, like frankly, I really don't understand the meaning of constraint, right? But the thing I remember is here in Cadence algorithm, the problem definition is quite amazing because like a maximum summation at, I mean, ending at index I. So the meaning of this is quite crucial, all right? Because, for example, fi and fi minus 1, for example, they are really two different questions, right? Why? Because, for example, if our array, for example, if it is like a b c d, right, and our problem, I mean, if we say f3, it means like a 3 2 1 0, but f2, no, f3 this may mean this, and also it may mean um, actually let me state this like this, all right? F3 basically means A B C D or B C D or C D or D, all right? I mean, basically when we get max of them, we basically cover all of the cases and we store this knowledge. For example, the max could be um, like A B C D, right? Or C D or D. So for all of these four cases in our max we store. We don't need to know which of them. And also like this reminded me of the question of best time to buy and sell stocks, right? In that question, like we need 2 days, right? Buying day and selling day, but actually we skip the buying day by holding only min. So in this min information, we have that day, right? Instead of knowing specifically which day it is, we hold the information of minimum value, all right? The minimum value that those previous days will can give us. That's a quite important realization. And here in this question, also we also have same mentality, right? Instead of holding the information of if it is a b c d or b c d or c d or d, like we don't know that, but basically we hold the maximum value from all of these, right, from this search space. And the thing I want to say also is let's say f2, and f2 means quite different thing. it means ABC or BC or C, all right? Like none of these subproblems exist in the F3, all right? This is quite uh, this is quite a realization. And what should we do? What should we do? We know this, and it asks us maximum subarray, right? We have, let's say, an array, right? Like A, B, C, D, right? So it asks maximum subarray. So our goal, oh, actually, the reason why we apply this approach is basically, this is actually like, now I will tell you the reason why. So imagine our array, like imagine we basically process all of these numbers right here, A, B, and C, right? And let's say now it is time for processing D, right? We basically need to append this, all right? Yeah, we know that. Um, so what can we do with the best and maximum subarray that we know from actually yes, this actually what I'm trying to say is the reason why we state our problem as like ending at index I. Why did we define that? Actually, this is because how we process our items, all right? Let's say we are processing item D, right? So um, if we know, like we should know the answer from f I minus 1. And this, like we need to make sure that this subproblem includes C. This is actually why. Because if it doesn't, right? If it doesn't, let's say we ask this like a f I minus 1, right? And let's say this return us a subarray like that, right? Let's say it return. I mean, it may, like we have lots of greedy, lots of DP problems where it may return. But if it returns, then we break the contiguity. Like in the question asks like a subarray. For subarray, they should be a neighbor, right? They should be neighbor. So that's why this function should guarantee. I mean, must have to guarantee, right? Have to guarantee that basically it includes C. Our priority is basically like having C, all right? This is our priority, and on top of that, you can have like the other items as well, right? Other options, but you should basically guarantee. You have to guarantee that you have C's, right? You have C's in those subarrays. This is this is the important this is the important stuff. Because like when I read this for the first time, I thought, what the heck, man? Why do we need to like why did we feel that we need to you know basically like define like a problem like this, right? It is quite strange actually, like ending at index I, maximum summation of a subarray ending at index I. What is that, man? This is why um I actually haven't read what you have written here, but the thing I want to mention is the thing I remember from this question is that the reason why we have stated our problem basically like an ending at index I is because our subproblem has to guarantee that it includes C. I mean the previous item coming before us, before the current item. Before the current process item, subproblem should guarantee that it includes its previous neighbor, immediate neighbor. It has to guarantee that, right? So this is why we have defined this problem like this way. And now it is time for us to basically create our it is not recursive relationship, but what is let's start with evaluating our options. What options do we have when we are processing? Let's say we have like we have processed ABC, and now let's say we are processing D. What options we have? uh, Actually, for D items, for item D basic, like we can include it, or start refresh. There is no exclude option for us. We cannot, we cannot basically um, exclude it. All right, we can either start fresh, like in both of the cases, we include the current item. All right, because if we don't, then the sub the problem that we returned, right, it may fail. We may break the chain. So, but like I feel like I'm still saying this from kind of memory, kind of understand. But that's all right. That's all. This is how we learn as we solve like a different dynamic like a dynamic program questions. It will stick. So for our options for D is either like a include or append to the previous sub problem, right? Or start fresh. Like these are our options, but how do we decide which one to follow? Or I guess since we don't know which one, actually not knowing makes this problem DP, right? Because it dictates us to explore both of them, because neither of these options has priority to other, right? So in this case, basically um we should basically now it is time for us to basically create that recurrence relationship, I suppose. Let's see. So we can expand. So if the subproblem is right, if the subproblem is fi minus 1, right, and let's say we are processing I, we are processing I, and this is our problem. We can actually, what does this return? Actually, this returns us a maximum value. It is not returning the subarray, right? Um, so expanding could mean like a adding number, but this is literally integer value. Oh, we don't need to simulate the basic. We don't need to simulate which subarray we have. Actually, this is the whole idea of DP. Without storing, without knowing your array, subarray, you just know the maximum. So to calculate the maximum, yes, this is it, guys. This is our first explore, and for this is our first option. All right. Our second option is our second case. In a better put, is starting fresh. For starting fresh, literally this, man. Like we should make like we have a value, right? That value holds like a maximum we can get, right? Maximum value we can hold. So in the second case, we should basically set max value to this. In the first case, to this, and we should get the maximum of them. So basically, max 1, the first case, and two. All right, maximum of these two. All right, and also I remember that I was gonna add a add a note. I said like after saying this I will add it, but I guess it was about basically explore basically determining our options, right? Our options and our recursive relation. Yes, it was about I guess robbing house robber. What was I saying? Yeah, so two things to explore. Yeah, I have said that, and actually yes. So like we have two options, and we like basically guys, like put simple, simple put, simply put, right? There was a term like that. Simply put, we have two options. That's all, and we basically discover those options. Yeah, we discover those options, but I mean those options like on this last node. I mean on this last node we have these two options, right? But do we also calculate same for this as well? I mean, do we also type this one here, like a getting the value, delegating to pass? Like, are we doing this operation for each of the houses? That's a very good question actually. Um, let's press enter and I will ask this because it is quite important. Because like we are looking at the last node and we are thinking about our choices, right? We can rob or we don't basically, right? And for both of the options we explore, but as we explore now we we have other problems, other sub problems. So what does this mean? Actually, most probably, the answer for my question is actually no, we don't do this for all of these because the way we define our problem is already I mean the way how we defined already includes this. How? Because we say that if I, right, means um all the houses, right, from 0 to I, it says I minus 1. Why was it I minus 1? Anyway, why isn't it I? Oh, actually it is I and I minus 1. So from 0 to I, from house 0 to house I, what is the maximum amount of money that we can store? So right, the definition of I is basically this. All right. So we don't do this. We don't do like option A and option B on this one again and on this one again and on no. We do this like a option A and option B on this one, but the answer to like the for example like literally we include this like a selecting like a these like a asking this question to these houses inside our problem definition. All right, all right. Again, you rusty. Oh my gosh. The why was yours. That's the part most people never know, never own. The sweep and the compressed formula were revealed. Re-review the two variable code plus stating the sweep unprompted. Which question we were discussing? Anyway, cadence are. Oh, it was I guess cadence algorithm, but I get it now. Loop detection. All right, fast pointer and slow pointer actually. Like this is about this. Let's see how far we can go, guys. Oh my. So loop detection. Fork first, since there are two levels. Is there a cycle? Oh, for loop detection question, like we have different types. That's nice. Which is yours? Um, I don't know. I guess is there a cycle? Yeah. Which is yours? The core in three sentences. All right. If it's all right. All right. All right. Like in one of our previous questions, you asked this question again, saying that which version. In our notes, can you also save that um the other type for the previous question as well, like one of the early questions, right? Because for example, we can study like a is there a cycle problem, and during the interviews they can ask like a where it does it start. Um, so it's quite valuable to know basically, right? Each of them. All right. And for this question specifically, the thing I remember is basically like having a fast pointer and slow pointer. And also, this question also resembles to the question where we basically we were basically trying to find the node, like the last k node, right? I mean, there as well we had like a two pointers, right? And one of them was, I mean, starting, let's say, 5 steps ahead, like with the k value, and then after reaching that position they continue same, and when the phase pointer reaches to the end, right, we say that, I mean, we say that the position of the slow pointer is basically um basically um the thing we want. Chill out, bro. How long will we learn? By the way, I'm thirsty. If you are thirsty, Saron, let me fill up my um, my basically bottle of water. All right. Just give me a sec and let me fill this. All right. And let me also present it. And I am back. I am back with small amount of water, like a little amount of water, right? Let us all satisfy our thirst together. All right, Sarah. I appreciate, man. Let us do that, man. Let's do that, man. Come on. We shall perish this obstacle. Yes, let's go, man. Let's go. And recall noted. on your recall so far, fast and slow is right. For this family, why is why is it starting to turn into a tradition? Yeah, that's a very good tradition, man. That would be a very good tradition. Like drinking water, quite healthy, quite healthy, man. It's quite important and very valuable. But careful with the connection. Remove nth now is a gap two pointer. Same speed, fixed head start, and measured. Thank you for the lurk, man. Thank you for the lurk. Measured in steps. While Floyd's is a speed two pointer. Oh yeah, of course. Like one, they are same. Like they move with a fixed speed. In the other, one of the pointer when it goes like a one step and the other goes two steps. So speed, their speed is kind of different. But not kind of, but exactly. Their speed is different, guys. Still open. Fast moves two. Slow moves one. Yeah, like alright. So I think we can skip this question because like I know like this is slow and fast pointer. But the thing is about their implementation because when when is your fast pointer stop? When is your fast pointer gonna stop? Right? Because since it goes two steps at a time, it can reach to null, right? And for example, it can be inside. It can be at the last node. We can check if it is next null, then we can stop. But since it goes two step at a time, we basically actually it is not too complicated. We should check if the node dot next um, if it is null. Um, yeah, basically we should check if node.next is null or not until like while um, fast dot next isn't equal to null, it can go. And also maybe we should add this. We should connect this with the second condition of using and slow dot next. If it is not actually, yeah, if the slow's next is not equal to null, we go. If it is, then this means we are at the last node we can go. This is how far we can go. So this should be our while loop, right? Another thing, other implementation detail is that um oh, actually, how do we detect the cycle, right? um I guess the thing that like a slow and fast pointer provide us is basically if there's a cycle at one point, they will basically meet, right? So yeah, but the thing is, what do you mean by cycle? Does this, I mean, does having cycle means we don't have any node that points to null, right? Yeah. So actually, then it means that having this kind of while loop won't do any good to us, right? Then what should we do? Like running something like infinitely and waiting for, like hoping, not hoping, but eventually slow pointer and fast pointer will be on the same node, right? So, but how should we structure it? I mean, slow goes like a one step at a time, and fast goes two steps at a time, right? Which is amazing. What should be our condition? I mean, if if they are if their value same, right? If slow dot value is equal to fast value, if coding bar redeem water, oh my gosh. Thank you coding bar, thank you for the redeem, man. See, I have a solution. Yes, man, yes. If they are, I'm so smart, you are smart, man, you are so smart. If um if they are say if I mean, what kind of data structure we have, like a detection, loop detection, let's see, loop detection. i mean I know that we should use like a two slow point and yeah, so cycle means this one, all right. um, Basically there is no node pointing to null. This is what it means. But um the thing is what the thing is let me the thing is I was gonna look at their, like, actually they have value, like, but they may have like a duplicate values, right? Note that post is not passed as a parameter. Given head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following next pointer. Internally, post is used to denote the index of node that tail's next pointer is connected to. Alright, this is post. Return true if there is a cycle in the linked list, where the tail connects to the first node. Yeah, this node. By the way, thanks for the tip. I will have RTMT protocol. Yes, yes, yes, on my server. So when electricity goes off, the message will be displayed on my screen, and server can run for about 2 hours. Otherwise, I will close the stream. Yes, yes, yes. On my server. So when electricity goes off. But how do you plan? Like, I mean, when the electricity goes off, on your server, you will lose your connection as well, right? The reason why my approach is works is basically my VPS on basic in like a Germany. So when electricity goes off in my room, like the stream is coming to you from Germany, not from my home. So like this is my home, all right? And what is what this is Germany. I don't know the map of Germany. Germany, and this is world, all right? So stream is coming to you from Germany. It works on backup. All right, that's the answer. All right, if your backup electric, yeah, yeah, all right, all right. If you have backup electricity, then there is no issue with that. Of course, of course. So the thing is, like, how can we check if the slope is exactly fast? Maybe we can check their addresses, right? Backup can't handle PC, but server, yes, probably. Yes, all right, all right. But server, yes, all right, all right. Um, slow, fast. Maybe we should. I don't know, man. I also realized that in this question, I don't know how to check if our like a slow pointer and like a fast pointer lands on the same node. Like because comparing their values basically, right? The node and their value basically is not a way. I mean value at the node that they point basically, right? So because there can be like a duplicate values in the linked list. So maybe yeah, maybe we should check the addresses of those nodes because addresses of those nodes uh, don't change, right? Don't change the address, their address, the node's address is same. So, but in Java, in Java, how do we compare the addresses basically, right? And also the other thing is yeah. So like we have a slow and fast, like we are moving them endlessly, right? Like maybe we should have a while loop, like a while true, right? We should create like an endless for loop, while true, and but if there is no cycle, then this while loop will run, uh, indefinitely, right? Infinitely, infinitely. So this is not this is not a good way because if there is a cycle, if it is guaranteed, but I guess it is not guaranteed to have cycle, right? No, yeah. In the question it says if there is a cycle. So if there is no cycle, then having a while loop with true state, that could be very dangerous. But let's say we have a while loop with true state, right? And we are moving our pointers and we are checking their addresses, right? And at some point their addresses will be same. So when they are same, we can say that we can say that we have a cycle. But having a like this kind of while loop is quite dangerous. So how am I supposed to basically move our pointers many times, right? Um, and when exactly we can make sure that there is no cycle? Actually, if there is no cycle, then there must be a node that points to null, right? So in that case, the thing I said earlier is valid, right? Counts basically. Why? Because if there is no cycle, then we should check if the while, maybe yes, instead of while true, right? We can have the, the earlier the state that I stated earlier, right? So like a while slows next is not null and fasts to next is not null. Check the addresses of those pointers, and if they are same, return false and break. I mean return false. Um, Yeah, do this until you reach. All right. Edit this and continue with the next one. What do you say, chat? What do you say, chat? Let's see. It's been 11 hours. It's been 11 hours. All right. Let's see who is live on Twitch. I'm checking a stream. Let me check some stuff, guys. Let's also check YouTube and let's see what our friends from YouTube doing. They are doing great. We have we have many friends there. All right. So amended that closes loop detection for real and it ended better than it started. To exit loop, the shielding guard. All right. So let me write something down, guys. All right. The next question. All right. We also covered that, but we didn't take any note on this. But we can do this later. Heap sort. All right. We can do that. Like we covered merge sort, quick sort. How about heap sort? Right? Do we have an animation? Yes, we do. Actually, maybe we can. Maybe we can watch the animation. What do you say, chat? Should we watch the animation? What do you say, chat? Or we should um okay, review it by text. Now we know merge sort, quick sort, and now heap sort is gonna be in our head. All right. An old friend. You animated. How do you know that I have animated? That's nice. Three sentences, two phases of the algorithm. The index math that lets a flat array pretend to be a tree. And why the sort can happen in place. What do what do the what do the two ends of the array mean mid sort? I realized that I don't remember basically heap sort at all. An old friend. You animated sift down in Blender once. Three sentences. Actually, I don't remember at all. Let's check the animation, guys. All right, we have root, we have subtree, Root swap, my job done. Sift down. What's going on? We don't understand. We don't understand. And they are basically, root subtree. All right. Swap root with larger child. Like we have 2 as a root, 14 and 11, and 13, 5, 9, 7. All right. We have root and we are picking the larger child. And after changing, like these are gonna stay same, right? I mean, we swap, but they changed, right? They changed. No, no, they didn't. Like a 13 left, 5 right. Yeah, they don't change. They didn't change. All right. Um, Sub 3 is now a valid heap. I guess we are calling recursive function, so that's why it suddenly turned into a valid heap basically. But we'll get there. We'll get there. So we basically check. We basically check. We basically check what? Our children, right? And take the maximum. I mean, swap max. But why? And actually, we have an array, right? Alright, so, and actually, I have checked the animation basically, right? And I kind of remembered that we have an array, but we turn it into heap, right? And actually, we use its indices on this array to basically make those swaps, right? In the animation, there is a tree, all right, and we basically pick the larger child and we basically swap root with that child, right? And but why do we do that? Because for example in quicksort I can really say that I can really see that we have a j which is a worker um worker iterator basically, right? And its goal is to basically like a search, and the goal of I is basically like a like when we find something larger than our pivot point, right? um our goal is to basically swap I and j. Like if first we increase the value of I, and then we swap the value at index I with the value at index j. But was it like a smaller number or greater? Actually, it was smaller, right? Yes, yes, yes. So when we find something smaller than our pivot point, we basically swap, right? And our goal is to basically like push all the small elements to the left, right? Because I is like is from is stays there. I stays there left on the left side, but J moves. So when J finds something small, we swap it with I so that it goes to the left. So our goal is basically pushing smaller numbers to the left. So and the larger elements will be on the right. So and by doing that, after a single for loop, we will have like a kind of sorted, right? In a like we will have a better version of our array, right? Um, yeah. And for example, for merge sort, we call like our recursive functions, right? We basically first sort the left half and then the right half. Um, and now our goal is to basically merge them, right? Um, so like what I mean is that they are kind of making the input array better in small steps, and then basically at the end they get and we get basically fully sorted array. So especially in quicksort, swapping I and j values is quite nice, right? But how about it? How about heap sort? Do we have something similar in this sense? Let's see. Let's see. Great question. Heap sort answer is prettier than both of your examples. Interesting. Pretty. Line the three up by their unit of permanent. 11 hours, Americano. I was. Welcome, man. Welcome in. How are you? We missed you, man. How are you? Welcome in. Um, line the three up by. No, why? What? Line the three up by their unit of permanent progress. The one person pass permanently seats one element. Merge sort. One merge makes sorted runs longer. And heap sort. One extraction permanently seats one element in its final position. Feeling fine. Just woke up. What about you? I'm doing great. I'm doing great. But like I mean, without you, I mean, it was not perfect, right? By the way, you can hunt my dolphin. I made the hunting mechanism better. Uh, you you must be able to. Oh my gosh! Did you eat already? No. You ate houses discuss. All right. Not my, not my dolphin. I guess I guess you started hunting dolphin, but you somehow hunted wrong, wrong fish. Yeah. Um, one extraction permanently sits. Actually, guys, as I see this part, I feel good that you are good, man. I mean, it's good that you feel better. It ate the first one. It encountered, I think. Yes. I should most probably fix it. Yeah. It shouldn't be like that. Yeah. It should pin the correct fish. Anyway, you can hunt soon again. My lovely dolphin is now, I mean, it's gonna get hunt. Um, one extraction permanently. Actually, guys, when I read this, the thing I basically think is that like heap, like min heap, like we have min heap and max heap, right? So as we, for example, pull from our heap, right, And actually, we have also top K frequent element. This also resembles to that. Yeah, my hat be taking mood swings sometimes. Yeah, yeah. Like I hope you get better soon, man. Like, did you recover fully, or you still feel a little bit under the weather? Um, health is quite important, man. I feel you. Already better. Nice, nice, man. Muco perfecto, man. Muco perfecto, then. Already better. I'm happy, man. I'm happy. I'm grateful, man. Thanks God, man. That's good, man. That's good. It's great to have you back, man. Um, like quick source pivot, but with zero uncertainty about where. It's always the current maximum, and it always goes to the end of the heap region. I don't understand. The move itself. Heap sort version of your beloved. Thanks. Thanks. Anyway, anytime, man. Anytime. It's good to see you, man. Heap sorts version of your beloved. See ya, Americano. See ya. Chia or see ya? See ya. Ciao. Ciao. Is it ciao? Ciao. Is it ciao or see ya? Let me check. See ya or Italian.
Ciao.
Ciao, man. Oh my gosh. I have been mispronouncing it basically. Ciao, not see ya. I like pizzas, man.
Ciao. Ciao. Ciao.
Ciao. This is literally ciao. Ciao, salve.
Ciao.
Yeah, yeah. This ciao. Ni hao, Salman. Ni hao. My two favorite foods are in my name. Amigo. Konnichiwa, amigo. Buongiorno, amigo. Konnichiwa. Por favor, you know. Spasiba. Buongiorno. Greeting Chimera. Um, let's see. Where are you, Cloudy? Quick, like, all right. So, swap the root, the max, with the last element of the heap region. Shrink the region by one. Actually, you didn't read it, but thank you for the motivate, lazy lobster. Good luck, buddy. Yugoslavia. Let me write it now. Thank you for the motivation, old lazy lobster. Good luck, but thank you, man. Thank you. Um, actually, I can maybe turn this on, right? Welcome in, man. How are you doing? How are you doing? Um, swap the root max. Maybe like we may need to have an animation, guys. Mid sort. Your array is two territories. The heap on the left shrinking. A perfectly sorted suffix growing from right. One seated maximum at a time. That's also the answer to why in place. The but we are doing it in place, guys. That's a brilliant algorithm, guys. Doing something in place requires too much brain effort, basically. The heap deno deno dena dena de donates, right? Dona donates donates one slot per extraction. The sorted region moves into exactly the space vacated. The second array, oh my gosh, what are you telling me? And the swap with the larger child you remembered from the animation is the repair crew. The extraction swap dumps. He dumped me. The extraction swap dumps a small element onto the root, breaking the heap property. Sift down, walks it down. Oh my gosh. I feel quite rusty about it, and also, as you know, there is an animation like a three blue and one brown, right? So there was a like an animation library. Could you please explain things that you have explained here now with animation? Because I feel quite rusty about this heap sort. Um, I basically don't understand anything you have just said. You explained it very well, but I mean, since I feel quite rusty, so I need some animations, man. Let's go. Because also it is quite valuable, because I remember a question where I guess there was a video, like a YouTube video,
Sergeant create an animation of a fish doing
um,
fishy things.
about heap, right? I will share that video. Sergeant create an animation of a fish doing fishy things. Why I didn't hear you, man? Oh, it is because of this, but if I increase this, let me test, man. I'm having some audio issues. But now, most probably, you will hear the sound both from my microphone and also from your computer, basically, right? Um, let's test. Be careful for your ears, guys.
This is test.
Beans taste good when pork is added. Like my first setting was good, but I guess I should fix it. Fix the new um audio setting. Let me very let me create a new, actually not like this one, but um beef too, but not chickens. Yeah, like I don't prefer basically the pizza with chicken as well. Like actually, yeah, actually we have. All right, all right. Project to which, right? Go into here and also check our like OBS setting. Like, and currently I'm live on Twitch, right? Um, but we should fix this issue. For example, I want our voice command to basically. Oh, I see why. All right. This is why. Um, it is because I selected output as yes. Yes, now it should be better. Let's take this in. I like pairing it with fish more. A bit traditional, but works best in my opinion. Interesting, interesting. Come on. Let's taste it again. Yeah, but it is not too loud. Hmm. But you don't hear the sound now, right? Yeah. I can hear the music, but now you cannot hear the music. We should. All right. Like we have a diff. we have a strange case, all right? Um, Basically, when our friends run our emo when we use like an emo comment, right? I wanna hear it quite louder, all right? But currently, like even though I change our output um, sound output as computer speakers, I hear the song I am playing and also emo comment, but it is not too loud, right? I want to hear emo comment very much basic. And also the thing is, now I don't share the sound basically on my VPS. For example, I play a song on Spotify, but I don't share it on the stream. So we should fix this issue. What I want is basically being able to share the music, right? Like we have some cases for this, but we should make it more easy, actually, like easier, right? um yeah, like the priority is to hear this basically like emo comments, right? And also share the desktop audio. And also, like I may play song from like a Spotify, but it would be great if we have a dedicated thing. But maybe most probably I may need to basically download all the songs. But is it the way so that we basically like dedicate Spotify to the stream, right? But what do you suggest? Like we should basically fix this issue, all right? Um, what can we do about it? And also today when I run our like a stream start command, the output automatically changed into um what it changed into black hole, I suppose. I don't know. By the way, which which output I should pick, right? We should also update our stream start command as well, because after running I had to change the output sound fast, because otherwise it was throwing an error saying that the song the voice or sound didn't set properly. So we should clear this ambiguity, man. We should clear this ambiguity. So it created a HTML file, and let's see what we have in this heap sort. Float array pretends to be a tree, crowns its maximum, and seeds it permanently. One extraction at a time. One extraction at a time. Like we are familiar with this approach top K from top K problem, right? Press play and watch. The two territories trade ground. The address book. A heap is a complete binary tree stored in a plain array. The trick is that parent and child never hold reference to each other. Their relationship is pure arithmetic on indices. Direct the yeah, we know that like a 2i plus 1, 2i plus 2. Parent is I minus 1 divided by 2. Yeah, all right. I don't understand. The two phases plan. While big child is greater than AI. Two subtle points. This is not what I want, man. This is not I want. I want to have an animation. Like I mentioned about an animation library, but you didn't create that animation, man. I need animation. Let's see which friends we have live on Twitch. All right. Wasn't there like a YouTube channel just sorting animations like heap sort? Actually, yes, we can use it too. Let's see. That's a good suggestion, man. Let's see. Heapify. Building max. What do you understand? I think we also need to hear it. So it picks the greater one, it swaps, then recursively we heap. Does heapify mean this? I mean, we turn this into like a valid heap. Oh, we'll be able to hear the sound. Actually, no. Yes.
Example of a max heap. We'll make use of a few functions when running heap sort. First, we have build max heap. This creates a max heap from an unsorted array. We'll also use heapify.
Similar to build max heap, but assumes part of array is already sorted.
Unsorted array.
Build max heap creates max heap from unsorted array. Heapify, similar to build max heap, but assumes part of array is already sorted.
Also use heapify. This is similar to build max heap, except faster because we assume part of the array is already sorted. You'll see what I mean. One note, for this video, I'm less concerned with you knowing how these methods work, but rather that they exist and when to use them. Once you understand the basics of heap sort, you'll understand these functions from their pseudocode. Let's get started. We have the following array that we're tasked to sort. In a nutshell, we'll continuously create max heaps to find the largest item. We'll then remove that item from the heap and into a sorted partition. We'll begin by representing our array as a tree.
We start with, representing our array as tree. All right.
Simply look at the array from left to right and the tree from top to bottom.
All right, left to right, top to bottom. Okay, two, like from basically looking at this from left. All right. Okay, 2 and 8, 5 and 3, 9, 1. Yes. All right.
Now that we have a tree, let's create our first heap. We assume this is an unsorted array, so we call build max heap.
All right. So is this a max heap? Yes. So each node is bigger than their children. Its children.
Now that we have our max heap, we know the largest item, 9.
Now that we have built max heap, now we know our maximum item. Yes.
We swap 9 with the item at the end of the array, 1.
So now we are looking at both like an array representation and the three. Like we are looking at the same thing, right? We basically, uh, I think this is a better explanation. Let's check this out.
Selection sort and heap sort can look surprisingly similar, but one improvement makes heap sort way faster. Selection sort works by scanning the list to find the largest number and swapping it with the number at the end of the list. It repeats this process for the unsorted part of the list until all the numbers are in order. But this repeated scanning to find the largest number takes a lot of work, and that's what heap sort improves on. Heap sort reinterprets the list as a binary tree, where each number is a node with a left and right child. It rearranges this tree so that every parent node is greater than or equal to its children. This guarantees that the largest number is always on top. So instead of scanning, heap sort instantly finds that number, swaps it to the end of the list, and locks it in as sorted. But now the number on top is no longer the largest, so it bubbles down until the next largest number rises to the top. Heap sort repeats this process, grabbing the largest number and restoring the heap until the entire list is sorted. And this process is way more efficient than scanning the array.
So the thing I understand from this is basically we basically poll, right? Pop or poll. Let's say let's use the term poll because it is the function name in Java. So we have we have a heap, right? Max heap. Let's say this is max heap, right? And we have the maximum here, right? And we basically pop it and put it into somewhere, right? And after we basically remove, like a pull this part, our beautiful, amazing, fabulous, spectacular heap magically, right? We know the heapify rule, but it reorganizes itself and gets the new, basically, next biggest number, right? Next greatest number, next max number. And then we pop it again and we will put that here. So it will organizes it itself again and we will pull. So basically we pull again, we pull again and again and again. All right. So because our heap is a amazing data structure, it reorganizes itself in an amazing way so that every time we pull an element from its tab, right, it handles reorganizes itself, reconstructures itself, so that the next value comes to the top, which is amazing. But now I guess we should know, I don't know, its functions basically, right? Like we know the poll, but what happens after calling this one? And there was a video even. Thank you for the video, by the way, Americano. Now it's much clear to me. Um, heap data structure. Like there was a video of a of hackering. Yes, this. So who is she? Gail